Hello everyone. Welcome to this DevOps full course by Intellipaat. Cloud and DevOps are the most sought after skills expected in the IT domain right now. If you're watching this DevOps tutorial right now, in that case, chances are you're trying to switch to the cloud and DevOps domain. Or you probably are already a cloud engineer and are learning this because you want to upskill yourself to improve compensation outlook. Before understanding anything, let's understand what DevOps is. DevOps helps you speed up the time required for developing software. It automates a lot of things such as deployment, testing, configuration management, etc. According to Deloitte, right now the average productivity of a software developer stands at 30 to 40%. Organizations that adopted DevOps like Netflix, Adobe, and Accenture were able to improve these numbers significantly. Because DevOps is not a tool. Rather, it is a set of practices that can significantly enhance the productivity of an IT company. That's why 47% of the companies are putting DevOps to use, says Statista. As more and many companies are implementing DevOps practices and automating their deployment process to perform this task, they need a really good DevOps engineer. If you're planning to become a DevOps engineer, then you have landed at the right place. With this free DevOps course, we will be helping you guys understand the fundamentals of DevOps. We have made sure to align the content of this course to DevOps job descriptions and have also added some interview questions that are being asked in top IT companies. Here's what the agenda for this course looks like. We will begin with an introduction to DevOps. Then we will look into the historical software development models like Waterfall Model, Agile Methodology, etc. Then we will go through the hands-on part where we will deal with EC2 instance creation and connections, version control systems like local, centralized and distributed VCS, etc. Later, we will cover Git installation and Git commands like branching, pushing and pulling from GitHub, overview of editors and merge concepts. We will also talk about how collaborations on GitHub happens and discover some commonly asked DevOps interview questions. I hope I've made myself clear with this agenda. So without further ado, let's dive into the session.
Good. So there is one more request, team, before I get started. Whenever we're talking about some topic, team, I would request all of you to listen completely, first of all, before you putting any question on the chat window. Or everybody has to put your questions onto the chat window. Now, once I finish with the topic, then I'll read all of your questions and I'll try to answer them accordingly. Then we will move on to the next topic. So again, I request that before you putting any question, let me finish the topic completely. And then I'll give you some room where you can ask your questions on the topic we discussed. If you still have questions, we can clarify them and we will continue. And there's also one more thing, stick your questions to the topic which I'm talking, right? Which I mean to say that if I'm talking about introduction to DevOps today, this is just going to be very basic fundamental things, right? And don't ask me like, what is Docker, what is Kubernetes, what is Terraform, something like that. So technically, whatever the topic that we are talking, if you stick your questions to the topic, the session will be smooth as we are all online, right? Which is virtual things we are doing it. So it's better to move the things smoother and quicker that way. So I hope everybody would stick to that. And again, I request that to do it so we can have a great sessions going forward, what we can do. Right, so just some rules, as we said, follow them to make it more better online sessions. That's all I request everybody. Thank you again. Hoping that now we are good to start discussing. So today's agenda, team, again, as we see it on the screen, that will be like introduction to the DevOps. Now, under that, we will try to discuss a few basic topics, or starting with a little basic of what is software and development and so on. We will try to talk mostly on these different areas of the DevOps fundamental, why DevOps came into the picture, why DevOps is being adopted by the many IT organizations and how they implement it. Yeah, this is what we will do it. We will discuss whatever possible for today. And if the topics are left over, of course, we'll forward them to the next sessions, obviously, since we have a 2-hour session. Remember that 7 a.m. to 9 a.m. in IST. And if you're in a different time zone, I believe you know your timings. So yeah, we will have a short break in between for 5 minutes. right? After an hour or so. That is the plan again. In every session, we'll have a short break of 5 minutes, not more than that again. So technically, that's how we will plan every session to do. Right. Okay, so giving this aside, team, all these things keeping aside, let's make our session also more interactive, which means that I'm saying whenever I ask some questions to you, so do answer. Your answer can be yes, no, maybe, or I don't know. That's absolutely fine. But do respond so that, the session will be interactive, making it more discussing rather one-way speaking always, right? That's all I request from you all, team. And since this is being the day one, I'm talking all these rules. So keep in mind, so we'll carry forward the same rules and everything to the next sessions accordingly so that we can start quicker in the next sessions. Okay. I believe that I'm clear again, everybody. Any questions again before we go? So let me start discussing team. As I said, I'll be starting with a very basic that is going to be making sure that everybody on the session would understand everything, why DevOps are, what is the purpose that we are discussing this topic actually, right? So a very, very, very basic word that everybody would be listening. Like, let's say that if you are willing to join any of the software company or a IT company, you call it, after you joining a role anywhere, there are a couple of words that you will be keep hearing it, right? There are more of technical words, but make it simple then. The first word that I would like to introduce to everybody is that team something called as a server. Now, what is a server in a simple words? I would say that is a computer, right? People may call it as a server team. We always consider a server is simply a computer, like as example, as simple as that, your laptop, right? Your laptop also can be called as a server if you want to, but you always call it as your personal computer or something like that, right? So the server is a regular word that you should keep in mind going forward because this is the same word you will be hearing tons of times going forward in the sessions. So the server is a computer, as simple as it is a laptop, and we use the server to run certain application or a software card, right? We use it to run a software. It can be anything that you run in your personal laptop, or you may also call them as applications, software or applications accordingly. We use it to run the softwares and applications daily, and then we work with those things according to the role that is given to you. That is a simple logical understanding that you must be keeping in mind. So this is the first definition T that you keep in your mind always. And the second definition that I would like to give you is that application, right? Application, or you may call it as a software. Now, what exactly the meaning of an application or a software in a general way? I would say that a person who is writing it, right? It's simply a piece of code, right? A piece of code written by some person, or you usually call them as developers, a software developer usually. They write some program to make some function happen. Like, for example, a calculator application solving your math problems, right? A VLC media player is helping you playing some media applications or movies or audio file something. So every software team is simply a piece of code written by somebody, and that piece of code is helping us to make certain tasks in a computer easily and doable accordingly. That's the simple idea. Now, remember that in a simple way. But we talk about the applications team again on the softwares. Now, when it comes to the softwares application that we use every day, remember that every type of an application that you're using every day in your life, right? Because in the current market team, everybody is dependent on computers, mobile phones, and everything where a computing device is in the picture. Now you use a different type of applications, and then they are meant for some specific purpose again. Now we talked about a couple of them. I'm not going to list about every type of application we run it. We use it every day, but a couple of things that makes this course more, sensible and understandable. So the first type of an application that I would like to talk is called as the standalone. A standalone application or a standalone softwares. Now, what are this means to me, right? What are actually the standalone applications team that you regularly use them on your computer? What do we use on your computer or on your laptop regularly is that most of them are also known as, right, as standalone apps are also, right, also known as desktop applications, right? Now, if I say desktop applications, you might easily understand them. Like the examples that you use in your computer are like your, a calculator, as I said, or a MS Word that you have it, or maybe the Paint that you're seeing right now on my screen, the Paint application, or let's say that a VLC player. Now, these applications team are also known as the softwares which you run inside your laptop or a desktop technically, and then you try to use within that particular computer itself, right? I hope everybody knows how to run these softwares in a computer. How do I use them regularly? For the purpose they built for. Every software has its own purpose team. You need to understand that, right? So this is the logical idea team. We are talking about it. The first category of application that everybody uses every day. So we can easily relate to them technically, right? How they look like. Now, I'm talking about the usage purpose, but how they developed, we never need to worry. Let's forget about that. So we need to know how to use them. That's good enough. Right. Now, the second category of applications team, which we also use every day. Now, without these things, we cannot imagine even our life right now. The second category of applications are known as your web applications, right? Now, or we may call them as the web services as well sometimes. So this is a question to you, team, right now. So how do you define a web application? Since I told you one type of application, so you tell me what is the second type of application will be like. Any examples of these web applications that you are using every day from your computer? How do you define a web application? Applications hosted on internet. Okay, thank you, Snehat. A Zoom app. Thank you. Application which runs on a web server with a runtime environment. Google Bank applications, AWS, Google Map. Right, so mail. Absolutely, team. Fantastic. Thank you. Flipkart, Amazon, Facebook, everybody. Great. Right. So now the simple definition that we can give is that, team, remember that I would say that any application, right, or a service we call it, right, that can be accessible over a network. Now, the network doesn't need to be an internet team. Always remember that when we say in a network, it can be a private network such as intranet, and then you say a public network, which is called as the internet, right? Now, that's what you need to give a definition to team always, that we are saying. Technically, whenever we talk about standalone applications, they are the desktop applications used within inside a computer itself. Now, when we talk about the web applications or these things, basically we call them as any application or service that is accessible over a network, right? Which is making it something like you hit a facebook.com, the Facebook is running somewhere else, but you're able to connect to it using internet. Something that you can host within your computer as well, and you can expose it to the internet if you want to. That's kind of the web applications, web services, we will use it. The examples, as you already said, anything that you're accessing like Gmail, Facebook, Flipkart, right, a Google Map, or anything, all of them are basically the web applications or web services, we call it, right? So this is the logical understanding, team. Keep these two things for now, team. There are many categories so that way we can discuss about it, but these are the two important things that we rely mostly on. So let's start talking about more about these things. Right, I said facebook.com or say amazon.in something, whatever the examples you gave it, which is very good. Now, this is a general understanding theme that everybody should keep in the mind, that how we use every day the various types of applications. Now, as we're talking about it, to run any software, we need certain server or an application, something you call it a server or a computer, we're calling it. Now, if you consider this server team, this box as a server or a computer, now we talk about the general idea, say that a server, or I call this as a computer in a general way, right? Now, when I say this one team, it is nothing but certain hardware that we use it assembled. Like say, for especially we have a 4 CPU, 16 GB RAM, and I say that a 1 TB of a disk. Certain hardware is assembled. Then you run a operating system in it. The operating system as such, you may run a Windows or maybe the Mac OS, which is OS X, you call it. or maybe you may run a Linux as well. Doesn't matter. Now, if you try to run an operating system on top of the hardware, that makes your hardware live, right? And then you start installing your softwares on top of it. This is the general idea that you can keep in mind. Now, the logical understanding is that team. What I'm trying to come here is that if I ask you to install a desktop application team, something, usually you simply do it, right? Anybody, even a simple, a school student nowadays can do that technically if they have a laptop with them. Say that, for example, if I ask you to VLC media player, then you go somewhere and get the VLC software application somebody would give you, like if you're using Windows machine, say .exe file usually, or .msi file, maybe, whatever it is, right? That's kind of executable file. You get it, and then you run it. That runs basically and installs the application on your computer. Then you start launching the application as a GUI application and you start using it. Now, this is a very straightforward installation. Remember, this doesn't need any other dependency apart from OS is running on your machine with certain capabilities. That's it, right? Now, this application runs on its own and then happily running inside it. And this application can be used only within inside this particular computer. Whoever logs into this computer, they can start using that application. That's the simple idea. Now, the next question is that can I host Amazon-like website in my computer? If I have to do it, then how do I do that? Is my next question. So how do you do that, team? I know a few people may be knowing about it. Create a runtime environment. Thank you, Vanilla. A few people may be knowing about it. A few people may be confusing that how do I do that? How can I make that happen? Can I have my own website from my laptop exposed to internet? Need to install web server. Thank you, Anand. Yes. Now everybody says yes, pretty much. We can. Because team, remember that as long as it is a computer, you should be able to run any type of a software. It doesn't matter that it is a desktop or a web or something. As long as it is a computer, it does support everything, right? So everybody's answer is yes. So, but if you say yes, then how is the question, right? Now, let me tell you, team, a few people may be knowing it. So technically, team, first thing is that your computer needs to be connected to a network. Maybe let's say that you have a router at your home, you connect to the internet with that. There are a few things needs to be taken care, but assume that whenever you connect your laptop or your computer to a network, you get a network address, right? Some address like this, for example, the IP address is what we call it. Now, apart from this one, team, these certain applications like web applications or certain applications may not run straightforward. They need some runtime environment, right? Remember what we're saying here? Web applications, or maybe some applications need some dependencies. I'm saying it, right? Dependencies, we call it, or we may also call it as a runtime environment before we install them. Some applications, not all the type, like VLC media player doesn't need anything before I do it, but technically some applications need some dependencies or runtime environment before we install them, before we run them on a particular server, we call it. Now, what we are trying to say is that, again, to run web applications, for example, right, we use web servers, right? Web server as a runtime environment, I call it. Now, these examples, like you might be knowing again. So there's some examples of the web servers are like your, say, Tomcat, or maybe the Apache, or kind of the nginx, or maybe IIS, right? Some kind of the things we use it. That is the understanding we need to have it. So not only these things, team, if your application is being developed with, if you're developing some kind of the application with certain programming language like a Java or something, then we talk about it. So think about it. For example, if I develop a application with a Java programming, now assume that maybe something, I'm saying that to run a web application, I said we might need a web server like Tomcat, or it might need some other dependency as well, like Java programming, right? This is what all we're talking about it. So you may host multiple dependencies before you get your application. Like say, in the case of VLC Media Player, you got a vlc.exe file to install it. Let's say if I have to do a Facebook, then I say facebook.war, something. I'm saying it technically, some kind of the software application file, which is installable format, we get it. And then you actually can take it and run it. Now, this is like for a simple scenario, I'll tell you, if you understand what kind of a dependency is this. For example, think about it like you have a movie, right, Soumik? Think about it, you have a media application, I call it like ABC, or let's say that Iron Man. I hope everybody's right. Ironman.mov file or some kind of MP4 file. Now, can you run this MOV file directly on your computer, or does it require something to be installed before you run it? Yes, Soumik. Can I run movie? VLC is needed. So can I say VLC is a dependency for it? Right? VLC is the dependency to run it, or VLC is the runtime environment to run a movie application. That is what, right? So some kind of applications, what I'm seeing it, some kind of the software application, this MOV file can also be known as your media application, right? Web application, desktop application, we said. So certain applications cannot be run directly on the OS. They need certain dependency, like movie requires a VLC player. Then only you play the movie and enjoy it. Similarly, if I want to run a web application, I would use this web server as a dependency. Think about Tomcat is like a VLC player to run a web application. That is what the simple logical idea you keep in the mind. Make sense? I believe that's clear for you now, everybody. That's a kind of dependency we're talking about it technically. Now, why would I use this web server again in a simple words? Now, this web servers allow us to expose some network address. Remember, these web servers have a capability to expose this web application into the network. So, which means that how do they do it? It's a very simple idea. They have their own configuration. They expose with the address, we call it as the port number. Say there is some number is given, that number is actually called as a port number. Now, what is this port number be like again? It is just the address. Like if I have to run two different applications within my, same server, same computer, let's say that, I would also use another web server like maybe. Now, this is possible, team. Remember, in a single computer, you can run multiple applications, right? That is okay to run it as long as the CPU and RAM is enough capable. So we can just run. Say that maybe you have some Python dependencies and say that this web server will be some number. Like every application would use a unique address. That address would be called as your, let's say that here I use Amazon.in, right? Amazon.war means that I'm trying to run Amazon application as well as the Facebook application on my same computer. Now, to reach out to these two different applications on the same server, they need a specific address to be reached, right? That is where we talk about like this. So different applications runs on a different addresses so that this address is used on the network to reach them technically. Now, how do I reach to these applications running on my computer right now? Somewhere outside from your laptop, maybe think about it, right? Assume that if these applications are exposed into the internet from my computer, now your computer is where you open it, your laptop browser. Usually if I want to connect it, what do? You hit something like HTTP. Now the general way of hitting it, you use a domain name, right? A facebook.com, but that's not how you need to think about it. The direct hit to a website will be, or a computer will be like this, right? You need to use the IP address of the server where it is hosted and the port number of that application running inside that particular server. That is the actual address, right? Now in this case, HTTP, I say that like this, 3.4 or 5.6 with, if I want to reach out to the Facebook, then I'll hit 8080, right? This goes to, Facebook basically. Now remember that what we're trying to do is that in general, the people does not like using the numbers, right? Which means that if a Facebook company gave you this kind of address and then asked to use a facebook.com every day, would you be comfortable in using them? If a company gives like this numbers and asks you to use it every day, would you be comfortable? So definitely we don't, right? To make it simpler for the end customer, technically these addresses are converted into a domain. Domain as such, something easily rememberable like facebook.com. Hey, you hit this one, in a way I'll take that into a back into this IP address and port number. Simple. They will convert that. That's their headache and everything. As an end customer, you enjoy be using this one. Whenever you hit this one in the backend, you will go to a IP address and port number and hit the application where it is running it. Technically, that's the idea, right? Similarly, if I want to go and hit the same thing, now remember that the Amazon also running on the same server because we're going to use the same IP address. Now, this is where I use some other port number, which is maybe going back to your Amazon, right? This is how we can host some applications on a server. And then whenever customer is hitting it, a domain, they convert that into a backend IP address and port number. Now, via the network, wherever is possible, say they will reach to the server and go hit it, right? Technically, and the response comes back. Now, whenever somebody is hitting this one, again, it goes here itself, but it goes here, then respond back to you. So this is the logical idea of how do we access a web applications or a web services over a network. It is always that the IP address and the port number, which is in the backend. For the customer convenience, for the end user convenience, they may give you a simple domain names and naming convention easily rememberable, right? That's the logical idea, team. We're talking about it. So these are the type of applications, type of softwares we use every day. Remember, team, if you are going to join a company or a software or IT companies, you will be working in these kind of roles, like whether you may be a developer who is developing a Facebook-like application, or you may be a person who is ensuring that the facebook.com is running on a server, exposing into a network, like you install Tomcat, Java, run the deploy, install the Facebook application, something like your role, right? Now, somebody may be ensuring that this server, after installing it, every time it is available, right? Like facebook.com is 24/7 available. So technically, somebody is watching over the application running in a server, ensuring that it is always running it, right? Now, whichever the role, team, remember, technically, whatever you're trying to do, right? Whatever it is, basically, you are trying to do or fit into one of these roles in the real world right now. This is just a quick basic understanding, team, that everybody should keep in their mind, because going forward, we will be implementing all these kind of things practically as well, and you will see, understand them accordingly. I believe that I'm clear on this basic topic of what are servers, what are applications, how do we run them, and then how do we make use of those applications from those servers. The software engineering is all about, it's an approach towards the development, operation, and the maintenance of a software. Remember the words again, we will be repeating them again. So the goal of any software engineering team or any software company with this one, it is to deliver an efficient and reliable software product to the client or end user or to the market, we call it. This is the logical thinking that if you keep in the mind. Now, what's a development? Somebody's writing a code. Now, what's an operation here? Operation is like you installing an application on a server with all those dependencies, ensuring that if it is a web application exposed into a network, something, right? That's called operating, making sure the application is running on a server. Now, once it is running it, the software can go bad anytime because of the computers, everything, whatever you can say that. If something is bad with some software, some software is not working well as expected, so we will try to fix those problems. That's under the maintenance, we call it, right? So this is the general definition of software engineering, team, you can keep in mind. Now, to implement this software engineering, right, we developed a certain process called SDLC. Now, everybody knows SDLC, whatever the definitions you're actually giving are towards the SDLC, right? Now, SDLC is a process basically that talks about the tasks involved in planning, creating, testing, and delivering a software to the client or a market. Now, the process aim again to produce a high quality software that meets the customer expectations. That's what we want to do it again. Remember again, it's all about the software development, operation, and maintenance that is described through the SDLC process. Now, when we talk about SDLC, team, that is being used by many companies or all the companies to work with software development, to implement software engineering, the first SDLC model that comes into your mind is what? What's the first SDLC model that comes into your mind? If you go back a little, Agile, okay, Waterfall. Now everybody says Waterfall. That's right. We also write Nagarjun. I agree with the V as well. Right. So the major things that always people talk about may not be the V, but the Waterfall people talk about it. So let's start understanding a few things about, little background thing we're talking about it. It's an evolution of IT, I call it. I mean, in the current market team, you're using a software like a way advanced thing, right? Many softwares are fantastic and they help you in everyday life in a much better way. But we didn't achieve the stage right now, team, overnight. It was the effort from the last 3 decades or 4 decades or 3.5 decades we have it, right? So we need to understand how the process was before, now how the process is now in the current market, right? So the first SDLC model that was used, the first SDLC model that was used here. Okay, thank you, Vishnuvardhan, for raising that concern. I'm hoping that I'm speaking as slow as possible again. Is there anyone else who is feeling that I'm speaking fast? Was the pace okay, team, or it's okay? Okay. Okay, thank you again, Vishnu. I'll try to be as slow as possible. Yeah, thank you. Great. Okay, so great. So let's start discussing. As I said, I'll try to be as slow as possible again. Here it is, right? Now we're talking about the first SDLC model, which is called Waterfall. Now, what is this Waterfall SDLC model? Now, how do I understand? Now, with Waterfall team, that majority of you knows that it is called a step-by-step process, right? Which means that if you take the SDLC, which talks about the various things called gathering requirements, analyzing the requirement, and say design the plan you have it, then implement it. Once development is done, then we test it. Then once it is tested, deliver it to the customer and start the maintenance of it. Now, this is like every stage in this SDLC process team is carried one after it is, once it is finished. Means requirement gathering must be completed completely, then only we move to the analysis. And the analysis has to be completed 100%, then we move to the design. So we say that a new phase in the development process begins only if the previous phase is complete. That's kind of a step-by-step process, call it. And along with that, in this process, once a client gives a requirement to develop a software, now we will develop the software completely with all of its functionalities. Then we finally deliver it. That's kind of right. We say that if this paint application or this slides or PowerPoint application is a requirement, now it has these many different options in this particular software. Now all of these functionalities are developed completely, then delivered to the customer as a whole software application. Now that
just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs descriptions for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
That's the approach we're talking about it. Now, since there are many things to be developed, many functionalities to be developed, right? It will take a very long time, not like we can do in a 2 weeks of time here. It takes a very long time for delivering the software to the market. And if the client giving me the requirement today to develop a software. By the time I finish the development and I give it back to the customer, it may take, say, 1 year or maybe 6 months of time minimum to deliver this whole software. Now, between the time, let's say that in the 6 months or the 1 year time frame, how many times are we talking to the client again, right? The client interaction is very less, let me tell you. Once a client gave his requirement, we start with the work, and then we hardly interact with the client to know what's happening or what is that he need again. That is the another way of doing it. So technically with Waterfall, the overall delivery time is actually a very, very long, which may not be suitable in the current market. For example, just a general scenario, the current market requirement is what? Technically, say that if you order something in Amazon or some e-commerce like Flipkart or eBay or something, what is your expectation? Yes, team. What's your expectation? You ordered something today, some gadget, something today on this one. What is your expectation? That you expect it to be delivered as quick as possible, correct? A fast delivery. That is what the main thing. Now, the current market team is working on a speed, basically. Everything that you talk, not only about the product that you order, anything that you want needs to be delivered faster, technically. So how is that possible? Now, can I use waterfall model in the current market and say that I will deliver the software in next 2 weeks of time? Will that be possible for us to do it? So technically what we say is that the waterfall model may not be a right suit for the current market. That's why people are not using like in the current market. You need to understand that, okay? So it is not only this process problem team, but I also talk about some other background scenarios that everybody should have some idea about them, right? The words that you will be hearing again after you join any software company regularly, that we talk about the development process was waterfall. It's a step by step, but we need to understand something about the application architecture, which used to be a monolithic architecture, we call it, and a deployment and packaging, like where we used to run the software, are known as the physical servers. What are physical servers and how to understand them? And we need some place where we need to keep all this physical hardware. That's called as your application infrastructure, which is also called as a data center. Now, talk about these things, team, which is a very, very needed words. You need to be hearing it. So what's a data center technically? Don't read the definition, please. So what's a data center? Have you heard about this word, everybody? What is a data center? How do you define a data center? Holds data. Data center holds the data. It is a physical server. Okay, it is a physical server, servers. What is a data center? Data center is a physical location where the servers are kept, where the data holds in the drives, and we access the data from there. It consists of different servers, high CPU available, group of networked servers. It's a site of a zone hired by multi companies, store and then manage their data. Location where the servers are present. Thank you, Nikhil. To store the data somewhere on earth, physical hardware. Thank you, Mohit. So yeah, team, some people who are confused just that the data center is just a physical server. First of all, try to understand, team, just a simple scenario. Like if you purchase a desktop or a laptop for yourself at your home. Now, to place this laptop or a desktop, you need a physical place in your home. Certain corner in your bedroom, or a certain place where you keep it, your office room, something, right? Remember that the hardware, that's what makes your computers, right? Or something you run in it. Now, to keep that hardware, technically you need a place, or a physical place on the earth or in your home, you call it. Now, your company's team not just maintaining one or two computers as your laptops, they may maintain, say, 1,000 servers or 10,000 servers even based on their requirement. Now, think about the amount of hardware. Think about the amount of hardware you need to build 10,000 servers, for example, right? Amount of hardware you require to build 10,000 servers. And also, where do I keep this huge hardware technically? That's what is the place we're calling as a data center. Now, data center is not relating to the storage directly or something. A data center is always a physical place on the earth, somewhere that is managed by your company. It's a building, I will call it. It's a big building. Inside it, where they place all the hardware in racks, and they put a network, storage devices, hardwares, whatever is required, then build your computers, right? Build your computers, then let you access them accordingly, let you run the applications accordingly. Remember always the data center is not a storage or a something. It's a physical place where all the hardware is kept and build computers out of it, where you may maintain the data, which is like you might have a storage drives, hardware component that makes your computers. You need a networking devices which connects all the computers in the data center, and all these physical devices are kept. That's what is called as a data center. Okay, remember again, the data center is a physical place on the earth where we construct a building and place all the computer hardware, then build the server, right? The servers that may have a huge amounts of data storage in the backend, let you access the data. All the servers are connected over a network and everything. Now, tell me, how much time do you require to build this data center now? Can I build a data center over the night? Is that possible for us? Anybody? What do you think, team? Can we build a data center over the night? Nowadays, team, nowadays at least you get something faster built as well. But way back in 1990s time, to build a data center, it might take years of time, especially to get the hardware as well, like computers as well. We used to take a long time because the production was not that much time, right? In the current market, if you want to go to a shop and get a laptop, but let's say that in the 1990s time frame, even to get some hardware, right, it is a very challenging task. You need to place a big order to certain company who develops it. They'll develop, produce, manufacture, and give it to you, right? So the understanding is that team building a data center. Now, since we're talking about the waterfall, say it started early stages of 1990s, not only the development process, because to host that application, we need a backend infrastructure support as well already. So we start at the same time. So it will take a certain amount of time, 3 to 6 months, maybe 1 year, depends on the budget you have it, right? Because without a budget, without money, you cannot build a data center. If you have money, you get things faster. If you don't have any, you wait some time again. So that's a kind of a understanding team you should keep in the mind. Don't always blame this process of the waterfall, but also the backend requirements to run the SIEM application requires this particular data center. That takes a lot of time for building the applications or building the data center and run your applications later. That is the idea. The reason why we take a longer time, we used to link them. This is one of the reasons, right? We can't blame the process only, but the backend things also need to be looked into. Right. So as we're talking about now the data center, what is clear to you, everybody? Any questions on the data center word? I hope that everyone is now clear about the data center as a word. So if you're explaining next time, just don't talk about the storage, talk about the place. Basically, that's how you need to keep in mind. Right. So now the next part is that we're saying that within the data center, at the early stage again, we used to have all the physical servers. Now, what's a physical server technically? How do you define a physical server? Yes. What's the definition of a physical server? Something physical. How do you define it? You may call them as physical server, physical machine, something, right? physical server or a physical machine, something. How do we define a physical machine? Physical servers which maintain BIOS, CPU, RAM, okay, which has CPU, RAM, and it is in a working condition. Machine on server that is wired, okay. Physical server refers to a piece of hardware. Thank you, Venkatesh. Right. Any examples of the physical servers you have with you? Personal laptop. Agree, everybody? Is your personal laptop is a physical computer? Yes or no? Yes, it is, right? So technically, the physical for a human being is that something that you can touch and feel always, right? That's what you need to understand. So something that you touch with your hand, you feel it. The physical hardware, basically, that's what is called a physical, right? Now, what I would say is that in a simple way again, if you assemble certain hardware with certain capacity, like the various physical hardware components such as CPU, RAM, hard drive, your monitor, and everything, right? So say that, for example, I'm taking this as a 16 CPU and I say that a 32 GB of the RAM, and say that I'm taking a 10 terabytes of disk capacity, and then various other hardware components. These are the main components that runs inside a computer every time, always. The rest of the things are accordingly used. So technically, these are the three important components in a physical machine or a physical hardware, which is required to make your computer. And remember that if you assemble the hardware components, then you run an operating system on top of it, like your laptop again, Windows or Mac or Linux, doesn't matter for us, right? Now, as long as you assemble the hardware and then run an operating system on top of the hardware directly, then that's what makes your physical computers. Remember again, if you assemble the hardware, right, and then you run an operating system on that hardware directly, that's what makes your physical computer or a physical laptop or a server or a machine, whatever you call it. This is the understanding. Now, in the initial days team, remember, initial days in the sense, again, we are going back in 1990s time frame. Now, we used to always have only these physical computers. Every company, whoever builds their own data centers, they used to, buy the all hardware and then start building a physical machines, like which assemble the hardware and they install operating system. So then, for example, we used these kind of servers to run applications. I'm talking about the web applications, for example. Everybody was using this kind of the servers only to actually run certain applications in them and make it available for their customers accordingly. Now, what are the challenges with these physical machines also we need to understand. So are there any challenges with the physical machines we found out? First of all, maintenance is very high. Can I say that? Maintenance is costly actually, because all the hardware has to be placed in a data center. The data center needs to be monitored regularly by a security, and say that you need to have a continuous power backups, power and the power backups. You need to have a continuous network and the network backups, right? And there is a skilled engineers who always needs to take care of the things if they go bad, something. Some kind of a lot of maintenance activity is carried at the data center level, right? On all the physical infrastructure level regularly to maintain them well. If not, then software won't work fine for us. That is a simple logical idea, right? Maintenance is a very, very costly factor with the physical servers we used to have it. Means you're spending a lot of money on running these infrastructure. The second thing I would say is that is a scalability, right? What is a scalability means to you? Simple scenario is that in my data center, I have 10 physical servers as of now, right? Remember, I have 10 physical servers. Now, over the night, let's say that by tomorrow morning, I need another 10 physical servers. Can I do that? Can we have more 10 servers to run? To do something like on demand. I hope today is 26th, right? I hope you know something called what is today basically celebrated as? what is this called as Black Friday? Is this Black Friday today? Everybody knows this? Not Black Friday, it's something they call it. What do they call? Yeah, Boxing Day. Sorry, that's my mistake. Yeah, it's a Boxing Day, right? Now, today is something a special day basically where everybody goes shopping because many offers will be kept today after next day Christmas basically, right? Everything for a cheaper cost. I believe, right? You get this point. Everybody does shopping, right? So technically team, so take another example, right? So think about it. Amazon announcing a big billion day. Yeah, rather Boxing Day today that we talked about it. Amazon announcing a big billion day. What happens on the big billion day? What happens on the big billion day? Say if Amazon is being accessed by 1,000 users every day on a big billion day, can I say that maybe a 10,000 users accessing at the same time? More traffic, more number of people are going to hit the Amazon website, right? That is what will happen. Now, the more traffic means what? So the application should be able to serve all the customers, right? Without a fail, they should be updating it. Latency can happen. The more requests go to server can keep a burden on the server. The server may fail to serve the users accordingly. Now, the simple logical idea is that if I increase the infrastructure, say instead of running 10 servers, now I run 100 servers to handle those 10,000 customers, which is going to be probably making Amazon big billion day a success, right? Now, Amazon has to do that. Now, the understanding is that technically Amazon wouldn't need those 90 servers before the big billion or neither after the big billion, which means it's kind of an on-demand requirement, right or not? Can I say that? On demand, like whenever I need it, I have to add another 90 servers and then say that whenever I don't need them, take them out. Running those additional 90 servers throughout the year doesn't make any sense, except that Amazon spending a lot of money again maintaining them. So how can I scale dynamically? Can I scale the physical servers dynamically over the night to 90 another physical servers, right? And then bring it back when I don't need it. What do you think? Is it possible for you to do it over the night? So the scalability theme was a biggest challenge. Of course, we had this one. I'm saying how do we resolve them? We'll talk later, but this is the idea of what is the challenge with the physical infrastructure. Now, one last thing with the physical was also something called resource wastage. Now, what was the resource wastage here? What is the resource wastage meaning to us? What is a resource with respect to a computer? Which is always a CPU, RAM, hard disk, which I'm using it. Unused CPU, unused RAM, unused hard disk, right? So more capacity than the requirement. Absolutely. Correct. Not utilizing the resource fully. Absolutely. The simple idea team, for those who don't know what is the meaning of resource wastage, it's like, for example, if your laptop has that capacity called 16 CPU, 32 GB RAM, and 10 terabytes of hard disk, and every day you're logging into your computer and you just open a browser, right? And then see you're surfing the internet for some time and closing your laptop. But do you really think that to run a regular web browser and surf the internet, do you need that capacity of the laptop? Definitely not, right? For those who are uh, new to this terminology, again, I'm saying it. I hope what you see, I mean, what I'm saying is making sense for you now. Like when you try to use only a very light applications on a server, which has more capacity, you're wasting a lot of CPU unused, RAM unused, disk unused, which leads to what? Remember that you spent a lot of money to get that capacity, which means that you're directly wasting the money only, right? Can I say that? Everybody. If I have a lot of resource and then you're not using it, which means you're actually wasting a lot of money. And who likes wasting money here? Anybody like wasting money, spending it directly without using it? A lot of people don't, right? So technically what we're saying is that team here, right? What we seeing here is that technically, initially, initially, I mean, way back in 1990s time frame, the organizations or a company used to purchase the physical hardware with a higher capacity like this because people did not know that a simple web application, how much CPU it requires, how much memory it requires, right? How much disk it would use it. People did not know because everybody was new to use those computers and everything, right? So they wanted to be sure that the application runs without any issues. They should not run out of the resources all of a sudden, so that application gets into a problem. So what they used to use is that they get a physical hardware with a higher capacity and keep it. Then they started running the applications on it. Now, of course, right, with experience, we gain some knowledge and we get to know some things. What mistakes are we making it? Similarly, that after running the applications on this big hardwares for a certain period of time, like a year or so, people started analyzing everything. Now, people started looking at the server utilization, then understood that, okay, this application that I'm running here is not actually using all the capacity, which means it is useless for me right now, correct? That kind of a conclusion is made after the experience team. It's not like you came to know straightforward. Understand that all these things you will come to know only with experience. And people realized after a year or so that we have a lots of hardware capacity, but my application is not really using that. So how do I solve this problem again? How can I use this hardware fully? How can I use this hardware capacity fully so that I don't lose anything? Means I don't feel like I'm wasting my money there. That's what they wanted. So resource wastage was one of the biggest challenge again. How do I minimize the resource wastage that is occurred with the hardware that I have it, with the applications that I'm running it? Right? Can I say that, everybody? That's one of the challenge we need to understand as well. How do I resolve these problems? Make sense, I believe, everybody? Any questions on this physical server and its challenges, team? Right, so great team, assuming that everyone is back as well. So let's start with the discussion again. As we understanding team, the various challenges that usually took a longer time for your application delivery when we are actually working with a waterfall model, right? Or when we actually initially working with waterfall as a SDLC process, how we delivered an application. Now, one another thing is that team, we also had something called as the monolith architecture. Now, what is a monolith architecture? What is mono meaning to you, everybody? Single tier. How do you define more about the single tier? Mono means what? One. Thank you. Single or one meaning is a mono. So what do you mean by monolithic architecture? As the name itself is a monolithic, or it is also called as your tightly coupled. Not sure if you heard about these things basically, but this is the idea. Now, monolithic, or we call it a tightly coupled architecture, right? This is what we're talking about it. Now, when we say this one thing, the simple idea is that if you take this as a server here, right? Something you're running here. Now, an application plus most of its dependent components were usually coupled together and deployed on a single server, right? We used to be deploying on a single server. Here, I'm saying that an application and uh, other dependencies, right? Other dependencies of application are tightly coupled, right? As a single unit and deployed mostly on a single server itself. That is the meaning of monolithic architecture team in a single idea. So for example, if your application is needing an application plus of most of the database components are deployed on a same server itself usually, right? Now, this kind of an architecture team can lead to certain problem, right? Not a problem. I'll see that after understanding the things like this, people started encountering some problems. Like since most of them are tightly coupled, troubleshooting becomes a problem, right? Troubleshooting, we can see that. Now, troubleshooting in the sense team, like if certain part of the application is failing it, and I'm trying to fix it. Now it is being tightly coupled with some other thing. Now other part also can break as well, right? That is a kind of the logical thinking. The troubleshooting was taking a longer time just because we couldn't fix an individual module which has the problem in it. Now, when I fix this one, something else may be breaking because of the dependency it had with other things. So on. Troubleshooting was taking a longer time. Since the all code is also on a bigger, larger file, let's say 10,000 lines in a single file, maybe. That kind of a thing, going through 10,000 lines whenever I have a problem also lead to a longer time for troubleshooting again. That's major things, team. We talk about it. The troubleshooting was the biggest challenge with this one. And what is the other challenge we had? Installation, right? Installation, or we call it as a deployment time. Deployment takes a long time. The simple scenario is that, team, if I give you a 1 GB application, right, executable, right, how much time does it take to install on the computer versus if I give you a 10 MB application executable file to install it on a computer? Which one takes a longer time? Which one takes a shorter time, basically? Yes, team, what do you think? Which application takes a longer time for installation? Is it a 1 GB exe file or a 10 MB exe file? Longer time, exactly. Which application takes a longer time? It's 1 GB one, right? Because remember that the 1 GB in the sense stream, it has many components are tightly coupled into a single exe file. So technically that would take a long time. Carrying this and shipping this into a different servers as well going to be a task for me, right? So means what, when it becomes the size is huge, because when you're combining many things into a single thing, technically that becomes a huge package, right? That used to be like that. Many components, many application programs were tightly coupled. Finally, they have to get one single executable file with a size of maybe 1 GB size. And shipping that 1 GB file into 100 servers was difficult. And then installation used to take a long time than they expected. And also once if there is a problem, troubleshooting takes a long time again. So kind of all the problems we had, which are time consuming scenarios, right? We're saying that monolithic architecture was all time consuming process for installation, building, deployment, everything, right? This is the logical understanding team. The monolithic architecture was also something like that makes it more time for anything. So this is the logical idea team again, a monolithic architecture, a single huge software package runs on a single server. That is the meaning of the monolithic architecture application. We used to have it. Now, the whole understanding in this waterfall stage of the things team is that it was all time consuming process. Means that if the client giving me a requirement to develop a software, I deliver it after a year. That is the consideration we do. Now, the challenge we found out was that the client is not happy because the client couldn't see the software quick. So how can I deliver the software quicker into the market or quicker to the client? That is what we wanted. So we said we will change this strategy or we will adopt a new methodology maybe that will help us in delivering the software to the customer quick. So what was the next SDLC model we had after the waterfall? Yes. Yes, team. What was the next SDLC model that is widely adopted by any company after waterfall being used for certain time? Agile. Now everybody says Agile. That's right. The Agile is the strategy team. People started adopting it. Now we need to understand something called Agile development, right? Now, what's an Agile development? Can anybody describe in a simple way? Requirement, develop, review. Correct. So the understanding is that team, it's a very simple logical idea, right? Now, Agile is a process. Agile is a process, right? That tells about releasing a software in bits and pieces. That is a more layman terminology, I'll call it, right? Now, rather delivering the whole software at once after an year. Now, why can't I deliver a simple product with a one feature, ask the customer to use it, then later 2 weeks I'll update another one maybe. So with Agile, we say that we go module wise or as a client wants technically. whatever the client want to see immediately, we develop that one particular feature, that one particular requirement out of 100 requirement given by the client, right? Like a file menu this week, edit menu next week, and so on. We keep adding more and more functionalities in an incremental approach, right? This way, we are delivering a software in the incremental model, or we say that updating the software with new features at a regular intervals. That is the simple logical idea. Like you see that for the long years now, iOS, this example, right? iOS 10, iOS 11, 12, 13, 14, 15, 16, 17, right? Now, these many versions of the iOS software we've seen it. What is the technical differences? As you keep enhancing the version, which means you are enhancing more and more functionality within the same software. That is the simple idea there, right? So in this way, what we're trying to say is that the client is able to see the software quick, even it is one functionality only, and also make modifications if it is not satisfied. Means I delivered a feature to the customer said, hey, this is not looking good, can we make changes like this? Oh yes, we will see that, okay, we'll do this. Now this way we're saying that the client interaction is more, we are giving more priority as what client wants it, and also client satisfaction is being increased like this is what the idea. Now with agile process, we are delivering a new feature every 2 weeks or a month as a deployment cycle. The maximum deployment cycle, we keep it as a month, but it is expected that every 2 weeks you will have to deliver a new requirement or a new functionality on the existing software, we call it. This is what we're calling it. Now, this is just with a layman terminology team, but if you talk about a more process-oriented topic or process-oriented words here. Now we see this picture describes something here. Now the client is giving a requirement to the product owner. The product owner is a person who is talking to the client and gathering the requirement. Now, once he gather a requirement, say 100 requirement, now the product owner write them as a user story, right? A user story is something, a task. Say, for example, develop this new functionality is a task 1 or a user story 1. Open functionality, user story 2. A share functionality, user story 3. Email functionality, user story 4. Something like each and every function that you see here, text box is a user story 5. Image is a user story 6. Something like that. Every requirement is written as a user story, whatever the client wants it, whatever client wants to see with his particular software. Now, the client gives the requirement, the product owner writes each and every story, right? And then keeps it in a queue. Now, then the product owner itself will ask the client, hey, which task or which story you want to see it delivered in the next 2 weeks? That is what the question, right? That is called prioritizing the user story, right? The client says that, hey, I want to see the basic new and open functionalities next week. Now, based on that, let's say that user story 5 or user story 1, 2, 3 is picked up for the next 2 weeks delivery. Now, that's where we ask the development team. Say that client said, I want user story 1, 2, 3, 4 in the next release. I want it. Now, we go to the development team and say that, hey, let's hold a meeting with the development team. And we ask them, hey, client wants these 4 user stories. When can you deliver them? Now they'll say that, hey, 2 weeks is required for us to deliver these 4 user stories. Now that's what is called as the sprint time, right? A time that is given by the development team to deliver certain functionality, say 2 weeks maybe, or a month maybe, decide on it accordingly. And then say that, okay, once the sprint time is fixed, say 2 weeks will deliver it, the development has given a commitment. Then the client says, okay, then the development team will start working on it. Now, just to give updates to the client, whether we are able to complete the work in 2 weeks or not, there is a regular meetings are held again, like we say that a daily sprint meeting or a scrum meeting, we call it, where a guy called a scrum master will ask the developers every day, like, hey, what did you do yesterday? Is everything good? Okay. What's your plan for today? Or do you need any help, or do you have any problems in delivering the planned content to the customer on the delivery day, right? There can be a problem coming in between teams, so we need to update the client regularly. That's where the Scrum Master will check the status every day. how the progress is there, and he will update back to the client saying that, hey, we are on the time, we will be delivering it. Now, as expected, if everything finishes on the last day of the sprint, right, as planned, the last day as planned to deliver it, we'll have a review meeting that day, which is a sprint review meeting, where we'll involve the client as well, or we'll demonstrate the feature developed into the client, get their feedback. If the client is satisfied, client says everything is fine, okay, let's give it to the customer. The customer will start using it. And repeat the same cycle again. First sprint is done, the second sprint with 2 more user stories, third sprint is with another user story. So this is kind of the continuous cycle, we call it, right? It's called as a continuous development that will be keep happening it, and the client is happy, and then we are able to deliver a software product, a minimal software product maybe, to the client at a very frequent interval or a very less time, we call it. Makes sense, I believe, that what is agile? It's just like we're talking, delivering a features into the customer hands at a regular intervals. Rather delivering the whole software, we are delivering the same software in bits and pieces and asking the client feedback regularly to make sure he is satisfied as well. Am I clear with this process, team? Anything that I need to further explain in this slide, please let me know. We can talk. Great. No questions. Now with Agile as well, team, it's not just about the process change. We need to do it. Means if the developer is saying that I need to deploy the new feature on the servers every 2 weeks. Now the server should also support it, right? A servers in the backend infrastructure should also support the latest things. So we need to understand on the way we changed this infrastructure, servers, application architecture as well. It works on distribution process, we can say. You can see that to Nikki. Definitely. It's like distributing whatever the basic thing is required according to the requirement. Right. Right. So again, any questions? I mean, see, understand that to run my application, I need the infrastructure. What we said infrastructure was earlier is a data center, right? Correct or not? Every organization used to build their data center with the, let me explain, guys. Now remember that we are talking about building the infrastructure. Focus on the word called infrastructure only here, right? Now, every organization used to build their own data center at the first stage of IT evolution, because every company built a building, then purchased the hardware, then place it in the data center, place the building, then build the servers out of them, then run their application. That is what everybody did it. Now, in the second stage of the IT evolution team, is it really necessary that I should build my own data center is the question. What do you think, team? Is it really necessary that I should build my own data center? Yes, no, no. Think about it. Is it necessary that you should construct a house for yourself to stay always? To maintain secrecy, yes, I agree. The simple question is that always you do. Is it necessary that you should build your own home to stay, or you just go and rent something else? Obviously, we can do that, right? Of course, when you have your own home, that's great secret. I mean, secrecy, you can maintain on everything you wanted, right? But again, there is a flexibility. People are not really worried about something. Then you go and rent a house and stay there. Now, the same concept is applied here as well. Now, rather, companies started building. I mean, some people are started evolving, right? People started business out of it as well, right? Some people built data center. They said like, hey, I have a data center. Would you like to rent it? Or let's say that I have a 10,000 servers with me. Do you need some servers on rent? Somebody said yes. Because now when I say I can take something rent, I can take out a lot of headache from my head, right? Because I don't need to worry about the construction. I don't need to worry about the maintenance parts. Everything is there out. So somebody else is maintaining everything. They just said, hey, I go them. I said, I need 100 servers for 6 months of time. Let's sign a contract and then give it. That's it, right? This is called a rented model team. Remember that hosted application infrastructure means that instead of building your own infrastructure to run your applications, you go to a third party, right? And then rent the server, and then you host your application on that. You run your application on that. So that becomes the hosted application infrastructure. Infrastructure where you're hosting, running an application, something can be your own data center or can be a third party data center maintained by somebody else. So people started renting that. That is a kind of model came in. That way, when I develop it, I go and get the servers immediately, right? That I don't need to wait for 3 months to wait on getting the hardware and then doing something there. That is the advantage. Basically, we speed up the process, right? Whenever I want a server, because somebody already spent a year there and then ready to give it. Now I don't need to wait on more time, right? That is the logical idea. We are saying it. The hosted application infrastructure can bring us the speed in delivery process. That is what the logical idea. Make sense, everybody? Am I clear on what is called hosted application infrastructure? It's a third-party data center rented by your company. Simple. Third-party servers rented by your company to host your applications. That's it. That is the logical idea. Okay, so now, along with that, of course, we are able to get the servers from somebody else now, rather I purchase something. But again, that company also should be able to build the servers quicker. Now, maintaining the physical servers, again, will still have the same challenges. Now, as we talked about, one of the biggest challenge with the physical was about the resource wastage. How can I utilize the resources in a much better way than what we were using it? Correct or not? We need to address this challenge, correct? How do I address the challenge of resource wastage technically? Now, that's where people invented some new technology called virtualization. I hope you all know what is the meaning of virtualization, but with respect to the computers team, remember that it's a lot of physical hardware with a lot of capacity in there. We cannot break physically to bring it down, right? This physical hardware cannot be broken into a smaller pieces and say that I have a smaller portion of hardware. No, right? We cannot do that. So that's where we need to break this hardware into a smaller portion by using something called as the, what is it you call? We used a specific software team, remember, that we now not running the OS directly on the hardware. We can run some specific called as the hypervisor, right? The hypervisor examples are, again, like you have the ESXi something, right? Or say KVM or a Zen, something. So what are these like? You have an OS like Windows, Mac, Linux. The hypervisor software, again, technically, that enables the hardware virtualization. What does the hypervisor do? It enables the hardware virtualization. That is what the understanding. Now, what do we mean by hardware virtualization here? The meaning is that we break the hardware resources virtually and maintain an isolated environment for them, right? This is what you can understand it. On the same hardware, now we start building the virtual computers, right? These are also called as your virtual servers. So all the virtual servers sitting on the hardware share the same hardware resource. That is what the idea. So each virtual machine here, now each box can be considered as a virtual machine that is sharing certain part of the hardware resource from the hardware it is sitting at. So say I can allocate 2 CPU here, and I say that a 4 GB RAM here. Now I'll say that a 1 TB of a disk here, right? Other thing is that, again, I split the hardware resource, like each box here considered as a virtual machine will have its own share from the underlying hardware, right? And I say that a 2 TB of a disk. That is how I do it. Now, each of this box is known as your virtual machine. The virtual machine 1, VM1, VM2, and I say that VM3, and so on. Right? You create as many as you wanted. based on the splits you do it. You cannot exceed the hardware capacity. Within the hardware capacity you have it, you split them accordingly and make the computer run. Now remember that this is the virtual computer as we talking about it, right? This computer is going to have the application hosted now, like we have the VAR and say Tomcat and Java. And you have the OS. Now remember that within this one, we use whatever the OS you want again, you run it, right? Like we used to run the operating system on the hardware earlier. Now this is a virtual environment created by this hypervisor where we could run the same operating system and then install the necessary application and their dependencies accordingly. That is the logical idea. Now, these virtual machines are isolated from each other that you could host a different applications there, say app.py with some Python. Say here I'm running purely the Windows operating system, maybe something, right? So this is the logical idea, team, that how we split the hardware resource into a smaller portion. And then we are hosting multiple different applications on the same hardware. Thus, the resource wastage has been reduced. Like here, 10% usage and 90% wasted. Here, 90% used and 10% maybe wasted still. That can be a logical idea, right? So this is called a virtualization team that brought a revolution in the IT industry. Over the night, every company did this because they wanted to save the money for sure, right? Now, this is the virtualization techniques team that is used for building and running multiple virtual servers on a single hardware, letting us host multiple different applications as well, leading to a better and a best resource utilization of the hardware that was available. I hope that I'm clear on this particular idea of virtualization team. Think about it. The physical machine is like an independent house on a 1,000 square yard. The virtual machines are like an apartment on the same 1,000 square yard. Is that comparable? Like apartment versus independent house, right? It is the same physical place that is being splitted and shared by multiple. Whereas in the current market, you always see only the virtual servers. Physical servers are very rare, just like your laptops only. But in the real organization, we use always the virtual servers only. Okay. So this is the understanding team about the virtualization that made us utilize the resources much better way. Maintenance has become reduced because instead of maintaining 10 physical servers, I will maintain 5 physical servers with 20 virtual machines on it. So technically more number of servers with a lesser hardware capacity you have it. That way we are able to reduce the maintenance as well. And of course, the scalability wise, it's okay that if I have a hardware, I can create a virtual computer in a matter of an hour or so earlier. But right now it's not, right? So this is the logical idea team. The scalability is improved, maintenance is improved, resource wastage is gone, right? Resource wastage is negligible, I can say that, but still there will be something. Right, so this is the advantages we got it through the virtualization. Now everybody adopted, everybody started seeing the benefits of virtualization technically. So apart from this one team, now the application architecture also being changed from monolith to n-tier. Now, what is an n-tier architecture or a monolith architecture? What is this, right? So what is an n-tier architecture? How many of you know about it? Yes. What's an n-tier architecture? Anybody heard about it? Now, this was the monolithic we said. Now we are talking about something called n-tier. This is also called as a 3-tier. Now, if I say 3-tier, some people may be realizing it. What is a 3-tier architecture? Yes, team. Decoupled architecture. Have you heard about these things or no? Nobody? No idea? Backend, front-end, middleware? Thank you. No ideas? Think about team, any application that you're using on the internet are now the 3-tier applications, right? Any application that you're using on the internet are mostly the 3-tier or n-tier applications like Facebook, Amazon, whatever you Flipkart, what you call it, everything, or your internet banking, something. So technically team, the logical idea is that not microservices. Micro is a little different, right? Now talk about the 3-tier first of all, then later microservices comes into the picture. See. Now in the 3-tier architecture, think about it. We are hosting the different applications or different components on a different servers. Just like think of an example, say if you're talking about your internet banking, just a simple scenario, right? So talking about this is the server or a virtual machine now. Now assume that where your bank application is running it, say bank.water as an internet application, I'm talking about it. Now here if it is hosted, say that as a client, you're sending a request from your laptop, right? What are you doing here? From your laptop, we call it. You send a request, the request goes to the server via the network and comes up, right? And think about it, once the application responded, all right, let's say you're using a browser here, right? Technically. Now in the browser, you see your login page. Now, once you see the login page, what do? You enter your customer ID and password, whatever it is. Then you resubmit. Now, when you resubmit, say the data is sent over to the application. That is the logical idea. We talk about it. The data like username and password is sent over to the application here. This application needs to validate the username and password you entered is actually correct. Now, if it has to validate that, it needs to know what is a one stored. Means somewhere it is need to compare the value and then give the result for you. Now, does the username and password is stored on the same server here? The answer is no, right? The most of the time in this architecture, we decouple that data storage or this one into a different server. Say that here, this is another server or a virtual machine where a user database is maintained. A user DB means that, remember, all of the Facebook users names and user passwords are stored on this particular server, which is called as a user DB. Now what happens that the customer sends a request, application then forward a request into a backend server where actual user data is maintained. So technically, right, this is the logical idea, application going in separate DB server, you call it technically. Now this is the logical idea where it is stored. So in this scenario team, there are 3 different layers that you can consider it. People consider it technically like this, right? Now, the first one where a client seeing something is always called as the client tier, or in a way it is called as the tier 1. Now, where actually the application is hosted, which is like in the middle always, so middle tier people call it, this is always called as a tier 2. Now, where actually the client data is maintained on a separate servers again, that's called as a backend tier, or this is also called as the tier 3, right? Now, in the scenario team, this is called as a 3-tier architecture in a general, right? The different components are hosted on different servers and everything is connected over a network, right? So the application hosted on a certain server, database hosted on a certain server. If application needs certain different things, they also can be hosted on a different server in the backend. Okay. Now, for example, after you log in successfully, you requested for a last 1-year statement as an example. Now the bank application would know that it has to connect to some other database again, right? Server or a VM. Now this is like a client database, I call it. The client DB in the sense that technically where all your last 1-year, 5-year statements are being, maintained. Whenever you request through the application connects to a backend storage, pull the data accordingly, and then present it to you on the screen again. So this is a kind of a 3-tier. Since the backends can be multiple team, it is also called as N-tier, like your application in the middle, talking to multiple different backend components, N number of different components in the backend. So it becomes the N-tier, also called as the decoupled architecture. Different components are being decoupled. Everything used to run on a single server earlier. Now we are running them on a different servers, and everything is connected over a network. This is called it's just kind of a database, right? You use like a SQL or Oracle, right? It can be a client DB in a sense where the client data is stored. Oracle technology has been used, right? Like a last 1-year statement, Nikki. If you're asking to pull the data is stored here. Now, whereas I'm saying it here, only the username and password are stored. Only username and password stored in this DB, right? Not anything else apart from it. So to validate, it is going here. Usually we use here is called as the active directory, right? Or you may call it as LDAP tools. I mean, just mentioning this one accordingly. You can see that, right? Since it is decoupled, now it is easy for me to look into certain specific issue, right, Vishnu? If it is some data related issue, client data related issue, I'll go to the client database server. I troubleshoot there itself. So I have a clear visibility on different components are running it. I can troubleshoot them easy. Second thing is that since we decoupled the components, means earlier whole application was 1 GB, now it is 100 MB of application, 100 MB of user database, 100 MB of client database. So it is easy for me to install as well, right or not? This is what the idea. Makes sense, Vishnu? So since it is decoupled, they become a lightweight. When it is a lightweight, it is easy to install, process everything, and easy to troubleshoot as well. Something like a specific component can be troubleshooted without affecting the other components as well. That's kind of the advantages you gain with 3-tier architecture, or also called as N-tier architecture. Load balancing for heavy data size, you may do that. That's right, Nikki. Well, when you want to make an application highly available, then we go for load balancing as well. That's okay. Okay. Hope this makes sense for everybody team in a more layman's terminology now, what is called a 3-tier architecture applications. Now, any application that you're using on the internet team working on these strategies itself, right? Either Facebook or Amazon or anything that you use it, everything is working on this model itself right now. Okay. Great. So I believe that now with this understanding team, with this kind of the all changes, infrastructure changes, virtual servers adoption, and the N-tier architecture adoption, what is that we are achieving here? What is that we are achieving, team, with all these strategical changes we're doing it? We can say that we deliver the software faster into the market. Can I say that? The faster delivery, right? That is what the goal for the entire things we are talking about it. So anything that you're doing is that we're all trying to achieve a speed of delivery. That's all we're trying to do. So remember that with evolution of IT, agile model we adopted, we are delivering a software application into the market as client wants it, also at a very frequent intervals, which is a very faster delivery when compared to the waterfall approach we had it. The goal is speed of delivery. Remember, the goal is just a speed of delivery we're talking about it. Now here, what are the other things that I still need to work on? Can I improve a speed more is a question, right? What are some other challenges that I can improve on so that we can make sure we deliver our applications much more faster into the market? The goal is speed. That's it. Keep in mind. Now with Agile team, we did everything great, but if you consider something, because everybody was adopting new technologies and learning them, a lot of work being done was manual, right? Manual in the sense that you copy a file on 100 servers manually, maybe, right? You install a software on 100 servers manually, maybe something like that. You create 100 virtual machines manually, just one by one at a time, something, right? Now, to build the servers, infrastructure required to run applications and softwares was done manually. Deploying the application on number of servers was done manually. Now, how can I improve this manual approach technically? How can I change this? Now, you automate everything possible. Remember, if I automate, can I add in more speed here or not? Yes, team. As I said, everything was manual. Now, if I automate it, can we technically go on improve the speed of delivery more than what we did with Agile again? Definitely, right? With automation only, team, you're all at this stage, remember, in the current market. So I hope that if you are working already, your managers may be keeping a mantra of automate, automate, automate. Yes. How many of you are working here? And how many of you, your managers was talking about automation every day? Nobody's working, team? Come on. Are you guys working or not? I expect that a few people are freshers, maybe. I mean, not working maybe, but I expect that most of you are working. So is your manager not saying about automation anything? Is not talking about automation anything? No. Day in, day out, always 7 years experience. Okay, fresher each day. Right. So yes, a lot of managers team, a lot of your organizations are now focusing on automation. Even if they are not talking as of now, expect that they will be talking soon. Yeah. So expect that your managers will be talking soon that about the automation. Okay. Freshers is fine. I accept it, but I'm asking about the persons who are already working. That's fine. Aniket. Right. So the understanding again, we're talking about the one of the important thing in the current market. Every organization is expecting to deliver their product into the market quicker. Now they're trying to do everything possible to make it deliver faster. That is what the idea is. So one of the solution to deliver a software product or a software quicker into the market is to automate everything that we did it, that we were doing it technically, manually, we do it. So this is something team that we need to focus on, the automation. In this course, yes, we'll be focusing on certain automations that will help us in delivering the things faster. And apart from that, we need to understand a few more things. I know team, we are closing to the time. I don't want to rush in explaining this, what is called a release maintenance window here. And we are close to what is DevOps discussion. So we need to understand this slide. And then we step into the DevOps as well. So we still need to discuss this DevOps concept and why actually DevOps is needed in the current market. To make you understand, you need to understand this point as well as this point exactly. But again, if I start explaining them now, it will take time. So I don't want to rush in explaining them. But I believe that you're all clear on whatever we spoke until now. Hope that everybody is good with this. So is 3-tier called decoupled or loosely coupled? It's decoupled, Snehit. 3-tier is called decoupled. Loosely coupled is microservices. Microservices are really different. Next level to the decoupled or N-tier is the microservices, Vishnu. Okay, that is what the idea. And team, please do not leave anybody. Whatever I said, whatever I spoke, if you're clear, we are happy for today. And the next discussions will be discussed in the tomorrow session by me itself. I want to make clear everything what we discussed again, we'll repeat tomorrow. But again, whatever it is, right now, since it is time for me to leave around 9 o'clock, and you don't leave it because there is a lab session will be on right now. I think you need to, which is something called like server or an applications. That's what we usually work with. So we understood about these servers, applications to you. What is a server? What is an application? What are the different types of applications we usually use to run it on a server? How do we make use of them, either within the server or maybe via network? That's what I mean intention here. Understand mostly about how do I run an application and make it available on the network, because nowadays everything is about the network only, right? That's the initial part team. We understood about the basic part, servers and applications. How do we run them? How do we use them technically? Then we started understanding about the definition of something called software engineering. What are we trying to do as a software engineer, which is like an approach towards the development, operation, and the maintenance of a software. You may be working in any role team. The final goal of your software company is to ensure something may be developed and ensure it is running it and maintained well after it is been delivered. That is the logical idea. The goal is to deliver an efficient and reliable software product to the client or to end user or to the market always. Now that's the main understanding team. So to implement the software engineering, we developed a process called SDLC, Software Development Cycle Process. It also this process aims to produce a high quality software again that meets the customer expectation. And we are talking about the evolution of this SDLC team or evolution of IT, how we used to develop and deliver the softwares previously versus how we are doing in the current market. So we started off with a little bit background, like we had one majorly used model called Waterfall. We understood about how we used to deliver the software with this model. In the situation, we say that we gather the requirement and then we try to develop the whole product and deliver it after 6 months or a year. The client interactions are very less in this approach. The client is not really satisfied with the kind of approach we use to deliver a software. And it is also a time-consuming process, as we said, with waterfall always, not only because of the model, but there are some factors in the behind scenes, which is like building up your application infrastructure, such as data center, is a big task for your company, your organization. The kind of servers that we're using, like a physical servers, also does not support, a quick setup and a quick scale up factors. Maintenance is very high and everything. A lot of resource wastage is being there with the physical infrastructure always. With the initial days, we were talking about all these things, right? The physical infrastructure is difficult to maintain, scalability issues, resource wastage issues, we found everything. Of course, technically understanding is that setting up physical infrastructure, that easy, and it is a time consuming process again. Now, we did talk about the architecture like monolith. The monolith architecture again says that it's a mono package which runs on a single server always, technically leading to a larger installation times, deployment time we call it. And also the troubleshooting scenarios takes a very long time in case of some issues and so on. Now, we did discuss about all these things, team, and overall idea that with waterfall we had was that with any approach you do it, it's not that easy for you to deliver the software quicker into the market, which is not going to be done with waterfall. I mean, this waterfall model may not be suitable for the current market, team, because in the current market, anything that you want needs to be getting it quicker and faster. Even like if you order something in Amazon, you expect an immediate delivery. That is what the logical thinking of every human being right now in the market, that everything we want it fast. Everything we want it quick. So this waterfall model is not the right suit in the current market. Not only now, but say that 20 years back itself, we realized that. So technically we moved on the process to Agile. And we said in the Agile model, the process tells about releasing the software in bits and pieces, rather delivering the whole product first of all. Develop only the individual product, individual piece of the product, like maybe a single functionality about the PowerPoint to make an open and empty slide, and then deliver it. Then later you keep enhancing it, adding more and more features to the same software going on. So incremental model, we call it, right? We're delivering the software in the incremental model, updating the software with new features at regular intervals. This way, the client is keep changing its requirement accordingly. The client interaction is more, and also we're able to satisfy the client that he can see and use the software quick enough with the minimal functionalities at least. That kind of a way we are making client happy. Now we discussed about this process, team, and we said with not only the process, but we also worked about the backend components again. The application infrastructure, we started using the rented servers, also known as your hosted application infrastructure. That is what we said. We converted the physicals into the virtual servers, gaining the momentum that how we can better utilize the hardware resource, right? Host multiple different applications on the same hardware to make the hardware resources are being used much better way than the other one. Maintenance is reduced because we have multiple servers on a single hardware. So maintaining, instead of 10 physicals, maintaining 5 physicals with 30 virtual machines, it's a lot easier for me right now. That's kind of the understanding we had. Creating virtual machines is also easier when compared to the physical infrastructure creation or setup technically. So we had these things team yesterday, right? And apart from that, I believe the entire architecture also we discussed, like dividing the components and hosting them on a different servers and connected over a network basically. That can be intranet or maybe an internet as well, doesn't matter for us. This is the logical idea, right? So these are the things, team, that we covered yesterday, mainly on the part of discussion with DevOps fundamentals. I think this is where we were slowing down. And with Agile, we said at least that we are able to deliver some or the other functionality or a software piece into the market, say every 2 weeks, maybe within a month at least, we are able to deliver it. That's what we said, right? So with Waterfall, we had certain challenge of delivering it. The delivery speed was very low. With Agile, we improved it a lot, right? Every 2 weeks, we're delivering the product into the market. The customer is making happy, getting happy. That is what it is. And as we said, team, with Agile, everything was great. right? The client, we are delivering a software as client wants at a frequent intervals. That's really great. Now, we can still look into some more things that can speed up the delivery process more. That is what we were talking about it yesterday. The challenges that we still see in the agile model adoption after adopting it for a while, and then we started realizing something can be done better way. Like one of the thing is that a lot of work being done in a manual way. Like you're building servers, infrastructure required to run your applications, softwares, deploying applications to n number of servers. Majority of the tasks were being done manually. Again, consuming a lot of time for these activities. Now, how can I do the same activity in a much faster way? That's where the automation comes into the picture. Automate everything possible, right? One of the slogan or one of the key, words that every organization started using, right? Later the agile, right? Is that automate everything possible so that we can improve the speed in the delivery of the software product into the market. That is one of the key challenge we want to be done. How to automate, what tools to be used, those things we will discuss throughout the course again. But this is one challenge to be addressed. That is what we discussed. Apart from that, we have a couple of more challenges. We need to understand this particular called limited release window, maintenance window, as well as the other problems. Then we talk about the solution.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Solutions that can be implemented with DevOps today. That is the agenda for today mostly, that why DevOps came into the picture after the agile, how it will help in, again, delivering a software quicker into the market. That is the logical understanding and the main portion for today, main agenda for today that we will discuss. So before I get started with this things team today, I believe that everybody is clear on everything that we spoke yesterday, right? If you have any questions before I get started with today's agenda, do let me know. We can talk about it. Otherwise, we'll quickly get on to the topics we need today. Yeah, I do see that most of you are good. Fantastic. What is the role of a Scrum Master? A Scrum Master is like a manager. What is the role of a manager basically? A manager is like managing the team and then ensuring that the team members are working coordinated, and also help the team members, like if they are having a problem in communicating with other team, setting up the necessary task and accordingly. That's this Scrum Master usually do it. Tracking of the work and also help team members if they have any problem with the development features, whatever they're doing it. Ensuring that they can collaborate with different teams as well. That's kind of a role the Scrum Master would do always. Okay. Mainly build collaboration between the different teams and between the team members. That is the main role. Okay. Now, not a problem, Pawan. I think you can revisit the recording that you have in the LMS of your Intellipaat. So revisit that. Right. So now today we are talking about the first point that we want to highlight is that your limited release or a maintenance window. Now forget about the limited release or maintenance window first of all. Now we say that a deployment to a server cannot be done without a downtime. So first try to understand a word called downtime. Now what is the meaning of a downtime here? Considerably, right? We can say that this one team. The simple scenario is that if I go and then say hit a website, right, on the browser. Just for example, means I'm trying to access the Facebook application. When I hit it, it says I got some response to the login page, which means the application is up, running, available on some server somewhere. But at the same time, if I hit the facebook.com, exactly the same URL, but if that you got a response, right, which is like the site can't be reached, right? This is what it is, the idea. Whenever you try to access some service over a network, whenever you're able to, or you're unable to reach out to a certain service or a website, right, and it says that the site can't be reached and you cannot access that right now, this is what we call it as considering it as the site is down. Down in the sense it is not accessible, simple as that, right? A down means it is not accessible at that point of time. But if the same thing continues for the next 2 hours, say the facebook.com is a website I'm unable to access from now, say next 2 hours. So the 2 hours time is considered as the downtime for that Facebook application. Remember, the downtime meaning is that the amount of time, right? The amount of time where the certain service is not accessible, right? Technically, where a service is not accessible certain amount of time, like maybe 1 hour or 2 hours, maybe 6 hours, doesn't matter. That is what is called as a downtime. Now, once we have understanding the downtime, now let's understand that why would the downtime occur? Now, what do you think are the reasons why the downtime would cause? Why would something will not be accessible? Server failure, maintenance, anything else? Server issues, power issues. So there can be many issues, teams. So you have a network issue, right? The major problem is that, first of all, you can see the network issues, right? Let's say that your internet is down, so you cannot access it. That's your problem. But say that if the same network issue, internet issue is on the Facebook server side, of course, that is also something that the network problem, we call it. Because of the network problems, you may not be able to access some service, the first thing. The second thing is that the server had some issue and the server went down because of some reason. Again, server crashed, server overloaded with over request and everything. Immediately the server crashed out, like shutdown. Now, when a server is shut down, you cannot access the application, the second reason. Now, the third reason, I will say that as we're talking about with Agile, we are delivering a feature every 2 minutes. It's like you're updating something on your phone. So think about it, you have installed certain application on your phone, like maybe a WhatsApp on your phone. Now, WhatsApp would release some fixes or the updates to the same application you installed earlier. Whenever there's a new update comes, you update it, right? Update button you click on, that will start updating the latest features into your phone again. So one main thing is that during the update, like whenever you release a new version of your software, new features into your software, that's when you bring it down. Means as part of this deployment or the installation process or the updating process, as well, there is a possibility the applications will go down and they have to be brought it up again after the update. So we're talking about the third scenario here. Since we are saying that every 2 weeks, right, since we are adding more and more functionality, which is like adding up the updates on the existing software, that's what we're doing here. So there is a possibility that whenever you release a new version to your software, the downtime can occur again, right? There is a high possibility that the downtime can occur whenever you are updating a new version of the same software every 2 weeks or a month. Now, there is one reason we're saying it here on the scenario whole, right? Whenever we're trying to do, saying that a deployment in the sense like you're updating it, deployment in the sense you're installing certain software on a server. Deployment to the servers cannot be done without a downtime. Means we had certain challenge where every time I update it, I have to provide a downtime, like again, right? That's causing it. So we need to inform the client. So we use a maintenance window, or it is called as a release window. Now the window is something like inform the timeline to client in which the application will not be usable or accessible. If the Facebook is doing an update, so they will inform all the clients saying that, hey, we are updating, our systems are undergoing the upgrade process or something under the maintenance, you may not be able to access it. So this is what the regular way of releasing an application into the market we used to follow, right? Now, again, I'm telling you, that is called a maintenance window. The maintenance window is like, let's say, I'm informing all my clients that as Saturday, midnight, 12 a.m. to 6 a.m., the website will not be accessible. You cannot use the service. That is what I'm informing the client accordingly. That's called as the maintenance window. Like 12 a.m. to 6 a.m. is the window where we're trying to update our servers, applications accordingly. So every week, means every 2 weeks or a month when we are delivering it, this is a kind of update we used to send to the clients and wait them until I bring up the servers, services, everything, then use it again. Now, one challenge is that now, how can I avoid this downtime is a question that people started thinking. Means to improve the client experience, maybe let's say that the client should be using the application without a failure, but I should update the version 1 to version 2 without any disturbance. Now that's what we want to implement it. That is one another challenge we are taking into our bucket and saying that, hey, how can I make a no downtime deployments? Remember, the challenge here is that how can I provide a no downtime deployments, a no maintenance windows to be used for deploying, releasing an application into the market. For that, again, you might want to adopt certain processes. That's where people talk about adopting something called CI/CD, which is called a continuous integration and continuous delivery. Implementation can give us a faster delivery as well as helps for no downtime deployments. Now, what is a CI/CD again? We have to discuss in more detail. I can't say you on a high level words what is this technically. So throughout the course, or one of the goal for this entire course is to implement a CI/CD by the end of the course we're going to do with these sessions, right? That is one goal for this course as well. We say that implementation of CI/CD process technical. So this is the logical idea team. The solution or one another challenge in our bucket is that how to make a no downtime deployment or installation onto a server. What are the strategies to be used for that? We will have to discuss accordingly. So two important things: automate everything possible, ensure the deployment goes without any downtime. That is the second challenge or two things in our bucket. How do I implement them? How can I make these things happen? That's what we need to address it. So I believe team, I'm clear here on what is a limited release windows. It is a possible solution. We can discuss about the different deployment strategies for that, Vishnu. Like we have a canary deployment, a blue-green deployment. A flip of second, you will see the application working. There shouldn't be like a customer wouldn't feel that the services are down. They still continue to use the same application with the updates regularly. That's there. That depends on your company and project or a client, Nikhil. I wouldn't say that like because my client allows me for 6 hours of downtime on the production. That is on the non-peak hours or non-business hours. But depends on the client, depends on the project. The downtime could be varied. It's not a static value that we can see that, Nikhil, right? So some clients may be okay even for a half day, but some clients may not be even okay for a half an hour as well. That depends on the kind of business they're doing it without application. Like Amazon, like application, can it be going for a 6 hours down? That how much business they would lose if it is 6 hours down. So they have to ensure that it is available all the time, 24/7. Maybe acceptable 5 or 10 minutes is okay, but more than that, say the Amazon would lose a lot of business in that. So technically they wouldn't allow a larger downtime. That is purely depends on the type of application or a service we get it. Okay. Am I clear, Nikhil and everybody? The other challenge we want to do it. Right. So now the next point we want to look into this one. Now, working fine in dev and ops problem now. Okay. Before I talk about this problem, let me talk about one simple word called an environment. Now, those who are already working might be aware something called environment. Those who are already working, I'm not asking the freshers if they are any did work so far. There is a word called an environment. So anybody can define this environment, those who are already working. What are the different environments for your project that you use it? Okay, prod, staging, dev, UAT. Right. So now people started saying to me that, okay, there is a dev environment, there is a QA environment, right? Or you have a SIT or a UAT, production, right? Depends on the project to project, depends on the organization, and these environments are very quite common. Now, what is the environment definition? Now, you told me the environment name, but why would I maintain these many environments technically? Now, the simple thing, team, I will say that, remember, an environment is basically a group of servers, right, where we run our application. Say that I'm working on certain application like Amazon development, and then that application, when it is developed, we will run it on a server, ensure that it is working. So remember that environment, there are many environments. The end goal is to make sure you deliver your application into an environment called production, which means there is a group of servers where we run our application. The production servers is where we run our application. Now, why would I use these many environments is the question, right? What is the necessity of running these many environments where these many number of servers where we run the same application again and again, right? So consider if this is the one and this is the another environment. So just a box refers to the different servers, team, remember. I call this is my dev server, or there can be multiple servers in an environment. So dev is the environment. So as I said, each environment is just a group of servers only. So technically, this is what I call it. Now we call this is my, say, QA servers. It can be a single or multiple servers as well. Now, similarly, we have the production servers, right? A production, I call it, or a prod in short, people call it a production servers. Now, what do we mean by this? Right now, why would I need these many environments, team, technically, or these many different servers where we run the same application over and over again? Now, remember that the production servers are something that are used by the end customer. Like for Facebook, you are an end customer or your end client. Now, whenever you hit a facebook.com on your browser, the request is going and hitting a server, right? That server is what we're calling as the production server. The production servers is where an application running and the end customer are able to access that application through a production servers, we call it, which is a live servers where end customer can use and enjoy the features of that application. Now, if this is the only required for the end users, now what is the necessity of a QA? We have a group of servers. Dev, we have a group of servers. The simple logical idea here is that whenever we develop any product, right? Whenever you develop any kind of a product, it doesn't need to be software, right? It can be like a COVID vaccine that is developed. It can be like a car that is manufactured by some company, or it can be like, some kind of a refrigerator manufactured by some company. So any product that is developed, before it is given to an end customer, do we have to test it thoroughly that it is working fine? Yes, team. Do we need to test it or not? If the COVID vaccine was given directly to the humans, what would have happened? Makes sense, right? So any product that is developed, any invention that you do usually, it has to be tested thoroughly before it is actually can be used by the end customers, right? So the same thing is applied here. When a software is developed, like a Facebook.war or Facebook application, right? I say that this is my FB application. Now, how do I ensure that this FB application is working fine as expected without any issues? Now, that's where people usually install on a server like this one. If it is working fine, then he will go here in the QA. QA is like a quality analysis servers, we call it, where the people perform some kind of the functionality testing, regression testing, integration testing, and so on. So all sorts of testing is performed, right? And once everything is working with this Facebook application, once we certify the application, then it is released into the production servers. But it are maintained separately because lower environments, we call it. The before production environment is where the application may fail as well sometimes, but we ensure that the application works absolutely fine in the production servers without any issues. So only the certified software product is released into the production servers. That is the logical idea we need to understand. Now, this is what we talk about it. Now, the question is that who will the person that as a human being, who is the person who installs the application on all these servers? Who does it? Now, especially the dev servers we're talking, it is the responsibility of the developer. Remember, this development servers we're talking about it. These are given to a developer where a developer would install it. Because remember, the developer is the one who developed an application or a software basically, right? I say that a developer is the one who installs the application in the dev servers. Now remember that he is the guy who developed the product, so he knows about everything. So assume that if he fails to run this facebook.var file, fb.var file, he needs some dependencies as well, like Tomcat and Java. So whatever the dependencies, he will configure exactly what he needs it because he knows what to use it. He deploys the application. He says that, hey, everything is working fine at my end. I'm done with the development. You take this and start delivering to the customer. But some people, again, we said, okay, you said from your side, I'm good, but let me also test it one more time. And then after that, only release into the production. Now, it is not the developer who installs the same application on the QA server or a production server. It is a different person who does not even have any knowledge on the development can take it. Like if I have to install a VLC media player on my server, do I need to have the development knowledge of the VLC application? What do you think, Tim? If you have to install any type of application on your server, did you ever worried about how it is developed? Do you need to know the programming? Something you will, right? Say that the end user should be there. So this is where you think about the developer duty over when he handed over the product to the next person, right? Now, it says that these teams, usually we call it as the operations, right? Development team, you call it, or in this scenario, we talk about something called as operation team, or there may be a multiple different teams, usually takes the code given by a developer and whatever the instruction, remember, but these persons really do not know how to use it. So developer would give some instruction accordingly and say that they will start installing it, say Tomcat and say Java. I mean, so they will set up all the necessary things which is given by the developer on all the environments again, whatever is necessary, first of all. Now, once that is done, let's say that they will shift the code, right? If it is working fine, so take it, run it, whatever the underlying dependencies as well, configure it properly and do it. Now, this is a regular deployment activity team that happens, that the person who is deploying the application at development servers is entirely different. The person who is installing, deploying the application on a production servers is entirely different. And remember that the person who is doing in the production has no development knowledge most of the time, right? That is what the regular case. Now, in this case, say that while this person, the operations person who is installing the application on the production server, then it starts failing. Now, who will he blame? Yes, Tim. This guy does not know how the application works. He said following some document. Now, when he followed the document and it fails it, now where would he go to fix the problem? To whom he needs to contact now? Developer, as usual, right? Yes, Tim. Do you agree or not? If a software is unable to install on your laptop, what do? You go seek some support or maybe get an update again regularly. So technically, the solution is that this guy needs to send or talk to the developer. Now, this operation guy goes and talks to the developer. In this scenario, developer says that, hey, let me check it. He will quickly test the same application on the development server. He says that, hey, the application is absolutely working in my development server. If it is not working in your production server, that's your problem. You go troubleshoot and fix the problem. Means he's simply passing the ball again. Say the operation team sent a ball to the developer. Developer did test it in his server. He says that, hey, it's my server and it's absolutely working fine here. I'm giving you again, so you check it on your servers. That is, you configure it properly. So you recheck everything. And this guy goes and checks again. He couldn't understand. So there is a kind of war that goes in between. Say Operation team says that, hey, it's your problem, your application. Developer says that, hey, that's your servers, you are not running properly, that's your problem, you fix it. So this is a kind of a war between the two teams goes on, right? That is a regular thing we have it. Now that's what this slide means to you here. It says that working fine in dev, it's an operation problem now. Now I hope you got the meaning of this slide. Working fine in dev always, but operation problem, that is that production servers are not working. It is purely the operation problem, right? I hope that I'm clear, team, now. This is the meaning that what's happening in the behind. Now, what exactly the challenge we're seeing here? What is the, I mean, who is the losing person between these fight? Who is losing team here? Who is lost? Who is in lost? Operation team. The end customer is in the loss, right? The client is unable to see the application, remember, because it's failing in the production. The end customer is unable to use it. It is the ultimate thing is that the customer is losing it, right? Client is unable to access the application until unless production servers are fixed. The client cannot access the application. It's a client or a customer who is the one losing it, because these people are fighting. These guys, they're doing their job, and they say that they don't give, they don't care about anything on the whether the customer is using or not. Technically, it's your company who worries about the client, but not the persons here, right? Most of the time, this is what happens. I mean, they should be worried about it actually, but the major problem here in this scenario is that the lack of collaboration. Remember why these people are passing the ball one on to another one simply and saying that it's not my job. Now, this is where team, remember that the operation team or a person who does not know who is a developer. The developer, most of the time, who does not know the person who is deploying in the production service. Now, why? Because they may be working in two different time zones. Say developer is in India, the operation team is sitting in the Germany or a US or a Canada somewhere, right? So because of the time zone, they never communicate with each other. That is a major problem we have. Even you are on the same city or in the same company, right? Most of the time, developers or development team and operation team would never directly communicate with each other. They just pass the ball and they say that my job is done. Now, this is a kind of attitude. This is a kind of, culture we have with a project teams. We have it, we call it. Now, this is where, how do I solve this problem? The major problem of collaboration between multiple people who are responsible for delivering the same project. Remember, developer duty is to ensure he develop and deliver it. The operation team is also ensure that the product is being delivered to the customer and make sure the customer is happy always. Now, this is what is lacking, team. Now, to address this one another big challenge of collaboration, people introduced something called DevOps. Remember, previous to the DevOps, with only Agile, development team and operation teams are working silos. They just say that they work like, I don't know you, you don't know me, right? They just doesn't care about anything there. They work in a silo. My job is done. It's your job to take care of it. The kind of the attitude, the kind of the culture we had was every team was working in a siloed environment. They don't lend a hand to support other people as well in the job roles. That is the kind of major problem that every company was seeing it. Now, to eliminate that kind of a problems between them, people introduced DevOps. So that is where I'm telling you now, the definition of a DevOps is not a process. Mainly, DevOps is all about a reorg, not a new team to hire. Remember, it's not any new team. It's not any new skill set to hire or make it happen. It is all about saying that, first of all, reorg, restructure your organization teams into a single team, like we call it as the DevOps team. Rather, you call it as a development team, operation team. Now, there is one single team who includes or which includes everybody inside it, right? So the definition, again, we're talking about the DevOps here. The DevOps is the philosophy of unifying development and operations at culture, practice, and tools levels to achieve accelerated and a more frequent deployment of changes to the production. The end goal, again, we remain same thing. We want to make the application delivery faster and faster into the market. That is the end goal. Now we are still lacking some time, or we're still making it slower because of the collaboration problems and everything. Now remember, team, this is like one we want to do in a software industry, we call it, right? Software field, you call it, whatever it is. Now, so far, if you are having enough experience, let's say that maybe 5 to 7 or 10 years of experience, you know how we used to work in the backend, right? Every team working in silo. Development team does their job, says that my job is over, take it up, and then you do your job. QA team done their job, pass it on to the middleware. Middleware does their job, back it on to the production support, something. So every team used to pass the balls. Now, and nobody's taking an accountability. Nobody's feeling that we are all working for the same project, so we should work as a team. Nobody's doing that. Now, to eliminate this kind of the collaboration gaps between the different teams who are responsible for delivering a product or an application in this case, people started bringing them onto a single team and call them as the DevOps team. Now, remember, team, just a simple comparison, I'll do it, how this works now in the software field. Take an example of the medical field. Just take an example of the medical field here. Now, in a medical field, everyone means once you started practicing the medicines or medical practices, what you do it, everyone is called as a doctor. Can I say that, everybody? Is everyone is called as a common title, something called doctor, first of all. Every doctor knows the basic, what do you call the basic thing? A basic medication that to be given to every patient that they come to you, right? Can I say that? Every doctor knows the basic thing, right? A basic thing to treat them up. Now, technically, but after they do the basic general thing, then they start using the specialization. Say a doctor with a neurology as a specialization, a doctor with a cardiology as a specialization, or maybe called as a different specialization. They do it after they learn the basics of the medical expertise, whatever they needed. Then they do the specialization. But still, everybody is called as a doctor again, right? Nobody called as you're a cardiologist and you're something. So you're a doctor with a cardiology as a specialization, you do it. That is what the title they get it. Now, we want to bring in the same culture within the software field as well. Now, in the software field, now we want to call everybody is a DevOps engineer. Remember, just say that like a doctor in the medical field. Now you have one title for everybody in the software field that is called as a DevOps engineer. Now, we say that a DevOps engineer should know something basic about everything from end to end. Maybe a little bit of the development, how it happens, little bit of the infrastructure knowledge, how servers are created and kept it, a little bit on how to troubleshoot issues on the production servers and so on. So every DevOps engineer is expected to know the basics of end to end, what's happening it. But again, it's not meaning that you have to do everything, right? That is not possible for everybody to do everything, right? Technically, we say that a DevOps engineer with some specialization. Now I call it a DevOps engineer with a development knowledge as the primary specialization for a person, and a DevOps engineer with a middleware administration or a database administration as a specialization. That is his role again. A DevOps engineer with a network administration as a specialized skill for him, right? Remember, it's like everybody is a DevOps engineer with certain specified or a specialization of a certain area in the whole project delivery, we call it. That is what we're calling it. And that is what we want to do it as well. Since now everybody is going to call as the DevOps engineer, remember, that you feel that you're all a single team, right? That is what the main intention of bringing the DevOps culture. A DevOps culture says that everybody is part of the same team. Now, if you are part of a single team, you land your hand or you start communicating with other persons, right? Obviously. So within a DevOps team, we have developers, middleware admins, database admins, network admins, whatever the necessary things to deliver the project. It doesn't matter, right? So everybody is part of a single team. Now, when we say you are a single team, you need to start work as a team, means you need to work with the fellow mates and then ensure that you fix the problem and deliver the project to the end customer. That is what the whole idea team, why DevOps is necessary here, why every organization is adopting a DevOps, and why everybody is talking about just a DevOps engineer, not just a specific developer or maybe the middleware admin or a database admin like that. I hope this makes sense for your team all right now. What is called a DevOps, why a DevOps is necessary. Again, the kind of adoption we do it can improve the speed of delivery for the end customers or a product technically. I hope that I'm clear. Again, we're talking about the DevOps goal. The goal of the development team is to deliver the features into the hands of customer as quickly as possible. So their goal mainly is speed only. But when it comes to the operation team, the goal of the operation team is to maintain the stability of the system and minimize the downtime. Means ensure that the product that is getting deployed on a server should not cause any downtime. That is what I do. But at the same time, they also need to deliver the product quicker. Means you need to do a more frequent deployments and cause no downtime to the clients. That is the goal of the operation team technically. So stability and the speed of delivery is the goal of the DevOps, we call it. No production failures doesn't make any sense, right? Failures can be there. Remember that when you see a failure, something is failing it, try to fix the problem as quick as possible. So we need an immediate recovery from the failure. How can I do that? Maybe by automating something, rolling back to the previous version immediately, maybe, right? Production failures can be their team, but you need to fix them as quick as possible before even the client is realizing that there is a problem there. So that kind of a quick solutions we needed to recover back. Finally, we say that there is no wall in DevOps culture. Means that you need to speak to everybody who are part of the project. You are maybe a developer, but say that you try to know who is the database guy, who is the middleware guy, and somebody, right? You try to speak to them, try to, build that relationship or a collaboration, everybody, and work as a team again. That can give us a most of faster delivery process. That is what the whole idea of why a DevOps is needed here. I believe that I'm clear, team. Again, I'll stop here. If you have any questions, let me know. We can talk about it. Am I clear, everybody, on what is the expectation of a DevOps engineer here? So it's all about the mindset team and attitude, we call it, right? Remember, if you are going to join as a DevOps engineer, right, into any software company or any project in a software company, they usually look at that what kind of an attitude you have it. Are you willing to learn anything new that comes to your bucket or not, right? So you cannot stick to one simple goal of your, say, specialization. Now we say that the DevOps engineers' roles and responsibility here, very few people talk about it. Now, as a DevOps engineer, I would say that very clear again. It's not expected that you do everything, because it's not possible for me, even team, after 15 to 20 years of experience, do an end-to-end things, which is not possible for me, right? So it is not expected for a person or a DevOps engineer to do everything related to a particular thing, right? But having an end-to-end process idea is necessary, like how a developer works in his day-to-day, what tools he's using it. Or maybe the developer needs to know how the application deployed in a production, how many servers are in the production, maybe some kind of the knowledge, some kind of the basic idea of end-to-end process is needed for everybody, right? Then you specialize your skill, right? Know the end-to-end process, how a project is been delivered from the development till the production support, everything. Then after that, you do a use specialization, just like a doctor does the basic thing first of all in the 4 years of graduation. Then they start do the specialization. So your role is also the same thing right now. First, try to understand the end-to-end process, and you be specialized on one particular area, one particular section in the whole software lifecycle. Whether you want to maintain a servers, whether you want to be a developer, whether you want to be only the testing person, whether you want to be somebody who maintains only the databases as a specialized skill, then you choose accordingly. Then start focusing on it as well. But don't leave that. Again, I'm telling you that you are becoming a specialized database admin doesn't mean that you should not look into other issues. So whenever you see certain problem in certain area, ensure that you do a basic troubleshooting and then hand over to the specialized person or specialist on that area. Then your job is done. That is called the attitude and the mindset of a DevOps engineer should be like. Okay. So this is just for understanding, team. Again, remember, as a DevOps engineer, you're expected to know end-to-end process and specialized skills, a couple of them that will help you in boosting your DevOps career. That is the idea. I hope that I'm clear again on this process, why the DevOps is mandatory and necessary for everybody. Any questions again until this point, feel free to let me know. We can talk about it. Otherwise, pretty much we are done with the DevOps fundamental discussion, why DevOps, what is DevOps and everything. We will move on to the next topics, what we can after this. Any questions from anybody are welcomed. So I'll hold now for a minute to see your questions. I will share the PPT, don't worry. Okay, so if you're all clear, team, before we get to the next topic, because it might take time again, so maybe shall we take a quick short 5 minutes break here? So come back and we can start discussing the next topics. Okay. Okay, let's go. A role of a DevOps engineer, everything. As I said, what is the role of a doctor? That he do the basic treatment, first of all, and you be specialized in something. That's what I'm saying it, a role of a DevOps engineer, right? You know some end-to-end process, what's happening, and be specialized in some area. Like you might like only the development, stick to the development. You might want to be some kind of the middleware administration, stick to that. Something like you need a specialized skill on a special tool. That's the role of a DevOps engineer. So how much programming knowledge is needed? Having it is always an advantage, Devendra, but mandatory if you are starting your just career right now. Say that AWS accounts already, right? If anybody has not created your AWS account, so please go ahead and create as well. That's what is recommended. But if you have enough good laptop, you can even set up a Linux VM on your laptops, or the setup AWS cloud free account and create a VMs on the cloud is preferred, right? I'll be sharing the guide, those who have not done. I think yesterday, Piyush might have already spoke to you on how do you create an AWS account already to set up a server on the AWS cloud, basically. That's very much important. That's the lab setup required before we get started with anything. Now, apart from that, what we are going to cover in this course again, what are the different tools to implement DevOps we'll be covering in this course. These are the ones like you see it. So we will start with the version control system with a Git and GitHub learning. Then we start talking about the builder tools like Maven. Now, what are these tools and why we use it? We'll start learning when you start working with them. But right now, I'm just listing the tools that will be working here. The build automation, remember one of the goals for DevOps is to automate everything possible. So various automation tools we use it, like Jenkins is one of the automation tool for certain process. The configuration management is again an automation tool like Ansible, which is also used for various things to automate it. Now, infrastructure as a code, which is a Terraform, which is also some kind of automation, we do it. And containerization and container orchestration are meant for how to run applications on a servers easily, right? Anywhere. That is where we use containerization with Docker, container orchestration with Kubernetes. And once we deploying an application into a production like servers, it is necessary that we need to watch and ensure the application is running without any issues. That's where we implement some kind of the monitoring, which will give us some regular things, alerts and everything is required according. So which is going to be a Prometheus, Grafana, or maybe we'll try to cover something called ELK, which is Elasticsearch, Logstash, and Kibana on a high level. What are they and how do we understand? So these are the different tool set that we will be covering in this course, especially that is part of your planned TOC given to you before you start joining this course. I hope that everybody might have gone through your TOC that is given. I know, team, again, these tools are like the oceans again. Every tool has its own deep dive of it. So we will try to cover whatever is part of your TOC. We will stick to what is part of your TOC. Now, why I'm saying is that again, some people may be feeling that the TOC that is covering only certain kind of basic to intermediate. Some people may be looking for an advanced course, something like on a Kubernetes or Docker. Now, we're not covering, to be honest with you, the advanced parts of these tools specifically, since this is a DevOps course, which introduces the various tools and how do we use them. The course covers up to an intermediate level of all these tools. And with that knowledge, if you have it, you should be able to clear any interviews of DevOps as well. That guarantee we can give you. And also you should be able to implement DevOps. And once after this course, you can start looking into the deep dive. Again, you do not need to learn a deep dive of all these tools, right? Because as a single person, learning the deep dive of all these tools is going to be not possible for you. So What you need to do is that once you understood about what all these tools, how they can be used for implementing DevOps as an end-to-end process, then you try to be a specialization. You try to do your specialization. Maybe you want to be specialized in container orchestration. So you can learn the deep dive advanced course of the Kubernetes or something. Now, if you would like to be specialized in the infrastructure automations, then you go for learning Terraform certification or something. So that's kind of the approach you need to do it. First, understand the end-to-end process, implement all these tools, how these tools work in delivering a project from the developer hand into the production house. That is what the idea is. Okay. So this is the logical idea team, and I believe that everyone is clear, right? Again, I would request all of you to go through the TOC that is given, and the course we will plan accordingly to cover all the TOC given to you. If you are looking for some advanced content than what is being there in the TOC already, right? Means if you feel that you're not in the right course, maybe, then you can just go and ask the Intellipaat to give you the specific things again. None of these tools requires any programming knowledge, so don't worry, right? None of these tools requires any of the programming knowledge. They just need some kind of the scripting knowledge, a basic scripting that should be good enough. Okay. Programming knowledge is not necessary for learning these tools. Okay. So any questions on these basic understanding, lab setup, prerequisite, and this one? But majority of you were there in the session and did it, right, Pavan? Did you do this? Yes. Done multiple times, Nick. Great, not a problem. If you haven't done, Pavan, that's your things to do it. Go ahead and do it. That is one thing. Yeah, please do it. And apart from this one, the way once you create a server, how to log in. Now, this might have done through, like a lot of people might have done through like by clicking on a connect button here on the top, right? Say I have a couple of VMs, I'm not talking about it. Everybody is using connect button here, or is there any other approach you log in? Putty, that's right, Vanilla. So, team, everybody, there are multiple ways to connect to the servers that you do it. Putty, mobile extreme, fantastic, great. Mobile extreme, fantastic. So, right, so here, there are a lot of people, those who are new may use a connect button. But apart from that, I wouldn't suggest the connect button because that may not be the same case in real time. Now, how do I use in real time? You need to get practicing with the real time knowledge, everything. So that's the reason. As a beginner, you may use a connect button, but if you're already familiar with something here, I would suggest you to use these guides again on the Google Drive. There are multiple guides. Say I said connect to the EC2 with the PuTTY options. That is a guide available. How do I get to know PuTTY application and how do I use it? Connect to the EC2 with a mobile extreme. This is also the guide I have given you. Steps to log into the EC2 mobile extreme with an SSH client. This is mostly used by the Windows users, right? Because if you have a Windows laptop with you and you want to connect to this one, I would prefer the mobile extreme than the PuTTY. The mobile extreme allows many more options than the PuTTY does. So always PuTTY, mobile extreme is preferable. Now, for those who are a Mac users, means if your laptop is a Mac or a Mac operating system, then follow this one. So for Mac users, steps to log into the EC2 using the Mac terminal or SSH client, which is a very much important one to do that, right? So this is the logical thing. Use the guide team. It is very simple and do it. Now, both of the guides include one thing. I know that you are all using the PEM file or a PPK file to connect to the EC2, correct? Can I say that, everybody? You are using either a PEM or a PPK to connect to the EC2 instances always. It can be either of that, right? Have you ever logged in with a username and password instead of the PPK file or PEM file? Anyone logged in with a username and passwords? Some people. Okay, great. Now, those who are, yes, in work area, but yeah, AWS EC2 instances also can be done that way. Yeah. So here, I would give you something like after you connect to EC2 with a PEM file, there is a guide that talks about it. This is the basic default approach that you do it. But I say that you can also set up your own username and password if you want to. Now, there is some additional guides, additional things which I set it up in these documents, which can help you in experiencing like how you work in the real time with projects, right? Because the PEM file and PPK options may not be present in the real time again. Sometimes may be there, but majority of the time they will not be there. In the real time, most of the time we use username and password, setting up some custom host names, everything accordingly. So there is a couple of guides I did you here. Setting up a custom host name for the Linux machine that you do it. You can follow this one after you log in. The guide again, just do it at least once so you get some knowledge there. We will do this again in the upcoming sessions, but right now I'm just giving you the upfront ideas. You can practice it for yourself to make it simpler for you later. Now, it also talks about something called setting up a custom username and password for a Linux instance on the cloud. I have given some scripts for that. You need to clone this and run a script called setup-user.sh. The script again is just a simple shell script again. We'll do it. Now, if you set up this one, this will create a username called DevOps and the password called today1234. If you want to change them, you can modify the script accordingly, but right now you can stick to this. Now, this talks about how do I set up the custom host name, custom username and password, then log into the same EC2 instances. That will be more helpful. This will give you something like you work in the real-time projects. Okay, that's why I'm suggesting you to go over these documents, what I'm sharing on the Google Drive at least once, step by step, 100%, and implement. For the same as Mac users as well, I have given, right? Setting up a custom host name as well as the setting up your username and password. The same steps I have given here. So go ahead and then check them and work with them, which is I suggested before you start working it. Which start practicing anything. And apart from that, team, those who are new to the Linux. Now, once you create a Linux server, once you're able to log into the Linux server, now those whoever are not aware of the Linux so far, anything, there is a Linux basic commands document that I gave it here. Now, what is required for this course? With Linux, you can do many things. Again, I'm telling you, but for this course, minimum is these commands you need to learn, right? For those who are not aware of the Linux, for those who never logged into a Linux server, never worked on a Linux server, I would suggest that you complete this document practicals, right? So there are some directory operations like how do I create a directory, how do I go to a directory, how do I list contents in a directory, and so on. Finally, how do I delete a directory within? Similarly with files, like how do I create a file, how do I edit a file, right, on the Linux command line terminals, which is very much important for all of you to go through this, which is a common factor, right? So some copying files, moving files, renaming files, updating the permissions of the files, directories, everything. You go through this document, and it is a mandatory, team. I'm telling you, I'm re-insisting it before I start with any of the tools in this course, remember. If you haven't completed this document, if you're not going through this document, you will face a lot of problems going forward in any of the practicals that we're going to implement it, right? So those who are knowing it, I don't say that you do it again, but the simple idea, those who are not knowing it, because as we said, we have a mixed background of people who are freshers and not having any idea, and you have to complete this exercise on your own. Whatever is in the Linux folder, please do it. The drive link, which I already shared, Nikhil, and I'm going to share it one more time to you. So all the content is available here. So please keep it, bookmark it with you, this one, okay? So team, I have shared the drive link again here. So keep it here and then let me know if you see any issues in accessing. I can fix the permissions right now itself. So am I clear so far, everybody, on everything that I spoke? Introduction to the DevOps fundamentals, what it is and why it is. Now we will have to start implementing the DevOps by learning the tools that are part of this course for you. So team, any questions on anything that we spoke until now? So the architect's responsibility is to, can I say that they are the one technically, the architect role is usually to, give a best solution the project can implement with, right? Provide a solution. That is what it is, right? Give a solution that a project can be implemented, which means that the architect role usually includes knowing the latest technologies, doing a POC, like a proof of concept. Let's say that there's a new tool that came into the market. They have to work with the tool and understand it, how this tool can implement my project. If I adopt this new technology into my project, will it improve my, project scope as well as the client experience and everything they have to do. So remember that the architect role is always to provide a solution, right? The architect role will remain same thing, right? As a DevOps, again, is not about providing something to architect. Architect is someone who provides something to the DevOps, basically, right? The architect is someone who needs to go through the market, find out a new technology, and then how that can be adopted, like the latest AI implementation into my project. How can that benefit my application, right? That kind of a solution they have to work on and introduce those tools to their project and make sure that your project is working with the technology as well as the things. Now, that's how the architect will provide some benefits and solutions to the DevOps. That is what the idea. It's not the DevOps helping the solution architect here. The architect is more than a DevOps you are implementing technically. I hope that makes sense for you, Abrar, now. Am I clear? Yeah. So think in the other way around. It's not the DevOps helping the architect. It is the architect who needs to help DevOps implementation in a more better way and everything. He needs to provide whatever the solutions required to implement the DevOps process into some of the projects. That is how the DevOps architect will be working it in a project technically. Right. So I think somebody else was also asking me this question. I'm not sure which was it, Prasad or somebody. I'm not sure. I hope this answers your question as well, Prasad. I haven't explained anything about that, Vimal, yet, right? We haven't just started it. I just said we're going to talk about this topic, right? Vimal, I haven't talked about it, and we haven't even started talking about anything on the version control. What I was telling was the question, which is architect role. What is that architect role, basically? Okay, that was nothing to do with version control. Okay, great, not a problem, Vimal. Right. So now, since we have some other half an hour time here, now let's start discussing something called version control with Git. Now, what is version control with Git? Now, when I look at this statement team called version control with Git, I get 3 questions in it. What are the 3 different questions in this that we can see it? First of all, what is a version? Understand it. Now, second thing is that what is called version control. Now, the third thing is what is Git, right? Can I say these 3 questions are valid now? What is version? What is version controlling? What is Git? 3 different questions needs to be answered from this single slide here that we need to do. So what's your answer for what is called a version? I say that simply it's a number associated with a software release, right? I say that a version is a number associated with a software release into market. That is what the simple number, right? That is what we do it. So we say that iOS 17.1.2, 17.0.3 something. Now that number is called as a version number. So version is technically a number associated with a software release into the market. Now, why do we need this number is the question. Now, why do we associate every release with a number? As we know, team, we are working in an update model, or we are working in an incremental model with Agile mostly, right? Whereas every 2 weeks you're doing a release, you're making a changes on the existing software itself. Now, we need to know a way to track every change I'm making it, right? So technically, the version helps to track the changes, right? Changes happening to a software or a code over the period, right, of time, we call it, or a period of time, right or not? Can I say that, everybody? So this is the technical understanding team. First of all, try to understand what exactly the meaning of a version in this way, right? Now, we said that we are tracking the changes, understanding from the version definition now. We're thinking that we need to track each and every change that you're doing to a software every day by a developer. Now, how does a developer track the changes? How a developer track these changes is the question. Yes, how developer is tracking these changes? Using a version control tools. That is what the idea. Remember, using something called as the version control tools. How a developer track these changes happening to a software technically. Now, the answer is that technically using a version control tools. Remember that version control tools are also known as your version control system, which is called a VCS in short, or they're also known as basically the source code management, right? In short, that is called SCM tools. Remember, we're talking about again the version control tools. What are these version control tools and how do you understand them? The version control tool helps developer to track the changes, right, made to every file or a code, you call it, right? When I say code, a developer writing a program, he writes in a file. So remember that helps developer to track the changes made to every file or a code, technically we call it. Apart from that, we can also say that it is not only about tracking team. The version control tool helps developer to look at the history. That is another thing. Means I can see the history of changes made by the developer, who made what change when. All those things can be looked into the history easily with the help of tools. That is the simple idea. Now, not only that, right? Rollback, right? Rollback. If any changes to be rolled back, if we want to, we say that simply, right? Roll back to any change if you want it, simply because of the tool is been tracking it. I know the records made it properly, made it. I can roll back to a particular version, particular changes to be deleted, added back again. That can be easily done through the tools. Remember, if a developer has to do these things manually, team, is that possible, you think? What do you think, Tim? Can developer do all these things manually by noting down on a notepad maybe? Technically not possible, right? It is like a software tool that can help developers to do these activities simpler way. So this is the logical idea, team. The two things we're talking about, version is a number associated that helps us to track the changes. How are these changes are being tracked? With the help of the version control tools, right? Version control tools are also known as your source code management tools. They help us track, help us look at the history, help us roll back, revert the changes, roll back or revert some changes if you want, right? This is the technical idea we call it. Now, once we understood this particular party, then we need to understand the types of version control tools, right? Types of version control tools that we use it. Now, since we need a tool. Now, if I talk about the Windows Media Player, or I need a tool that plays the movie, we can look at the different tools like VLC Media Player, Windows Media Player, or the QuickTime Media Player. There are many tools available, many players available. That's the same thing. So when we talk about the version control tools as well, there are many things in the market, right? Now, technically, the types we're talking about it. So when we talk about the types as well, the category of tool, we call it as the local VCS, right? A local version control system tools. The tool name, as an example, I'll give it to you, right? Example is that the tool name is called SCCS, which is source code control system, right? We used to use these things very long back. Nowadays, nobody uses this, right? Let's say that I'm talking about the example of this local VCS tools is this one. Now, along with that, we do have some other category called as the centralized version control tools again.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world, and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Now, this is where people talk about the various tools such as the SVN, right? Or they may call it as a TFS, or maybe a CVS, and so on. Now, these are the tool plays, like, you have a VLC, Windows Media Player, something. We have the different tools here like this. Now, the one last thing in the current market we use is called as the distributed, right? VCS tools, basically. Now, this is where people talk about something called as the GitHub, or you may talk about the Bitbucket, Have you heard about these things, team? Now say GitLab. And there are many more. I can say that not only these things we have it, but say that with respect we talk about it again, right? So these are the different types of version control system tools, team. People were using it. I wouldn't say that we are using all these tools right now here, right? The understanding is that we need to understand what is the difference between these things and how they are being adopted, why certain tools are actually used more in this market, right? Now, I believe, team, you all getting some idea here, the basic understanding. Now you got the version and version control, and technically a Git or GitHub is a version control tool that help us track the changes, which I talk about something called as the local VCS. Now understand, team, how the tool functions. Basically, we need to understand the way they work to understand better about how do you work with it, right? Now we talk about the local VCS tools. Now the understanding of local VCS tools is that, team, what I would say is that remember that whenever a developer, right, whenever a person joins an organization, that you joining a project as a developer, maybe think about it, right? Now, what you will be given is that you will be given a laptop or a desktop, right or not? Can I say that every person joins a software company gets a laptop, right? Or a desktop, basically, usually where they can work on, because we're all dealing with softwares. Now, assume that this is my, a laptop one, which is given to a developer, something. And this is a laptop two given to another developer or maybe a DevOps engineer, whoever it is called. I'm just talking about them as the servers, right? Now, in every server, of course, if I say laptops or something, you always have the OS, which can be Windows or a Mac. I don't care about it. We don't need to worry about it. The one thing we need to understand is that to work with a local VCS tool, now the developer need to install that tool on their laptops, which is like install, right, the local VCS tool. That's what you're calling it as the SCCS tool, right? Now the called, we see that this is the idea. Now remember that if it is a local, I'm saying that every developer would usually install this tool on their laptops. Now this tool would help them track the changes making on a particular software that they work on. So technically, say that if they are developing a code or a project, so they create a project directory, say project X something as a directory. Now where they start creating the code, which is the files, right? File one, when they track it, when they make a save, so the tool will record a version for it like this. For example, the scenario. File two, V1, V2, V3, which means the file two is modified more than file one, technically like this. So technically, all the version tracking here is happening on every developer's individual laptops. That's why it is called as a local version control, local to the developer machine itself. Now, if you try to understand the scenario here, what is the advantages or disadvantages of this? First thing is to make understanding here. Version tracking is done only on local developer machine. That is what the first point to say it. Now, the second point is to highlight is that here, that, right, there is a high possibility, remember, right? We can lose, understand, team, we can lose all the version tracking when the developer machine crashes, right? Can I say that? A developer machine or a laptop crashes, basically. There is something that cannot be recovered. Can I recover anything if something is lost in your own laptops, basically, team? What do you think? The major problem is that we are going to lose. It means that from the last 1 year, we worked very hard, or a developer worked very hard. He tracked many versions in his local only. Now, all of a sudden, after a year, he lost his computer, or let's say that he actually crashed his laptop. Can he be recovered? No, right? It's completely of loss. So we cannot use that. Remember, we cannot be on a situation like that. That is a reason, team, that is a one biggest challenge with this particular local VCS tool is that you could lose all the changes. Now, the second thing is that we also say that collaboration, right? Collaboration between multiple developers is not possible. Now, what do you mean by this? Now, if two developers are working on the same project team, remember, assume that developer one is working on a feature one, developer two is working on a feature two, right? When they tracked the versions of these features in their local machines only. But when I have to release the software, do I need to merge the code from both of them? Right? Do I need to take the code from both of them and then release the software? Now, when I take the code from both of them and I club it, I mix both the code. What is the version to be tracked again? Where the version to be tracked again? Is that making sense? Now, is that possible for me to track something when I add the code from developer one, developer two? I said I added this code. This is the version of it somewhere again. Where does the version is maintained? Is my question valid, team? Is the collaboration possible here? Understanding it? So it is technically not possible. Technically, it is going to be very difficult when you release a software from multiple developers working on a same project if they use only the local version control tool. That is the major problem we need to understand. Now, to address this challenge, team, local version means that it is local to the developer. They track things on their local itself always. Now, to address this particular challenge, team, we introduce the second category of version controlling, which is called as the centralized version control. Remember, we introduced something called as the centralized VCS tools. Now, what do we mean by a centralized VCS tools? In a simple way, the simple example is like you are using your Google Drive. Now, understand that in this scenario, what we say is that we technically have a server which is hosted remotely on a network, right? This server team on the top, I call this as the remote server, right? It's a remote server that can be accessed over your network, something like an EC2 server you created with some operating system. Again, definitely a server should have it. But here is where we install certain version control software, which is like install either SVN software or maybe a CVS or TFS, right? Tool. Remember that the actual version control software or a tool is installed on one remote server, right? That is one thing. And the project is being initiated here itself, technically, on the remote here itself, say project, right? X, I do it. And I say that you might create the files here, something. File one with version one, version two, and I say that file two with V1, V2, and V3, and so on. So, like all the code is maintained on the remote server, all the version tracking would also happen on the remote server itself. The only thing is that, like I gave you the Google Drive and you're all able to connect to the Google Drive and then see the data which I'm sharing it. If I give you the edit permissions, you would also able to edit, right or not? Can I say? If I give you the edit permission on the Google Drive, would you be able to edit it? The files, you can add files there as well? Definitely yes, right? So the same logical idea here is, think about it, that the developers will still work on their laptops only, right? Remember, this is the laptop one, this is the laptop two of the developers, whatever they are. Now, these people are given access to the remote server, means they're asked to connect to the remote server from their laptops, right? And then get a copy of the code if they need it to work on it. Let's say that I will take, right? They take a copy of the code on their laptops like this, means they take a copy, not the version stream here, or let's say that I'll do. Now, when I say that they could actually take a copy, they can take only the file, say project X, I do it. Now, inside there, they get a file one and say that they can modify the files, right? They say that a file two something. Now, remember the scenario here in their local machines right now, there is no version history. They just get the files. Remember, they modify the file and everything. So they may even create a new file here, file three, something like that. Now, whenever they're done with the changes in the local, now they will upload it. Just like whenever you're done with the changes in the local, you upload it. This is also called as a push technically, right? We say that we push the code to the remote. Now, whenever you push the code to the remote, let's say that, assume that if he modified the file one, the remote server will initiate a new version for the file one. Now, since there is a new file is added here, the file one, file three, which is with the version one, it gets stored. This is what it is. Similarly, the developer two also pushed by changing something on a file two. Say this is creating a V4 for the file two. something like that. So the understanding here is that team, all the version tracking happens only on the remote server. The first idea in this logical whole thing here, right? Version tracking is done only on remote server always. That is what the idea is, right? So one thing that is resolved with this one is that the collaboration problem. Remember, collaboration problem is solved right now because developers are not tracking the version on their individual machines. They're tracking all the version in one centralized place. Now, whatever I can take it, I can directly take it from the remote server and release it into the market as a single version. Now, all the files are tracked in the remote itself. So the one good thing is that with the centralized architecture, we were able to solve the collaboration problem, and which is fantastic. But if you consider it, there is still certain problems here. We have it. If we lose the remote server, then we have a chance to lose all the changes or version tracking again. Now you may see this team, I can make a redundancy of the things again. But what if the Google Drive, the Google company said that we lost everything on Google Drive? Can you get it back again? I know that a Google Drive being a highly available server that's there, we can make it highly available. We may think about backing up something on the remote server directly itself. That is a possible solution. We can do it. But what if you lose the actual server, backups everything on the remote itself? Now, how many copies you do keep it? Let's say that you might keep 2 backups and 1 original server, but I lost all the 3 copies now. Can I recover it? Yes, team. Can we recover if you lose a remote server is the question. The number of backups you have is minimal, right? You may not keep hundreds of backups, right? You may keep 1 backup or 2 backups and the original server as it is. So if you lose all of them, there is a still possibility that you lose it. There can be a chances. I don't say it is happening yet, but there is a possibility that can happen as well. Now, the second thing is that the one major thing here is that developers are dependent on the network to make a version change. What do you mean by this? Now, if you don't have internet connection, can you upload something into the Google Drive? What do you think, team? If you don't have a network connection, can you upload something to Google Drive? Cannot. Means you're dependent on the network. You need to wait until the network is online again. The second thing is that your network speed is very low. Let's say that you're using a 512 kbps internet speed and you're trying to upload 1 GB file onto the remote Google Drive. How much time does it take? Yes, team, what do you think? How much time does it take for you to upload with a very internet speed low? You have it. Maybe hours of time? Correct or not, team? Do you agree with me? Now, you may think about, team, where is the internet speed is very slow now. Now, don't think in the current market, team. Think about 15 years back or at least 10 years back. Do we get the same internet speed? Did we get the same internet speed or network speeds at 10 years back? Those who are having a knowledge or those who are working on 10 years back on the internet, you never get the speed, right? We used to work on a line which is of just a 512 kbps from BSNL, right? Not sure if anybody used that. We never had a mobile network so fast. We had a 2G, then we had a 3G, then we have a 4G, right? This one, dial-up connections. So remember that the kind of situation we were in 10 years back. Now we're talking about the centralized, not in the current market, way back, right? So technically, developers were dependent on the network to make a version, right? They have to make it for sure, right? You have to make it for sure, but you're unable to do it because of the network problem. Then the developer's productivity is gone. Developer is waiting until he push the code, then only he can continue on to the next work. Until then, he has to wait it. In a way, your development is slowed down. In a way, your delivery is getting slowed down because of some basic network problem, right? This is kind of a centralized architecture we've worked on, and we ensure this is happening, right? Developer is not able to continue with the next work until he pushes the code, pushes the latest changes he made it. That was the major problem. So network dependency is the biggest problem we had. Now, how do I resolve this problem as well technically? Now that's where team, we introduced, or our people introduced, something called as the distributed version control system, right? In the current market team, I'll say that 99 people are using this distributed VCS concept, distributed VCS tools. We talk about it. Now, the distributed VCS is nothing but team. It's kind of the hybrid model. Now, I hope everybody knows what is a hybrid model, right? How many of you have a hybrid car? Not sure everybody can own it, but I'm saying that nowadays you even see the hybrid model cars. What does it mean? The car that supports the electric power, which is a battery, the car that supports the fuel as well, right? Both of them are possible within the same car for you. You can run the car certain time on the battery. You can run the same car on the fuel as well, sometime like that. That's called as a hybrid model. So that supports multiple things for you. Now, in this case, the hybrid model, in the sense, I will say, now you see the local and the centralized. So we club both of them, which is local VCS plus the central VCS. If you club both of them, that becomes the distributed model. Again, we don't use the same tools here. So we introduced a new tool. Remember, the remote server is always mandatory for collaboration between multiple developers. That is very much important. So here on the remote server, right? Think about it on the remote server, right? This can be like EC2, wherever you had it here. Now you have an operating system here. Now in this one, we will install a tool like this one. Install, like you have the GitHub, or maybe GitLab, or maybe you have a Bitbucket, right? And so on, team. There are multiple solutions which we are talking about it, right? This one that you install, or somebody would install any of these particular tool on the remote server. Now, this remote server is responsible for managing the source code again, code maintained by the developer, files with their versions, v1, v2, file 2, right? That's a file 1, and say file 2 with v1, v2, v3, and so on, like this, right? Now, the remote servers are there. Now, when it comes to the developer machines, now try to understand here the scenario we're talking. So this is the developer machine 1, I'm talking about it, and say the developer machine 2 here, right? Now, every developer having their own laptop with their type of operating system, whatever it is, the OS, right? Which is very much important when I say it's a computer, right? Now, this is my laptop 1 and laptop 2 we're talking about. So laptop 1 and say laptop 2, which is like two different computers worked by the two different developers, consider that way. Now, in their local, now remember, in the case of the centralized architecture, the thing is that they may have a local client as well. Now here, one important thing on every developer machine that they have is that they have to install a local VCS tool, right? Called technically Git client. Remember, there is a local VCS tool that is called a Git client that has to be installed by every developer, mandatory on their local. So we have a local version control tool which is running or installed on every developer machine or a DevOps engineer machines as well. Now on the remote as well, there is one solution that is also acting as a version control server to maintain the version changes on the remote servers as well. Now in this scenario, remember, developers are still connecting to the remote like this. And they can, remember, understanding here, if you try to look into one good scenario, is that here we are saying that the version tracking is, right, recorded or done, right, on remote server and on every developer laptop as well. That is what you see it here, team. The version tracking is done on multiple places. That is what the simple logical idea here. Now here, understand it, what is happening it, developer make changes in local and record the change or a version in local machine itself. That is what they do it. And then push to remote server whenever they want it. That is what the logical idea that you can keep in the mind. One good factor here is that this is a one, right? Now, in a way, we're seeing that developer not dependent on a network to complete a version, right? Or the work, we call it. This is the idea, we call it. Yes, the IDs acts as a Git client here for you always. That is right, Nagarjun. Now here, technically, this is what the idea. Say that the project X, you have it. Say they get the code, the file 1. Remember, in the case of centralized, the version tracking is not done in the local. But in the case of file 2 here, V1, V2, V3 will be there, right? So you have the files, you have the code, you also have the, version tracking is done on every developer machine as well with the help of the local client. Now, whenever a developer makes a change in the local, they don't need to push it to the remote to create a version. They directly create a version within the local like V3 here, right? And if they create a file as well locally, say that a file 3, right? Sorry, the file 3 here I'm doing it, they record a version for it in the local itself, right? Now, similarly, the developer 2 is updating the version of file 2, say V4 something. Now, these developers are tracking everything within the local here. Now, whenever they push it, remember, if they have to share the code, if they have to update the code from one to another, they will upload it to the remote. So when a developer 1 updates the code here, right, a remote gets updated. Remember, since remote also can maintain the version, so with V3, and say that it will also create the file 1, file 3 with version 1. If the developer 2 pushing, it will update the code of the file 2 to V4, something like that. So this is the logical idea here. Remember, this is the logical idea that the version tracking is actually maintained on all the servers. Remember that if there are 100 developers working on my project, again, if 100 developers are working on my project, now there is a project copy and the version control copy is maintained on 100 developer laptops. The possibility of losing the version tracking, version history is very minimal in this kind of an approach. The second biggest advantage is that since the developers are not dependent on the network, they can work faster, they can complete the work faster. Whenever the network is available, they just simply upload. So they don't need to wait until the network is available to complete on the next work, right? They locally work, they locally track it, they locally record everything, and they just update their local changes into the remote when the network is available. So this way, the development becomes faster, and so that delivery also can become faster with the help of the distributed version control software that is used in the current market. Remember, everywhere, like you say, 99 companies are using only the Git and GitHub, or maybe GitLab or something as the version control tool by the developers usually. So I believe, team, this theoretical concepts makes it clear what is version controlling meaning to you, and what are the different version control softwares that we use it regularly to implement version controlling. So I'll stop here for some time. If you have any questions, we can talk about it, right? The only thing I know, it was theory today as well, but I'll promise from tomorrow that we will see complete practical knowledge as again. So we will try to install the Git client tomorrow on a server. You can be ready with one of the EC2 instance created on the cloud, like any one server, right? And then we'll log into that. Then we start working how to install a Git client, and how do I work with a Git client in the local? How do I track each and every change practically? We'll show you, demonstrate it. And we're also going to connect to the remote, which is going to be GitHub. Now, we're not going to set up the GitHub like applications team, remember, because to run a GitHub like website, you need a higher capacity servers, like minimum 8 CPU, 32 GB RAM, something. Now, I cannot set up that big servers for your lab. Remember, that will be chargeable, and then, on the AWS as well. We're not going to set up an AWS servers will be gone. We will use an existing publicly hosted version control server called as the GitHub, right? Remember that the github.com is a publicly hosted version control server that we will use as a remote server. And then locally, we will install our client on our laptops or anywhere, and we start working with them. Okay, that's the idea. Those who do not have a GitHub account so far, you may sign up here by tomorrow. Keep your GitHub accounts ready as well, so that you can experience on how we work in the real time. Okay, that's the idea, team, for today. I believe that you all got some fair and a good knowledge as we did. If you have any questions on anything that we discussed today, we can discuss here. Otherwise, we're done for today. Those who wants to leave the session, they can leave. Okay. Thank you again, team. Do share any of the feedback you want to. We are open to take it, and we'll try to accommodate your request again. Thank you. Right. So if two version names are same but different changes in code, what do you mean by two version names are same? We cannot have a two version name same, right? We cannot have version 1.0 twice in a single repository. Not possible, Vishnu. You may think that the file may be same thing. We will talk about the scenario of how to do multiple files changed by the developers. So which AMI instance should we create for tomorrow? It is the Ubuntu 22.04. If I go to launch instance, Pushpalata, right? This is the one, right? You search for the Ubuntu. Sorry, the typo. NTU, right? You take this one, which is the Ubuntu Server 22.04, which is a free tier eligible one. That is what you need to take it, and you start working on creating instance. With public IP, enable or disable. Enable the public IPs, which is very much important. Always enable the public IPs for this entire course. Okay, do not disable the public IPs. Can we access version in other devs local machine instead of remote server? No, you cannot, right? It's like you're asking his laptop access. Why would he give you Snehat? Now you have some personal in your laptop. Would you give me your access? Your laptop access to me? You wouldn't prefer to give it, right? So it's not a good practice as well to access any version that is available on other developer machine. The remote server is made for that purpose. If you want to get anything updates from other developers have to update to the remote server, and then you take something from a repo. And that is the only approach. You share your code to others share their code to you via remote server, but not a direct access is given. Not recommended. So any other questions from anyone here? Okay, so if you do not have any questions, team, again, thank you so much. Have a great day ahead. I will see you tomorrow with more content working with Git and GitHub Moragon. Okay, I'll see you. Take care. Bye-bye. Assistance with you. I want to create one EC2 instance with Ubuntu Linux operating system. That is what I said yesterday, to create a server. And nobody is going to practice along with me, team. You always have to practice after the session. So please do not execute anything while I'm doing it. Just follow the session, understand the concept, and then ask any questions if you have. If you practice along with me, there will be a lot of confusion will happen. You will miss the topics. So please do not practice anything right now. So this is the first thing, team, that I said. You have to create a VM, and then let's say that we will log into this VM from your local, like using the PEM file you had it, right? This is my PEM file. Now I can do something like ssh-i ipad pem ubuntu @ this one. Now this is the default way of logging in, team, that you all might be knowing it yesterday with the AWS sessions you had already. So this is how we log in to a remote VM, first of all. So assume that we have successfully logged in to this particular thing. So once we logged in, then we have to install necessary thing here. I will talk about it. Before that, let me see the question. How the code moves from his laptop version to exact into the module functionality. Okay, rather discussing like this in a question, Venkatesh, you will see it practically. Okay, how the code moves from when everybody laptops into the the remote system How does it move? Let's see it practically, right? Rather, I explain it theoretically. Now it unnecessarily wastes the time. While we're executing it, you will get to know that. Okay. Just wait for it. And then if you still have doubts, we can discuss at the end. Okay. You have to check out the files, modify and check in back if the code to the Git. Once the module are completed, then merge request can be raised, merge codes. This might be your query, Venkatesh. Okay, so anyways, yeah, you are going with the things. Right, let's discuss it practically so he will get to know. Thank you, Srinivas, for that. Right, you're right as well, in a way. Yeah, let everybody make it clear on that point. Right, so now, initially, let's try to understand how the tool works, right? Then we talk about the collaboration part. So the first focus is to understand on how Git tracks the changes. Then later, when we move into the remote, then when multiple developers are working, how the code gets merged or how the code from different developers gets added into a single repository. What is the approach should be done? We will see it practically as well. So let's work on it, right? Now assume that now this is the server team that I created on my AWS. I would request everybody to next 10 minutes or 15 minutes, listen carefully. And after that, you can ask your questions again. Now, the first thing, as I'm telling you, team, one more time, I have created an EC2 instance on the AWS cloud, the same thing, which is a T2 micro, which is a free tier instance, which is sufficient for us to do it with some, key that is attached to it, with certain security group that is attached to it, just like you do on everything. Now, once we have created it, now in order to log into it, now you know how to do it from your local machines using a mobile system or maybe a POD or maybe your Mac terminal, whatever it is. We try to run SSH command and then it will log into it. Now, once after you log in, this is what you see. Ubuntu is a username logged in. This is my host name. I have told you how to change the host name that you can work on. Now, the command here I'm running is called hostnamectl, just to show you that which operating system I'm using it, which is the Ubuntu 22.04.2 LTS operating system, right? Which is a Linux operating system. As you can see, it is a Linux. Now, on this one team, unlike the Windows or a Mac, the Linux is always mostly the command line. Now, you have to make sure yourself comfortable on the command line. For any task you want to do, you should be running a command. That is what I gave you the commands yesterday as well. Now, first thing here is that now we need to install Git client software. Consider this is your local VM right now, like this, say. Now, this is the VM or this is the server that you have created. Consider this is like your laptop maybe, right? This is the VM you're calling it or a server. Or consider it is the laptop that developer is working on right now, right? But he has some basic operating system called as the Ubuntu Linux OS. Now, the first task in this machine team or in this particular computer is that what you need to do is that you need to install a Git client software, right? Install a Git client software. That is what we want. Now, how do I install this Git client software and where do I install it, right? So the official documentation can be referred for installation. So you can go to the Google and I say that Git client installation, something you do. Second. Right, so if I do it now, if I say simply Git client install, now it will go to the page called Git SCM downloads. Right now, this is the first page. I'm just walking you through slowly so you can see this page basically on the web, which is basically telling you that, hey, you can install the Git client on a Mac OS or maybe a Windows or maybe a Linux based on wherever you want to work on it. Now, we are going to work with a command line, but we do have some GUI clients as well. If you want to work with GUI clients, you may work with them. But as a DevOps engineer, it is necessary that you work with command line mostly than the GUI. Developers may be working on a GUI clients, that's okay. But as a DevOps engineers, apart from the developer, so whoever it is, basically, it's preferable that most of the time they work on the command lines. The more comfortable on the command line, the more good it is for you. So in this scenario, we will be working on the command line. So again, as I said, you could install on the Windows or Mac as well if you want to. You can follow the instructions accordingly given. Right now, I'll be following the instruction for the Linux or Unix, which I'll click on this one. Now it will go to the page where it will tell you. Now it depends on the operating system that you use again, right? It will give you the installation instruction. Like if you are using the Debian or Ubuntu Linux operating system, follow these. If you're using Fedora, then use this one. Likewise, you have a different types of operating system that has to be used accordingly. The commands have to be used accordingly. Now, in this whole scenario, if you try to look into the Debian Ubuntu, now there is a command that they're using is called apt-get or apt repository, apt update, apt install something. Now, what is this apt or apt-get technically, right? In a Linux team, as I said, even if you want to install, uninstall, update, remove, delete some things, you have to use a command line commands. Now, if you look into this, what is this apt-get command in Linux, right? Or if you just use one, what is apt-get is used for technically? Now, apt-get is a command line tool interacting with some library, right? Or it's also called as the package management system for Linux distributions. Remember, it is going to connect to some online libraries. It allows you to search for, install, manage, update, remove a software, right? The tool does not build software from the source code. That's what it says. It's just going to search for something, install and manage updates for that particular software, right? That is what all we are trying to tell you. Remember, the apt is a package manager utility or a command line utility that helps us to install, uninstall, upgrade, remove a software packages, anything that you want to install on the Linux operating system like Ubuntu. We use this apt as a package manager, right? There are different approaches, but this is the easiest approach that we are going with. Now, this command would also require an internet connection for you always, right? So this is the logical idea. Now, with that being said, this is where we will be running the instruction that is given by it. So I'll go with this one. Now, if I try to run, first of all, way to search, which I'm giving it, which is the add apt repository and the repository address I'm giving it. If I take this particular command and run it here, now you will see some issue, first of all. Like it says that must be run as a root. For those who are new again, remember that when you log into your computer, you can be an administrator for the full privileges, or you can be a normal guest user with a minimal privileges. Now, this Ubuntu user is like a guest user, which does not have a super privileges, administrator privileges to install a software. Now, the user must be provided super user privileges, then only it can do. So what I have to do is that I need to switch to the admin user. Now, that is called a root in the Linux, basically, in a way. So in order to switch to the root user, I would run a command called sudo su-. Now, this command help you to switch the user from the Ubuntu user now became a root user. The root is a user here, Ubuntu is a user. Now using this user is a super user or administrator in this Linux system right now, which can run any command without any permission denied problems, right? So I'll take the same command and I run it again. When I run this time, it will start running it. It is asking you to enter, hit enter. Now you see it started connecting. Now, remember, we're trying to add a repository, which is referring to this address, basically, as you can see that, right? It is actually going with this particular website and then connecting to it technically. Now, once you do with this, right, let's say that we will try to run the second command, which is apt update, right? This is what I'm running it. It just tries to hit something and see whether the repositories are reachable or not. Here it is added, here it is hitting it, and then seeing if it is connectable or not, something like refreshing the repositories and everything is working good. Now, once you do it, let's say that we're going to do something called as apt install git. Now, this command will go to this website, right, above added, and then download the software, then install the software into my Linux system. That is what it is going to do. So when I do, it is asking you, say yes, whenever you want to do. This is the idea. Right. So, all right. So thank you, Vanilla, for that. Right. So sudo -i is interactive as it is. Now, sudo su is that basically su means that a switch user. Right. Thank you, Vanilla, for answering that. That's the answer, Harshit. So interactive you want it. No, we don't want. Su is switch user to automatically switch it for the other user you wanted. And a dash refers to reload the profile from the scratch, rather just switching the user. That can be done. Right. So now, as we see, team, we have successfully installed the Git client software. Now, how do I check it? Basically, that we can run a simple command called as git -- version. Now, once you have installed any particular software on a VM like this, you could run the command line, which is given by the tool to do this one. The git -- version is now showing you the Git client version that is installed here, which is 2.43.0. Now understand that we have this VM here. Now we have installed a Git client software. Remember, as I said, there is no dependency of the remote at all to make any versions here. Technically, the project or the developer can work locally completely and create versions or track versions, everything in the local, right? Now, how do I do that? Now, as we know, team, remember again, right? Understand, team, with your operating system, anywhere you come with the various directory structures, you need to understand it. Now, with my installed operating system, I have these many different directories, right, which are related to operating system and the users can work on accordingly. Like in your Windows machines as well, a laptop as well, you by default get many files under the C drive where your operating system is installed. So that has the different. Now understand the slash is like your C drive here in the Linux, in which you have all the system related files, everything, from where you move forward accordingly, right? Now in this one, remember, you could choose any directory where you want to put your project on. And right now I'm in the folder called as the /root. /root is the user home directory of the root user. That's what we see. No, I don't want to create here. I want to put it on a similar different directory. Then choose where you want to go. Like say I want to go to OPT or something. Then I switch the user or switch the directory here, sorry. And then within that directory from where I would like to store my project. So that's your choice that under which path, which folder you actually want to put your project on and start working with your project. And remember that by default, we do not want to track every file available in these directories. That is the meaning I'm trying to say it. The Git client is installed doesn't mean it is going to track everything in the operating system files, everything. Now the Git should track only what I asked it to do it, what I asked to track it. So that is where we can go anywhere. I'm saying it, that's your choice. But right now I'm going to the OPT, right? And then I'm saying that I'm creating a folder called mkdir. I'll say that project X something. Now you can create any directory. Mkdir is a command to create a directory here, like creating a folder. Now, once I do, I can list the project X is present. Now I want to put all my code inside this project X folder only. So I'll go to the project X folder with a CD command again. Now, once I go inside it, remember this is an empty directory, right? There is nothing inside it. Now, what I want to do is that technically from now onwards, if I make any changes here, like I may create a file, I may modify a file, I may delete a file, something like that, the Git should understand what I'm trying to do and help me track that change. Now to do that, now how Git tracks only this particular directory is that we need to ask Git to work with this. So that by doing something called as git init. Remember, now inside the project X, I'm running a command called as git init, which means that I'm asking Git to start watching this directory and track any changes happening in this particular directory going forward. Until unless you do a git init, Git won't start doing tracking changes here, right? So I do a git init simply. Now it says some messages here, whatever the things you wanted. Now it says something at the end, something called initialized an empty Git repository under the folder that you have chosen accordingly. This is the logical idea, right? Now, this is the first thing we are trying to do. in this directory still there is nothing. Remember that we just initialized. So Git now understanding if there is a change happening here, Git will start tracking it. Before we doing anything again, you could check. It is also necessary, team, to understand that technically, like as we discussed, like when multiple developers are working on the same project with the different modules, understand that the Git should track the changes on each developer name. Correct or not? Can I say that? Means if the Naresh making some changes, Git should say that, hey, Naresh made these changes. If Vinila made some changes, the Git should say that, hey, Vinila made this change. Similarly, Harshit made some changes. Similarly, some other person made some changes. Correct or not? Yes. That is a basic necessity that Git should do it. Git should tell us that who made what changes, what time. That's the very basic thing that everybody should be understanding. So in that scenario, that how Git knows my name here, right? How Git actually knows my name in this scenario. So I should tell the Git my name, that is where I'm talking, that once after we do it, we say that git config, hey, this is my name, store it with you, and then record the changes with this name. So git config, I do it, user.name, I'll say Naresh. You could give any name as you wanted. I'm just configuring the Git with, hey, this is my name, and this is my email address as well. Say that I also put my email so that people can reach me on the email when they look at change. So naresh@gmail.com. Now, this is a very basic and very important thing. As soon as you initialize the repository, the next thing you tell the repo that, hey, this is Naresh, I'm working here. You record the changes on this name every time I record a change for you, right? That is the basic understanding. So we understood to initialize it. Then we understood about how to configure it. Then if you want to check the status, git status I do. The third command, which I'm trying to tell you right now, the git init to initialize the repo. Git config is to configure the username and the user email as well. We can use it. And after that, if I'm using a command called as a git status. Now, what I'm saying is that asking the git, show me the current status of this repository or in the local. Now it is giving you some messages like on branch master, no commits yet, nothing to commit. Now we will understand each and every word here. What is branch? What is master? What is a commit? We need to understand all these things. But as of now, you need to say, it says nothing here, nothing in the current repo. That is what the meaning of it. Correct. Because we don't have any files here. That is the idea. So this is the few important steps, team, that everybody should be aware of before we start working. Just for a quick recap again, we installed a Git client software. Then we tried checking the various directories available, and then we decided to go to OPT. Then I initialized our project X directory. Then we switched to it. Then we started asking Git to start tracking that particular project X. Then we said configure my username so it can track with the changes and checking the current status. I believe that I'm clear until this position, team. Whatever we have done, we can do this. As of now, I will not be pasting anything, Chandrakant. I will share all this command history to you on the Google Drive after the session. So please do practice everything after the session that you can do it. Okay. But I will share each and every command that I'm running it, so don't worry about it. Right. So now, once we have done, any questions until this point, everybody? Am I clear? No questions, right? Okay, great. So if you have no questions here, then let's move on. The next part we want to understand is that start making changes. Now, what is a change again? Now, within my project directory, as of now, there is nothing. Now we need to start making changes. So what exactly is a change in a Git repo? Yes. What's your answer for that? What is a change? What do you call as a change? Change in a Git repo, technically. Now, the simple is that if you create a file, which is a new file, basically, that's called as a change. Or say that you modify, or you may call it as an update a file, That is it. Remember that Git tracks only the files, no directories. Remember that if a directory name is created, it won't consider it. If you have certain files inside it, again, it will consider it, right? So again, if you delete a file, that's a change. Remember again, in a Git repo, whether it is on a remote or a local, basically, whenever you do these three actions, Git considers that you made a change and will let you know if it has to be tracked, recorded as a version or not. That is what all we want. So in the local repo right now, say that since we do not have anything here, let's create a file first of all. Now I'll initiate a very basic file, which is the empty file. Say touch one.java, whatever the q.java, whatever you want, right? Now the file can be anything, team. It doesn't need to be a Java file, but I'm just taking an example of some extension for a file like this. Now, once I do, let's say that I created a one single file. Now, as soon as I created a file, let's say that what Git is going to tell me, say Git status, right? Now, if you see this, earlier it says nothing. Now, right now, it says that untracked files, that is one.java, means Git is able to recognize that I have created a file called one.java. And it says that, hey, I didn't track this file yet. Do you want me to track it? That is what the meaning here. Now, if you want really to Git to track this file, now you need to tell what is this file and what you have written inside. As of now, it is an empty file, but say that technically one.java, I'm editing. Remember, the VI is a editor like Notepad on your Windows machines. This is a command line editor. Basically, if I say VI and the file name, it will open the file in the editing mode, like you open a Notepad and you start writing it. So I use this particular VI and one.java. Now this opens up the file here, and then you can write it. Say, hi, how are you? Right? Now you can write anything, but I'm just writing some dummy text right now. So understand that. First thing is first, you have created a file as initial one. Now you have added some code in it or a basic thing. Now, after you adding a change or making a change to you should let Git know what exactly you did. That is where we do something called as Git add and the file name for now. Now, by doing an add, what exactly Git is going to do? Git is going to record a change accordingly, or is Git going to read things? When I do a Git add thing, that remember that you know that you created a one.java and you know that you added a line in that file. But how does Git know here? Now, when you do a Git add, basically, Git understands that, oh, you have modified this file, and Git also reads the exact line you modified or added in that file. In this case, remember, when I do a Git add, technically Git goes into the file and sees that, oh, you added this line. So let me remember this. Remember, it is like in the temporary memory, right? Remember, like whenever you do a Git add command, Git add something, Git read the file and Git kept in its brain right now. Tell me something, team. I asked you to read this now, right now, or something that I asked you to read a paragraph right now that was in your brain sometime. You can repeat it maybe in the next 1 hour or so easily. But if I ask you to repeat the same after a week or 10 days, would you repeat the same thing exactly what you did? Until unless, for example, you might have noted the paragraph on a notepad and then keep it away. Later you can see it and read it maybe, but how long you're going to keep in your brain? Making sense, team? Understand something? Something that you see right now that is in your brain, but if I ask you to repeat the same thing after a week, like I asked you, like, hey, you did on that day, what time exactly? If I ask you to do it, it will be difficult for you to do it. Now, the same thing is with the Git as well. Now, when I do a Git add, it's just like on the Git memory, a Git brain only, right? Now, if a Git has to remember this permanently, now if I have to go back and check in the Git history that somewhere it is having it, now the Git needs to record this into a permanent disk, writing somewhere in the notepad line. Now that is where, team, it is necessary that you do something called a Git commit. Now, what is a git commit basically here? I'll say that, hey, my first commit, I do something. Whatever the message that you want to give it, -m stands for message. And within the double quotes, you write a message like, why are you recording this change right now? Remember, I created a file. I wrote some text in the one.java file. Now I want to record the change which I made it as a version, as a record history, version history in my Git memory, right? Now, when I do a commit, Git records it into the hard disk, like you wrote it on Notepad. Something was on the brain, then you write it on a notepad. Similarly, when I do a git add, it was on the memory. Now, in the temporary memory of the git. Now, when I do a git commit, it writes that information onto the hard disk where you're running the git commands. Right now, it is my virtual machine's hard disk where Git stored this information permanently. Now, since it is stored on a record on the server right now, I have a privilege to go back and check it. The whole purpose of the Git is to show me the history, what is being done, when it is being done, or done by whom as well. Now, I want to check the Git record history. I do a git log, right? Now, the git log shows something that is called a commit, right? Remember, this is a random ID or a reference ID reference to a particular change you made. Now, remember that Git is not going to show you like v1, v2 of the files. Git says that, hey, there is a random hash value ID, a unique ID will be given for a change interacted or recorded on the disk for you. Now it tells you the commit ID so that we can use this ID for the later reference on how to see it. Now, who did this, which is author, the username and email that I configured. Now, what time I made it, which day, which time exactly to record it, and the reason for it, it is given to you. Now, how do I know what I changed in this particular commit? That I can simply see called as git show, right? Git show, hey, show me the changes you recorded in this particular commit ID. Remember, commit ID is a reference point to refer to a change you made it at that particular position or a time in the Git history. Now, if I do this, now it says that, hey, you have modified this one.java. It's a new file. And I do see that you have added this text in that file at that point of time. That is the simple idea. Now, this is kind of the version 1 of the one.java file. Now, if I go and modify tomorrow, say today I made this change, tomorrow I come and again, I'm adding one more change. Say, I'll open the file again, vi one.java, right? I have done something. Now I'm adding some text, some random text only I'm adding it like this, something like you write a code. I save it. Now, at this point of time again, remember, Git did not know yet what is exactly the line you wrote in this file, right? Now, this is what all I'm saying it. Now, if I go on add right now, git add one.java. Now, whenever you do a git add, it compares what was there in the previous. Now, what exactly the line you have written, it remembered that line again, right? If I do a git status again, it says that you modify the file, which is fantastic. Now, I also came to know what line you added. Now, if you want to record that again, say that git commit -m v2 of one.java something. I'm just saying for your understanding only, this is not how it should be, but I'm saying it. Now, what exactly happened in the second commit? Now, if I do a second time record, the same file is being modified second time, right? Now, Git remembers that each and every change you made on that particular file in the history. Now, in this commit ID, it says you modified or you added a new line. Now, if I look into this, in this particular commit ID, the second version of that particular thing as a commit ID, now it shows that, hey, you added this line in this particular thing. Now, this was the previous code. It says there is nothing. Now, you added the two empty lines and there is a new text you added in this commit. So it shows that exactly what you added. It can be 10 lines or a 20 lines, doesn't matter, right? Whatever the amount of block of code you added in that file, it will show you that, hey, in this commit, when you recorded this version here, this is what the you code added. This is what the code you added, something like that. So likewise, if you keep adding the changes into a file, Git will help you in finding that exact change you made on the file at what time it done by whom, and so on will be recorded. So this is the 3-step process in the Git, we call it. Now, again, remember that whenever you make any change, doesn't matter, right? I again open the 1.java file. After that, I'm writing it hello, 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 something. I'm writing something like this. Again, I save it. Now, along with that, it is need not to be same 1.java theme. There is a flexibility that you can also add multiple files. I'm also using touch 2.java, say touch 3.java as well. Like I'm creating 2 more additional files and I'm writing something in them as well. So 2.java, right? This is a 2.java content like this, right? Now, it is necessary that whenever you create any new file, whenever you modify any file, you need to tell the Git what you did. That is by doing the git add. You can do 1.java, 2.java, 3.java. I know that it is going to be difficult for you to put all the file names if you have n number of files there. Now, instead of that, we can just simply say, hey, use a dot. The dot refers to the current directory which you are in. Now, whatever the files that I modified, created in this local directory, you get to know everything, right? If I do a git status, now it says that, okay, you modified 1.java. You have 2 new files called 2.java and 3.java. Whenever I do again, I'll do a commit, say git commit -m, right? A new code for feature 1 something, right? That whatever you want to do it accordingly. That is weird. Now commit it. Now, as soon as you commit, again, it records the change, git log, that it creates a new reference ID called the commit ID in the repository. Now, this commit ID is a reference for...
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
Different changes again, like if I do a git show that particular commit. Now it says that, hey, this was the content which I already had in the 1.java. Then you added this is a new line in this particular commit. Along with that, you also added a new file called 2.java with this content. And there's also a new file called 3.java, but which is an empty file here. There is nothing. So as you can see that every commit refers to a particular change happened on a file, maybe a multiple files as well in this scenario. So this is the logical idea, team, that how we work in a local Git repo, or how usually we track changes of each and every file in the local Git repo, right? So this is the 3-step process, team, we talk it. So this is what we just did it. First, we created a file, right? And then we told Git that we created it, modified the lines, and then we committed. Now you can see the content of that particular commit generated by the Git. Now you repeat the same process. You make change, you add change, you commit it, and verify the record if you want. Again, you make changes, multiple things, not only the one file always, you can also modify multiple things. You add them and then you commit them, then you review them again, like what you wanted. Now this commit ID is a reference point, even that will let me revert the changes that I'll show you how to revert later. But right now we keep recording the changes so that we have a track of every change we made it on the files related to your source code or application development, we call it. So this is the 3-step process, team. I believe that I was clear until this position. If anybody has any questions, let me know. We can talk about it. We have to first add all those to Git, then a commit. So we will need to write all those 10 files and add them one by one. I think you got your answer, Nadir, right? If you have multiple files, do whatever the files you want to write a code in, then you do a git add dot. That's it. So it will add everything there. So team, everyone, am I clear until this point? Any questions on this particular 3-step process of the Git, which we just discussed with the different commands that you came across? Git add, git commit, git show, especially, and a git status command. I see a very few people responding. Shall I assume that everybody is good? Git show is to see the content of a particular commit, right? Show the changes made in this particular commit ID, right or not? Git is recording all the changes as a commit IDs. Now git show is that to show the contents I modified in this particular position, right? That is what is a git show command. Right, so git push is not same as a commit. We will talk about the git push later, Neha. You will see that. That is from the git log command that you see here. When I do a git log, you do this commit IDs, right? When I get this commit, when you do a git commit, the commit ID is created. Later that you see a git log, you see all the commit IDs created by the git. So from that you get it and pick it up. So Git repository where we are saving, transferring this data. I'm coming to that, Nikki. Just give me a second. Right. Now, just for a quick thing again, let's try to understand like this here. Now we're talking about the 3-step process in the local. So let's read this one more time, clearly everybody. Now the git local is something like it's a directory or a folder. Say for example, my project or project X is technically a directory on your computer or a server. Now the first thing we call it as the project directory is also known as your workspace or a work area, just like the current folder that you are in right now, like project X folder in our case. Now it is the place where you create, modify, delete file physically, right? As a developer or a DevOps engineer, we work in this workspace. Now remember, the folder that you are in right now can be considered as your workspace or the work area where you create, modify, delete files and record the changes accordingly. That's called as the first thing. So you touch, VI, delete something. Now, once we're done with certain change, once we wrote a file with code something, then we should let Git know what you have exactly written in a file. That is where we go to something called a git add command, right? Now we did a git add. Now, when you do a git add, basically, this is called as a staging area, more technical terminology of Git, the staging area of index area, we call it. Technically, what is this area? It is an area where a Git takes a snapshot for every version change made to file, like every line you have written in that particular file, it will take a snapshot of exactly what you have written. Now remember that it is a buffer zone between the workspace and local repo. Wait for a minute, and we can't see this region as it is a virtual area maintained in the memory, right? Remember, there is a possibility something is in the memory can be lost if your computer crashed or restart or something. There is a possibility of that. So technically, this is a temporary space only that Git remembers for a certain amount of time, as always do. Now, once the Git understood what the change you have made technically, then we ask Git to record that as a history so that I can refer it later, right? Remember why we're asking Git to record it, write it on a disk, that I want to come back later and then look at the change. In case of something is bad, I can also revert that. Now, that is where the third step comes in picture. That is where we do a git commit. Now, when you do a git commit, the changes are moved from the virtual memory area into the permanent memory, which is your hard disk. Now, the local repository or a commit area, we call it, it is the place where Git stores all the commits locally. Remember, we're still in the local only. Locally in a .git directory inside my project directory. Now, you didn't see this, but let me show you. Inside of your project directory, it looks like you have only 3 files. But remember, there is some hidden directory called as this one, ls-al, you write it, which will also list a hidden directory called a .git. Now, every commit that you're making it, remember, every record that you're making it, now this is considered as your local repository where it stores all this data, right? That is what we're saying at. The .git is a hidden directory in your project directory so that no one can delete it accidentally as well. Now remember that a commit ID is a reference for the changes made to a single or a multiple files saved to hard disk on your computer. Now where they saved in your hard disk, that is under your .git directory. That is for the Git purposes. You should not be going inside or modifying it. But if you want to check it, I can say ls-l.git. It has its own content in it. Objects is where it actually stores all the commit history for you, right? But again, I'm telling you that this is to be used by the Git. We should not modify, delete something in this one. It is done by the Git for you. You just look into it, it's available or not, right? So this is the idea where it is actually putting all the data right now on my local hard disk, on my local computer's hard disk, inside a project directory where you did a Git in it. It always has called as .git, where it will store all the changes within the local itself until unless you move them to the repo, right? I believe this answers your question, Nikki, and everybody as well, like where Git is storing all the recorded changes in the local hard disk of my computer itself. I said whenever you do a Git commit, something is written on your hard disk. Like you create a file on your laptop hard disk, you know where it is written, right or not? Netradeep, right? Or Mohit, I can call it, I believe. So if you create a file, you know where it is created on your laptop. Like you might use a C drive, D drive under a particular folder somewhere, right? The same thing we're saying it when you do a Git commit, the commits are stored under the directory called as this one. This is right now, it is not in your personal laptop. If you have installed the Git on your personal laptop, it will be somewhere. Since I have I'm running this commit on everything on the EC2 instance right now, this is storing on the virtual machine that you created on the AWS cloud. Not in your personal laptop. It is right now storing on the hard disk of this particular computer that you created on the AWS cloud, not on the local, not on your laptop. Okay. I hope that makes sense. Yeah, great. So now, once we understood this, maybe before I go with the few more commands and understanding everything else with Git repo, let's take a short break for 5 minutes. We will be back in 5 minutes, and then we will start understanding more things after the break. Okay. These commands are used by both developers as well as the DevOps engineers with some specific specialization, like infrastructure automation, the cloud automation. Like there are many things we do. So yes, we do use these things accordingly. Okay. That's why we are learning, right? That's why it's very much important. Okay, so getting back to the discussion theme, as we are talking about the way we actually ask Git to record each and every change that we are tracking it, like with the commit IDs. Remember, the commit ID is a reference for a particular change made on a particular file or maybe a couple of files as well that we can simply understand so far. That we did modify multiple files and we did modify added files into it. The next thing is that the purpose of this history is that if I want to revert certain change, remember, if I want to revert certain change which I made it, I can simply use the git revert command. For a scenario, if I open this one.java theme, remember that we have added first this line, then this line, then this line. Means think about it in a way that you have wrote this is 100 lines of code, another 50 lines of code, another say 50 lines of code. Now, for some reason, you wanted to delete the one of these code from the file. How do I do it? Now, do I have to open a file and modify it? The answer is no, right? Now, the record that we made here, we made this file. In the second commit, we have known this one. In the third commit, we have known this as well. Now, first, suppose if I want to delete this particular code I have written, now I don't need to even open the file. I know that I can see the commit say git show this one. Now it says that, hey, in this particular commit, in this particular commit, we say that this is the line you added. Now I want to undo this particular thing here. Then what I can do is that simply one simple command is called as the git revert. Git reset is little danger. Git reset does not work with the file name either. So the git revert, it is not the file name we do it. It is the a commit ID in which you have made a change, you have to delete it. So technically we use the commit IDs as the reference to delete. So it is a v2 of 1.java something. Now I do a git revert of this particular commit, which means that whatever the changes that I have recorded in this particular position or a commit ID reference history, delete them, revert the changes which I made it, right? So technically if I do now it says that there is a conflict either, that you can clearly see that. I'll explain the conflicts again, how do they come up, but let's say that we can now try to run this git revert continue. I'll explain the commits team, so don't worry about it, right? So this is what all I'm trying to do it. Now say git revert and continue if you want to really do that. Now it says that technically, again, it has some issue. Committing is not possible because you have unmerged. Okay, fine. So it says that it is deleted, but it is not able to commit it. That is the reason. Now, if you do this, basically, if you see this, basically what it says is that whatever I did here, something, it deleted as well. Now, if I open the file 1.java here, now you see that it is technically saying, okay, you are trying to delete this file, this commit, which is already been modified one more time for you. So what I'll do is that I'll just open up this file. Okay, I'll repeat the scenario team, so don't confuse here for you. I'm just going on with this. Let's say that, whatever it is, right? Just to show you the reward again, I'll just show you one more time. So let's say that git add dot, and I say that git commit -m. See that modified 1.java. So forget about whatever we did team. I don't want to confuse you. Let's say that git log, you see it. Okay, you have certain commits again. See that one more time, I modified this 1.java file at the last commit. That's okay. Now, just to repeat the scenario here, like whenever you have certain changes done on a particular file and you really want to delete the changes, right? Then we can do something called a git revert. Now, how do I do that again? Let me repeat the whole process for you just to avoid confusion. Now, what is a conflict and why does it occur? I'll explain it later or no time. But right now we want to understand only the revert command for a second, right? For example, I'm creating a file here, touch4.java, or I'll say that vi4.java file, right? Hi there, something. Now remember that there is a file that we created. This is the 4.java file, which is present right now. And I say that add it to the git memory. And I say that git commit, say that added 4.java file. This is what the simple logical idea I'm doing it. Now, what I want to do here is that technically, now whatever the changes I made with this particular commit, which is like adding of 4.java and all of its content, I would like to delete it, right? You may delete a file and commit it, that's a different case. But technically, if I want to delete the changes of a particular commit here, as I said, we can simply use called as the git revert, right? Git revert and this particular commit ID, which I'm asking you to, or I'm asking Git to undo whatever I did with this commit ID, the latest commit ID in a way. So I do a git revert, that commit. Now again, it just opens up an editor team here. That's it. It says that I'm reverting this so and so. Are you good with this? Yes, I'm good. Say Control S and Control X. That's gone. Now, if you look at it technically, that the 4.java is deleted. Exactly what we wanted is that undo. Like we added 4.java and we want to undo whatever we did that. So it is undone technically. So the git revert command team, in a way, it will help you in undoing the changes of a particular file or a particular changes on a file can be done through this, right? So this is the idea about how do I work on a revert command and how can I see simply that. Sometimes when you do a git revert, as you see, you got merge conflict. I'll explain what is a merge conflict, what is merging everything in the upcoming sessions. Right now, it is too early to understand the merge conflict concept for you. So keep that aside. And simply understand that technically a git revert command can be used to undo the changes which are made in a particular commit in a way. I hope this is clear to you now. If you have any questions on the git revert command specifically, let me know. Git log shows the records of everything vanilla. Like as of now, we have seen only 5, right? So you see only 5 or 6. But for suppose if I have hundreds of commits from the last 1 year, then it will try to display everything on your terminal itself. That's right. Git log shows everything recorded so far from the first time of the repository started. So git revert, as you understood technically, right? Git revert is to delete a change and do it. Now, in this scenario, if you observe it, Nikki, git log that I see it, when I perform the revert, basically the git log shows there is an additional commit created and says that it is actually did a change, correct or not? That's what the understanding of git revert command you do it. Make sense? Git revert is something that deletes the changes in a commit and creates a new commit to say that, hey, I deleted that. Correct or not? Can I say? Yes, Nikki. Is that clear with the git revert command? Now, in a way, if you do a git reset, right? I'll show you that as well again, but the git reset will actually delete the commits. Means in the log, there will be a record that you did something. For example, now I want to reset something in the Git repository here. Now I want to delete this entire reference in my log and I want to go back to this position, right? Now what I do is that simply git reset, right? Reset to a position. Remember, if I give this position, it will delete all the commits above, leaving no clue that somebody deleted some files, somebody deleted some changes. Say, for example, I want to go back to this position. It will leave no history of this 4.java, added, removed, everything. So remember that a git reset as well, we go with a commit. Now, if I go with a git reset to this position, remember resetting back to certain position in the repo. Now I do a git reset and say that -- hard and this one. Right now, there is a command to use it, git reset -- hard and do this one. Now remember that I want to go back to this. So I gave that commit ID, leaving no clue that somebody did this one. So let me show you that. Now what it says that, basically it says that head is now at A8 something. Now what does that mean technically? It is deleting all these commits. Can we see? Git log, I see it. Did you see the difference now? That a git reset is very more dangerous because it leaves no clue that you deleted something, you reverted something. So it is not a good practice to do a reset. It is always good practice to do a git revert command itself. That's right. Until it is approved, until unless you know what you're doing it, never use a git reset, okay, which is not at all recommended option. I believe that everybody is clear now as well with the git reset. It is a very dangerous command. It will leave no clue that you did delete something in the repository, which is not at all acceptable. If somebody finds out that, they might fire you even. That is not going to be good. In the local, you cannot do that vanilla. That is comes up, the permission comes up in the picture when you go to the remote. The remote is like your GitHub, right? In the local, it is a developer machine. They can do anything, but something that is updated on the remote server, we'll talk later, where you get the permissions into the picture. The answer is yes, we can. So now we understanding about the various ways we track changes in the local. Now various ways that we can revert some changes in the local of the developer machines itself all the time. That is the logical idea, right? Now, once we understood about these few things, team, now we'll come back here and we'll learn more commands as well. As of now, the quick thing to understand that we understood git init, git add, git status, git commit, git log, git show, git revert, and git reset. These are the various commands we understood. Now, within the local, again, as we see it, the git log team can be growing bigger and bigger. So for example, as of now, I'm seeing only the 4 commits, but say that over the period of time, you might see hundreds of these commits happening in the local, correct or not? Can I say that? Say I'm working on the same project for last 6 months. How many commits that you would see in the same repo? There can be hundreds of changes you made it, hundreds of commits you made it in the local repo. Now it's difficult for you to look at the log history. So we have a way to filter this one. So we can say git log, hey, show me a one-line output. So it will truncate a lot of content. I will show you the simple output. Now you could also see a particular number of commits. Say, hey, show me only the last 2 commits. I'll show you only this one. You could also say that when multiple developers are working, remember the author here, the author Naresh summary, like if multiple developers are working on the repo, right? This is what you do. Now I can also filter it by the author, say that, hey, show me the commits based on the author, that the commits made by only Naresh. It will show you that comments. As of now, it's only Naresh here, but say that if I have 100 comments, only 10 are made by the Naresh, then it will show you only those 10 comments. Now it is even possible from day to day. You can use since, means show me dates from since 15th August or something like that, you can say. So you can say that filter the output of last 2 days only, last 1 day only. So you can have many filter options here with the git log command. All you need is that you just need to know how to use a git log, right? If I say git log -- help, now you see the n number of options, say full difference, you have the various options, right? That you come up. So here you can skip somebody if you wanted. You can since date you mention, after you date you mention, right? You can say since as a filter, you do it until some date, you do it before some date, you do it. Use the author pattern or the committer pattern, you have it. Now you can also grab something from it. So there are multiple options are given to just get that options for you. So just filter it accordingly, because remember, a git log is going to be huge when you grow with your project. There can be hundreds of commits, and you need to know that which commits you want to see, then you filter them. This is one another idea, that how can I filter something with git log command. Any questions on the git log filter commands here? Now moving on, team, as of now, we are understanding that everything is in the local, that every version that is recorded, every change that we recorded, the changes. Remember, team, in this scenario, the whole scenario, now in the local developer machine, say he has a project X directory. Inside it, he actually has the multiple files created, file 1, file 2, file 3, and so on. Now he has a records of each and file, everything recorded as a commit 1, commit 2, commit 3, and so on. This is how you refer to it. Now, this is the logical idea that we're talking about it. Now, when we talk about the way we can share this code with other persons in the sense that, now this is not the only person team working on my project. Now he needs to share the code with other persons as well, which is like, now he needs to work on something called as a remote, right? A remote server is something that is a central server, we call it, where every developer can actually push their changes. A remote server, I'm calling it. In our case, as I told you, we will be using a publicly hosted server, version control server called as the github.com, right? Now, this is the website where you can go and create an account first of all. Then you log into the account. Then you can start uploading, pushing your changes to the above. So this is what we're going to do right now. Coming back here, I'll go to my, say, github.com as the publicly hosted version control server, we call it. Now you could log out team here and then say login as well. Sign out, I do it. Now this is the default page. Now you can sign up, as I said yesterday. Those who do not have an account, just go and sign up. It is going to be a matter of 5 minutes, you do it. Now, once you sign up, you just sign in with your account. Say, I'll do the lead DevOps is my account. Then my account name is lead DevOps and my password. Now, it is also required some 2 multi-factor authentication team. So I have this Auth app. GitHub made it mandatory that you need to have multi-factor authentication. Let me generate this code first of all, and I'll put it. Okay, this is my code. Verifies and logs in. Right now, I have logged in successfully to my account with a multi-factor authentication. That's okay. Like you need an additional passcode to be entered after the password. Now, once you log in, team, I mean, you might see an empty page because the first time you log in, it will be like completely an empty page. You will see it. Now you can start creating a project here, just like you did in the local team. You initiated project X directory and then do something. Now here as well on the remote, on the top right, there is a search box. Beside to that, this blue color logo, you see a plus symbol. Now there you see an option called as a new repository. Now click on this new repository. Now here it will ask you to create a new repository, the remote repository we call it. Now you choose the name for your project. Say I call this as now whatever the name you want to give it to, you can give it accordingly. Now once you enter your project name, just ensure it is public so that everybody on the internet can see it. Now if you want to keep it private and only to be accessed by you, then you can make it private. Remember, the private is that only you can access it. Public is something that everybody on the internet can access the repo right now. So I'm making it public accordingly. It is giving you some options here called initialize with repository with something. Don't choose anything as of now, right? And I say create repository at the bottom. Now, when I click on create repository at the bottom, now you see that the project X under the lead DevOps is created. Now here it is giving you some options by default. It says that create a new repository on the command line, which is like saying the git init, git add, git commit, right? Which we already done, right? We did these commands multiple times, right? In the local just before. Now, if I add it, something called a git remote add, and this origin is just an alias name for the big URL. Means rather typing that big URL every time, I can type some alias name like this. Now, if I do a git remote -v, it says origin. Remember that origin is just an alias name, right? And then you see the original project address, which is the online, right? Which is github.com, lead DevOps and project X. Now the local knows about the remote, right? Now we can start pushing. The pushing is something like you upload something from local to the remote. Remember that what we have just done here is that we created an account on this one. Under that, I initiated a project X again here. Now this is available on the remote, that is readily available. Now what I have to do is that I need to upload my content in the local to the remote. So what I did in the local is that git remote add. So I told where is the remote first of all. That means technically these two repositories are now connected. Remote repo is connected to the local repo. Now this is when you need to start uploading. Now the developer or the person in the local, he needs to upload whatever the code in the local to the remote. That's where we use something called a git push. Now this is in a way I'm calling as the upload. That's it. Like you upload something into a Google Drive. Now we do something from the local to the remote. This operation now I'm calling as the git push command that we actually can use it. Right, this is the understanding, right? You do it. Now this is the understanding team about what we're trying to do. But before that, there is one more command that it is giving you. Now there is something called as a git branch command. Now I'll explain this branch command team, but try to understand, you tell me what this command is doing. In the local, first I'm running a command called a git branch. Now it shows a name called as master something. Now I'm running a command like git branch -m main, whatever it is here. Copy this and I just now after that I run the git branch again. Now you tell me what exactly happened here. What exactly happened, team, here? Looking at the output, what do you find it? One branch is created. The branch was earlier present here, Nikki. The git branch was already exist, right? So the branch switched to main from master. Is it switched or is it renamed looking like? Do you have two branches or one branch only here? Team, it's a very simple thing, right? You're seeing on the screen. No, it is not a separate branch from the master, right? How do you see, where do you see the two branches here? When I hit a git branch, do you see two of them or one only? Where do we see two here? There is only one thing, right? Assume that now I'm running the git branch command. Does it show you two names or only one name? It's showing only one name, right? When I do a Git branch, if it shows two names, then it is two branches. But there is only one name, which means only one branch. So technically, it is just renaming it. Remember the command here, the branch is renamed, not even updated. The branch is just renamed from master to main. That's it. Understand again, team, the git branch -m command main. When you had initial branch called as master. Now, when I ran this particular command here, it simply renamed the master to main. It is not doing anything. The content will be as it is, like that only. All the log history will be as it is only. The git branch -m command is just renaming the branch. In a way, it's modification of the branch name. That's it. Now, why would I rename it? Why would we rename it? Can I use master itself if I want to? Yes, team. Can we use master only instead of main or not? What do you think, team? Can we use master only instead of main? Why should I rename it? There is no necessity of renaming, team. Remember, the only thing is that a lot of people says that kind of the master slave words, right? People use offensive words. People feel them as offensive words. That's the only idea, right? So Git wants you to rename the branch if you are feeling the master as offensive word to you. That's it, right? There is no necessity of renaming the default master to the main until unless you do not really want to use a master word and you feel that word is an offensive word, right? That is the only reason here. If you want to do it, do it. You can keep to the master itself if you want to. That's also no question about it. Am I clear, everybody? Am I clear, everyone? Okay, good. So keep that in mind. It's not mandatory that you run the command, but I'm just showing what it is doing it. Okay, great. Now the last command, it says a git push, right? Now that is where, team, we talk about now. I do something called a git push. Remember again here, git remote that we know already, added. Now if I do a git push origin. Now what is the meaning of origin here? Basically, origin means that this origin is referring to this particular URL. So remember, whenever I'm saying origin, I really want to go to this. That is what the idea. We just, instead of typing this big URL, I'm using an alias name. That's it. And I say main. The main is again a branch that will be created on the remote, like you have a local main branch. Remote main branch will be created for you, right? Now I'll do hit. Now say that lead DevOps is my username. And can I use is the password? The answer is no here. Now you see that it is expected here, as you can see clearly. If I'm trying to use the username as I used in a browser and also the password that I used in my browser, it says that support for password authentication was removed on 2021 August 30th. Now, if it is not accepting the password, then what should I use it? Right? Now that's where the Git asks you to, or a GitHub asks you to create something called as the personal access token. Now that can be used as authentication for your GitHub from the command line. Everybody, whoever is performing a git push, they always have to, they always have to use something called as the personal access token, which is recommended, right? Now I'm just sharing some document, team, here that you can refer it. How do I create a personal access token, which is very much important. Oh, it will load. Yeah, now you can see this, right? Now I have created a document on how to create it. So how to create a GitHub personal access token to push Git repositories from the local machines. Now that's where, as simple as that, you need to github.com. Of course, you need to sign up. So there is a sign up process as well here. If you already have an account, log into your account, right? Now, once you sign into your account here, this is what you see. Now, once you see it, on the right corner, you see your account settings, right? You need to go to your account settings. You can open up this browser, team, in the browser if you want to. I'm pinging in the chat window as well, that you can see this. Now, this is where it says you go to a developer settings, and then you have a personal access token option. Then you need to generate a new token and then say that you're done with this. So let me show you that on the project X right now here on this one, on the right corner, right? This is what you see. And beside the search box, there are a few options. There's a right corner. Now you see that the account settings, my personal account settings here. Now there is a settings option. So right click and open a new tab. So I'm opening up my account settings on the separate tab so you can see them. Now here on the left menu, you see that technically on the bottom, the last option is called as the developer settings. Click on the developer settings. Now, once you click on the developer settings, you see some option called personal access tokens. Click on that and say there is a token classic. There is something called fine-grained tokens, which is a beta, which is still in the development phase, so don't use it. So we go for the token classic here. Click on the token classic. And on the top, you have something called generate new token. Click on it. Again, you see the token classic. Click on it. When I click on it, it says that new personal access token. Now you enter a name, whatever the name you wanted. Say it is going to be iPad December 26th batch, right? We started on. Now you can mention this token is valid for how long? Technically 30 days, maybe 60 days, 90 days. You may enter the custom value, or you may set no expiration. Setting to no expiration is strongly not recommended. Don't do that, because to secure your account, more better ways, better you set an expiry always. So I'll do 30 days only, not more than that. Now, once you set up your expiration, the token that will be generated will automatically expire on Jan 27th for me, so that I have to regenerate a new token to apply it. Now, what do you want to do with this token? You can select everything so that you get a full privilege right now. Don't worry, we just need a full admin rights with that account. So I'm just selecting all these options. Sometimes you may give a restricted access to your account with this token as well, something that can be done. So I'll do this, select, since this is my own account team, I'll be an account admin, that's okay. And generate a new token here. Now, once you generate a token, you see on the top, it says this is the token actually. Now on the above, you also read, make sure to copy your personal access token now. You won't be able to see it again, right? That is very much important. So I'll copy this. I'll make a note of it here in my notepad, right? I'm doing it. Now, once you do it, remember team, if I go back from this page again, you will not see that. So if I go back to the personal access token, you see that it is available. But if I want a token of the same thing, I have to regenerate a token. You can't see the same exact token you copied just now. That has to be regenerated. It will be a new token again. So make sure you copy it or regenerate token whenever you want it. That is something. Now, once we're done with this token creation thing, that is what we did, which is very much important. Now, once the token is created, the next thing is that you need to push from the local again. So git push origin main, and I say lead DevOps. And instead of password now, you use this token as a password. Copy this and enter it. Now it will be non-visible team, but it will enter. Just hit enter. Now you see that it is successfully published to the repo, right? To validate it, go to the remote repo and then refresh it. Now you should see the content which we have in the local, like 1, 2, 3 files, as well as the 4 commits. Remember, we talked about the version history, which is like every commit will be available on the local as well as remote. So here in this scenario, we're seeing that technically, hi there, how are you? The files modified everything, right? That you see it. So this is the logical idea team. How now this is called as a distributed version control. You see the source code files available on the remote, as well as the commits available on the record. The version record history is available. The same thing is available in the remote as well here. The command to connect was git remote add. This is a git remote add origin, and this is the one you do it. Okay, that will be given to you by the git remote itself once you initiate a repository on the new on the github.com, right? Right. So this is the logical idea that we have now successfully understand that we have now successfully uploaded something from the local to the remote. And it is a regular practice team again, whenever developer makes a change, that will stay connected. You don't need to do anything always. That every time you push it, it will automatically refer that. So once we add something, it will be permanent. Now, like if I make a new change, hello.java here, the same process to be repeated, git add. You need to commit in the local first of all, hello Java, right? And then once there is a new commit made in the local, now remember that origin main is your remote main branch. It says only this much available. The local main branch having one additional commit here. That is what it is showing to you. Now, if I want to sync them again, I will do a git push origin main. That's it. Then you enter your username. Repeat the same process every time there is a change made by developer, right? It will upload again. Go back to the remote and check if you have a new file uploaded, new commit entered here as well. This is the regular process that a developer or even a DevOps engineer, whenever they change in the local, they will keep pushing the changes to the remote accordingly. Make sense, everybody? Am I clear? Right, so this is the logical idea. Now assume that I made one more change. Say I modified hello.java, right? A new code added here, something, some text I'm writing it, save it. You may add multiple changes as well, 2 or 3.java. Hello there as well. Something like I'm modifying multiple files as well in the local git status. Now the developer will again do a git add, git commit -m, say that new code, and he will do push again. Now every time he updates something in local, he will have to push the code. Git push origin main, enter the credentials again, lead DevOps, and the passcode will be like this. Enter it. Now it will be pushed again. So this is a regular practice team that whenever developer wants to update the local content into the remote, he will add commit in the local, then he will update to the remote. So the new code added here, the files get updated directly on the remote without you doing anything. Hello there, the content is updated, right? If you want to see the commits, technically you can go to the commits. Just below this code button, there is a commits available. Go to the commits and you want to see this commit, what all the changes made. So I'll click on this commit. And I will show you that, hey, there are two files modified, which is the 3.java, hello.java. Now it says that, okay, this is the new line added in the 3.java file. This is the new line added in the hello.java file. That we can clearly see what is that exactly modified on the remote server directly for you. So this is how you can review the changes on the remote whenever something is uploaded by somebody. Right. Is there any way that it will not ask for passcode again and again? That's a good question, Nikki. Yes, we can do that. What I can do is that you can ask git local to store the password that you entered once, so it will not ask you again. So that I can do with some command called as git config. I do it. There is a command called as the credentials, right? .store. Just give me a second. Is it the credentials.store only? I'm just checking the word team. The word needs to be exactly the same, otherwise it will fail it. Get right. The word has to be exactly the same thing. That is the only thing I'm trying to do. Oh, it's not credential.store. No. It is not credentials.helper actually. Credential.helper. Asking the credential helper to store my password. That's it, right? Git config, credential helper. That is a store option. I'm doing it, setting up here. Now, what happens is that technically, now if you have to enter one more time, that is what it is. You need to do it because you just added the configuration. You need to one time enter it, then it will store it. So let's do something here. Touch now .java, git add dot, say git commit -m, say now. Now this time, if I do, it will still ask me git push origin main that I do it, because this time it is going to store right now. Once whatever you enter right now, it will get stored. For the next commit onwards, it will not prompt you for these things again. Copy this, enter it. Now this time, assume that it is stored your credentials. Now, if I go and make some change again, say vi now.java, right, testing the credential, right, store. I'm just adding some technical, that's it. Save it. Now you need to add it again. Git add dot, git commit -m right now, right? And this time, if I do a push, it should not prompt me for the username or password, because earlier we did, it will store it. So git push origin main, done, right? Without entering that right now, it is able to push it, right? When I do a git push here, it didn't even prompt me for it. It picked up the credentials we stored it earlier and able to upload the content to the remote. Okay, this is something we can do it. We do have multiple other methods. The easiest method is to do this, right? The other approaches may take a long time to understand. So the easiest approach to store your credentials here, this is one thing you can do it. Okay. So this is the understanding team that you can see it technically, how the things get updated and everything that we can do here. Make sense, everybody? Again, any questions here? Okay. So now team, as we understood about how do we keep pushing the code from the local to the remote. Now assume that as of now, this is the only one developer you see in it. For suppose now there is a second person is coming into the picture, or the third person, the fourth person, something. That is what we wanted, right? So we want to replicate like when multiple developers working on the same project, now how the things will be. So this is what we want to do. So assume that the other person coming up into your project, now he has his own laptop again, of course, the desktop or whatever it is. Now this is considered as a VM or a server again, what you want. Now in this scenario team, remember that they might also have certain operating system, and they should also install the Git client. Install a Git client software, which is mandatory on other developers' laptop as well. Now, assuming that team, to replicate this scenario, I'll show you something on my local. Let me split it. Now, remember that the left side team here, this is my Linux system. That is the remote one you have it, hostname CTL, I see it technically. This is my Ubuntu server. Now, on the right side team, this is my Mac. Remember, this is my local Mac operating system terminal. Like you have a command prompt in your Windows machine, the Windows machines is still. Now, as we know that Git client can be installed on the Windows or Mac as well. Now, in my local team, I already have the Git installed, so I'll show you a Git client. Assume that I'm working on a Mac machine right now instead of Linux machine. The commands would not worry, anything will not change it. That I have the Git client installed here. Now, the question here is that the second laptop or a second person is ready to start work with it. Now, this person has nothing inside. Now, right now I'm in this one. I want to go to maybe to the directory here. Now, I'm just choosing my own path team where I want it. I have something, so rm-r stuff. So assume that I'm in this path right now in my local, and there is nothing in my local, nothing in the second developer laptop. Think about it. Now, this guy needs to download the code from the remote, right or not? Can I say that? Now, the second developer need not to start from scratch here, since he's joining in the middle of the project here, since that is already available on the remote. Now, this guy needs to download something from the remote to the local. Can I say that, everybody? Now, how this person can download something from the remote to the local is the question. How can he get it, everybody? How can the developer 2 get something from a remote or everything from the remote to the local? Pull, fetch. There is one scenario here that the developer 2 has nothing in this local. Nothing in his local. That is what you do. Pull, no. So then it is clone. So the answer is that first time when you have nothing in the local, understand here, this is where we need to use a command called git clone. Now, when do I use git clone? When you have nothing on your local machine, always do it, right? So remember again, the git clone will get all the content, right, from the remote server to the local, which is the laptop server, basically. That is the idea. So this is what you need to do it. Remember again, a git clone is to be used when you have nothing on your local machine, local server. That is where I have nothing right now here. Now what I can do is that you need to take the repository URL on the remote, which is like the code button I do. There is a HTTPS, and copy the URL and come to the local, and I say git clone and this one. Now you have to do this, remember, always try to do it. Now when I do a git clone, it automatically creates a project X directory for me. Now goes inside the project X directory and also does the git init for you automatically, right? So it gets all the content, including the .git repo, which is the local, it creates a .git here, right? So it is getting all the content from the repo. It is also getting the log history from the repo. Like you see, all the commits made by the Naresh has come up here, right? Can you see that? All the commits made by the Naresh has come up here. So far, the left is the first developer, Naresh. He made some changes and did everything. That is what the idea is. Correct or not? Now, once he gets the repository in the local, that's it. Now, let's say that this person would configure his name. So git config user.name. Say this person name is what? What can you keep it? Kumar something. That's okay. I'm keeping it something, right? Now user.email, right? I say that kumar@gmail.com. So assume that this person needs to configure his username so that technically Git records every change on his name itself again. Now this person got everything, including the source code, including all the log history. Now the same thing is available on the developer one machine as well. Remember ls-l. You see the same files, you see the same log history that you see that. Technically, this is why it is called as a distributed version control system. The version tracking history, the source code available on both developer machines right now, and also on the remote server as well. So technically, this is how it is called as the distributed version tracking system, right? I believe that I'm clear here again. If you have any questions, let me know. Until this point, we can discuss. Now that everyone should be clear of what is called a git clone, or when should I use a git clone here. So if you're all good with this team right now, there is one more thing. Now, assuming that if the developer 2 is making a changes, like Kumar, let's say that he creating a file, kumar.java, git add, he does the same thing again, git commit -m, Kumar code here. He committed in the local. Now what he needs to do, he needs to push as well, remember? So git push origin. Remember that he already got from the remote itself directly. So the remote is already configured in his local automatically. That you see this, right? Now technically, if I do a git push origin main, now it is trying to take my default credentials. Team, don't ask me like how it happened. I configured previously that it's taken already. So assume that it is actually taken and it is uploaded into the remote technically. Now you see something is updated, which is kumar.java, technically uploaded by the developer 2. The new commit has come in. Now, what exactly is missing on the developer 1 machine here right now? Yes, team, what exactly is missing on the developer 1 machine? It is the latest change made by the developer 2, right or not? It can be something like kumar.java, or the new commits made by the developer 2 is missing it. Now, how he get those changes right now? Developer 1 needs to get those changes right now from the remote. to the local. How does he do? What does he need to do is that simply a git pull command. Remember, I'm saying that clone does not work here, Vishnu, again. Remember, because developer one already has everything except that one file, right? Everything else is available. The git clone is to do everything, you get it. Remember again, as I told you, that git clone will get all the content from the remote server to the local, and you have to use only when you have nothing on your local. But let's say that developer one already has a project X directory, all the code is available, all the commits are available, except the latest change. The difference is only not available. This is where we need to use a git pull command. I'll say git pull origin main. Now that will get only the change available. The differences from the remote to the local, now you get it, and it will be added to the local here. There you can clearly see right now that kumar.java is downloaded to the local, and also the log history gets updated as well. Git log -one line. So this is the one, right? If I want to see that it is actually done by the Kumar only, say git log -one line. Now -n, last three commits show me. Sorry, one line is removed. I just want to show you the author as well, right? So if I do, now you see that the last commit was made by the author called Kumar. Previously, it is Naresh was doing it. So you can clearly see that who made the changes on the servers like this. So remember again, a git pull command is something to download the changes itself. Now we can do some more command called as to do it. The developer one here is doing something called a git pull, right? What is this? It's a git pull. Now, what is a git pull understanding here? A git pull to be used, right, when you already, right, have a project in local that is on your laptop, right? Remember that git pull gets only the changes, right? Compare and gets the changes, right? Git pull compares, right? I'll say that git pull compares the local repo with remote repo and finds the differences, right? Finds the differences and get the differences only to local. Differences only to local, basically. That is what the idea you need to understand here. So the git pull and git clone difference is that only, team, remember. Git pull is to be used when you already have a project in the local connected to the remote already, and compares the local repo with the remote repo, finds the differences and gets the differences only to the local when you do a git pull. So these are the 2-3 operations that everybody should be aware of here. What is called a git push? It is like updating, uploading the local content to the remote. Git pull is like downloading something from a remote to the local. And similarly, the git clone is like also downloading something from the remote to the local, the whole content or a partial content only. That is the differences. We have it here. So I believe, team, I'm clear on these commands of git pull, git push, git clone today, and how do I help create a repository on the local as well as remote, everything, what we practiced. So in this scenario, team, what I'm trying to give you, like whatever we have done today, all these commands, whatever we have done, for example. Oops. Yeah. Now, these are the commands that I executed today. Now, I have a habit of sharing these things on the Git Google Drive every day. So go to the Git. I have a class notes document here. Now, take out it. Whatever I have ran here, I've just updated. So I wouldn't asking you, all of you, to go here and then start practicing them. This is one thing where you can find the class notes, whatever the exact commands that run in the command on the command line or class notes. The second thing is that I also gave you this repo. Not sure how many of you are looking at it. This is part of your Git Google Drive itself. But otherwise, I'm giving this Git repo called labs, where you see a n number of lab material, the advanced material, if you're interested in practicing additional content than what we're discussing in the class actually, then you go with this repo. For example, in this repo right now, we can go to the Git as this one, or a Linux also available here. If you're interested in learning the Linux advanced content, go with this. If you are talking about the Git right now within the Git, I also have the installation instruction, how to install a Git on different OS technically. And here I do have some scenario-based execution. So working with Git local that you can see. Now this gives you a scenario-based execution if you're interested in. Say that create empty local repo, add some files, modify, then add Git and staging and commit them. So the solution is here. Like what are the commands, and explanation to that command is given as well here. So use this one team, which will help you in practicing the things in a better way. This has many more scenarios which we haven't discussed yet. We will discuss them as well accordingly. There is also a document about working with Git remote as well, like Git push, Git clone, everything we have it here. So try to use these things as well. I hope these things would help you, team. If you have any questions again, please feel free to let me know. We can talk for today. Otherwise, we will meet again tomorrow with more content on the Git itself. And then how Git actually gonna track those changes, whatever I'm making it, with the help of the various Git commands. That's what we understood, right? So we try understanding about the Git init, right? Git status. Then we say Git add, Git commit, Git show, Git reward, Git log, right? The various commands that we use locally to manage the changes or record every change that the developer wants to make sure it is recorded, and so that it can be referred later. Now that's what we tried doing a team yesterday on the local first of all with the various commands. That's what we were learning, right? So this is the understanding, right? The various commands that we went through, and then we were able to understand on how these changes done by a developer to particular files in a project are being recorded by the Git as a history, so that those changes can be looked into later anytime we want it. And also, if you need something to be reverted, deleted something, we also understood about the way we can revert the changes with a git revert and a git reset commands as well in a high level. Now we understood about all these things, team. First of all, how do we work in the local? Then after that when the developer wants to share the changes with other people in the team, or maybe some other people to deliver the code, it is always necessary that he has to upload into the remote server. The remote is the centralized server where multiple people, multiple developers can collaborate on a single project easily without any confusions. That's the reason we need it. So we went to the github.com as a publicly hosted version control server, because hosting this version control server on a remote servers needs a larger capacity of the VMs, which we don't do it, right? We took something publicly hosted and we're trying to experience how it will look like in the real time as well. So we took the github.com as an example. So we went there, we need to create an account. Then once you log into your account, you can have a project created again. Now, once a project is created, we linked the local server to the remote server by using something called a git remote add something, right? We said to the local, hey, this is the remote server where you need to upload or push changes whenever you're done, so that other people can look at this place to your changes as well. That is what we told. Now, once we did add it, then we tried pushing it. That is the understanding, git push or anything. It's like whatever the local content we have it, including the commit history, like the recorded history, is being uploaded onto the remote server here like this. Now, once every change is being pushed here, right, so that multiple people who has access to this particular place again can be seeing the same repo. And if they have to contribute work towards the same thing, they can start working as well. That is the logical idea. So initially we understood about how to create this and how do I push from a single developer into the remote. Now, once we understood that particular thing, team, right, we also understood, team, as part of this process, we also understood about how do we authenticate while doing from the local, which is like a git push. So when you are doing a git push, it might ask you for the username and password. The password that you use on a browser may not work. So we understood about how do we create a personal access token, right? So with GitHub team, it is always necessary that you should use the personal access token for authenticating, pushing any changes from the local. That's what we said. So we did know that how to create it using your account settings button, going there. Now, this is what we were discussing team, and then we were able to do everything. We were able to push the changes successfully, and entering that username password every time can be some kind of the repetitive, irritating task. So we said we will store the username password in the local server itself with the help of the Git configuration. We're asking Git to remember the username and password when I enter first time. For the subsequent push commands, they will use the configuration stored inside and then automatically authenticate us. So we use this particular command to store the credentials we pass in first of all, and the subsequent push commands will always go and use the same credentials until unless if they are not changed, the authentication will work for us. That is what we said. Now, once we understood about these things, team, then later we also said, if you have a second person coming into the picture right now, then how does he get something, right? That is where we started taking a second server, like I have taken my personal laptop, which is my Mac machine. Now, where we said we have the Git client installed, everything, but the only thing is that he needs to, get the remote content into the local. I think the history is gone, team. Right, fine. Whatever it is. So the thing is that the developer needs to do is something kind of a clone operation. When something he wants to get everything, as a new person, there is nothing on his laptop. Ensure that he installs a Git client, then he will actually clone it when you have nothing on your local machine, and it will get the content, all the content from the remote server to the local laptop completely, where the folder gets created, everything, so that he can get into the folder and start working on the project, and he push it back again. Now, whenever this person pushes something, like multiple people are updating right now, and assume that they already have certain content in the local, right? That they already have a part content, and then whatever the regular changes that are being updated by the developers every day will be missing in their local machines every time they work. So this is where the developer one, for example, the developer two pushed some changes to the remote, whereas the developer one had certain changes already. Now he needs to get those differences or the delta changes from the remote to the local. To get those changes, we use a git pull, right? Git pull to be used when you already have a project in the local, and compares the local repo with the remote repo, finds the differences and get the difference only to the local. That is the simple idea we said. I think this is where we stopped yesterday. I believe that everyone was clear on whatever we spoke until this point. If anybody has any questions on what we discussed yesterday, on practically whatever we did, just let me know. We can talk about them quickly. If you say that you're clear on everything, then we will move on to the today's agenda. The today's agenda will be understanding something called a forking option. And then we also gonna understand about something called a branching. What are branches in Git and how do we use them actually to work in real life again? So anybody having any questions on anything that we discussed so far, please do let me know. Then you have to revisit the recording, Saravanan. So please revisit the recording. If you're new to the topic, you must go through yesterday's recording first of all to understand some things in today's session. Right, so git remote -v, if you have origin, what do you mean that, Vishnu? When we added, we just added an alias name to the project, right? I said the git remote -v, right? It just gives you the origin, which is the target or online or the remote repository where you need to push the changes, right? So that will just print it. The origin is just an alias name, I'm saying it. So this is what the big URL, instead of calling that URL every time, I'm saying that here I'm using a name. So whenever I refer origin, basically I'm referring to this particular thing. That is the idea. So good, great. Then hoping that everyone is clear now. Now, I believe that to just experiment a quick thing here today, I hope that everyone is created your GitHub accounts. Have you, everybody? Yes, team. Have you guys created your GitHub accounts? All of you? Maybe at least a few of you is done, which is good. Okay, great. Now, because I just want to do this practically, just to demonstrate it. So assume that team, that whatever we are seeing on the github.com here, there are two options. One is to make it public, which means that everybody on the internet can see this project. Like if I ping this project URL to you all right now, all right? So you all should be able to see the same content that is on your browsers. If you open up, you should be able to see exactly what I'm seeing here, right? That is the logical idea of publicly open repo. Now, assuming that team, you already have your account, right? Say that, for example, I'm already having the one of my account team here. I'm just gonna demonstrate something called as a forking option in Git. We will try talking about it. Now here team, I'm on the Google Chrome browser here. I'm having logged in with the lead DevOps as a Git hub account. Now you could create multiple accounts as well. That's your choice. So what I did is that I have created another account as well. So I'm opening up my another browser just to have this one. So I'll open up something called github.com here. Now here team, technically I have logged in as a different account called Nareshwar, or if you want me to re-log in. So let's say that I'll log out something. Now I'll log in here with a different credentials, with a different account. Think about it. So the username here is Nareshwar T. This is my another GitHub account, Nareshwar T, and I see that ensure that team you also need to log in like this if you're not logged in into your accounts yet. Assume that I'm just like you in between you right now, and I'm opening my account. So this is what the idea. So I'm able to log in to my account. I'm believing that you all are able to see the similar thing, but you might be seeing something called, the empty page most of the time, not many things to be there. Now on the other part, team, assume that like one of you right now, I have logged into my account, right? Lead DevOps is the trainer and the Nareshwar is the listener or learner here. We can think about it. So now you liked my project. So the my project or the trainer project is the project X, whatever the trainer made. So he liked it. And then he took to his browser and he opened it like this. No, it is like this one. Now, since it is a public project, assume that anybody can open on a browser. So like this. Now, once you see this team, like the trainer project, you liked it, and you would like to contribute to it. Means assume.
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
That right now, whatever the things we have it, you want to take a copy of it. And remember that you can directly clone if you want to the local, but there is an option here that you see everybody above the score button, the green color button. There are certain option called watch, fork, and start. So if you like the project, you can mark it as a start. But let's say that the fork option here, if you see it, everybody. Now, what is this fork option? The fork option makes a copy of the repository, right? The fork option makes a copy of the repository, right? From the original account, which is the trainer account, into your own account. That is a simple copy. It's like a clone operation only, team, but within the GitHub itself, from one account into another account. That is the main understanding we do it. So say that create a fork. It says that fork is a copy of a repository. Forking a repository allows you to freely experiment with changes without affecting the original project. Without affecting the original trainer's project right now, you can freely experiment by taking the code of the trainer here. That is what the meaning we're talking. So you could give any name to your project if you want to. Now I'll say that create a fork. Now, when I created a fork, as you can see, that it is simply making a copy from the lead DevOps account. Now you see that it looks like the project X is owned by the Naresh. Nareshwar, right? But in this case, there is that hello. Below it says that forked from, which is lead DevOps project X, which is the original repo. From that, you took a copy, and then you are going to work in your account with your own credentials freely if you want to do anything. That is the logical idea we are talking about it, right? Remember again, the fork is a simple copy within the GitHub repo itself, like from one's account into another's account. So this is what the simple option that you had it right now. So Nareshwar T has the project X right now. Product X, and with all the content of the whatever we had in this one, file 2, file 3, and so on, and with all the commits as well. So C1, C2, C3, right, and C4, etc. All those commits have been happened to be copied into the Nareshwar account, just like exactly the same content placed into the Nareshwar account. Now this option is what we are calling it as the forking, right? The fork is the option here. When I click on the fork, you should be able to take a copy from my account into your accounts. This is the simple logical idea. We get it. I hope that you all are able to fork. If you already have the account created, you can do that. And that's what we just see it here. I'm able to successfully fork it. Now the original repo that will come to know that who all have taken a fork. If you want to click on the fork right now, team, you can try doing it. It says one fork has happened on the top, you see. If I go to the fork, no, not this one, right? I need to check the forks who did it. So this is what the idea. If I fork it, now you see some switch to view. I say that Nareshwar has copied the lead DevOps project. This is what the simple idea. It's a very simple thing, Nikki, that I hope you're following it. Not sure if you joined late, but here it is, right? I said you need to log into your account and then open the lead DevOps project, right? That you see that lead DevOps project. This is the actual URL that you can open in your browser. Now, when you open it up on this one, you see the fork option here above the code button. There is a fork option that you see. You just need to click on the fork button. That will make a start. It says that you already have a forked, means Nareshwar is already forked. That's what it says to you. But if you want to make a fork now, you should see the options. Just say create fork at the bottom. That's it. Okay. That's all you're going to do. Just click on the fork option once you open the my project, and then click on the fork option, and then you should be able to create a fork. Now I can see that people started forking it, a couple of you. Like I say that I'm not sure whose whose IDs are these, but say Abhinay, and then say that Vishnu, and I say mix veg. I don't know what is this, right? So Nagarjun and Nareshwar. I see that these many people are taking a copy of my lead DevOps project X right now. They can start working with it. Neha also did right now. Like you see the list of people who keep forking it. So this is the logical idea, team, that people can take a copy, whichever they like it on the GitHub. If you really want to contribute towards it, first of all, you need to take a fork of it. So I believe that I'm clear on the fork right now. What exactly the fork meaning? The fork meaning is that technically take a copy from one. Right. So now I see that most of you are clear. So what's the advantage of taking the fork, right? Again, just think about it. Now, the understanding is that since you own the copy right now, that you can start working with your own things, right? That is the advantage. You see it. Now you need to work on your accounts team, like whatever the account here, which is owned by the Nareshwar T, for example. This is Nareshwar T, right? So this is Nareshwar T account. Now he will be freely allowed to make any change, because remember that, can you push any changes to this account right now? Does anybody have a direct access to push, update the code in my account? Do you think, team? Does anybody have an access to my account here to push it, until unless if I share my username and GitHub token, right? You should not be using that technically, correct or not? So the understanding is that team, nobody except me, which is the owner of this particular account and owner of this particular project X repo, only can push or only can modify, edit anything in this project, right? That is what the default access is given. Now, if I want to enable some more people access to this one, there are two options. Like I said, if you want to put your changes into this repository, the first option is to do the fork option. That is what we did right now, right? Like somebody who forked it, they get a copy. Now, what they can do is that they can make a change on their account because they get a full access in their account and project something here. Now, technically, for example, this guy can take it to local and push it, but let's say I'm just adding from the GitHub itself as an Nareshwar T is adding a new file called create a new file. Beside to the code button thing here, follow it carefully. Beside to this code button, green color button, there is an option called add file. So if I create a new file with a name in the box, say that Nareshwar, right, .txt file, and he is writing some content, say hi there, right? How are you? Some code he's writing it, assume that. Now, once he done the changes, he can directly commit on the remote itself, or you can also push from the local as well if you want to. That is a different case. So this is one. So assume that right now within the Nareshwar project, which is copied from the lead DevOps original project, he copied it and he added some new content or a new code to it. Now, this Nareshwar file is actually missing in this one, correct or not? So does lead DevOps has the Nareshwar file here, team everybody? Do you see it? And nobody sees this, right? So technically, the Naresh or the lead DevOps does not have the content of the what Nareshwar is added, whatever is modified by the Naresh. Now, the thing is that, as I said, now if Nareshwar wants to get these changes updated to the lead DevOps, the other account, the original project. Basically, there are two options here. It means since the Nareshwar does not have access to the lead DevOps project, now he need to propose his changes that, hey, I have added this change. If you like it, you can add it to your original repo as well. Now, this is where we come across a simple concept called as the pull request. Remember, the simple concept I'm saying right now is called as the pull request. Now, what is a pull request? Technically, that Nareshwar is sending a request to the lead DevOps saying that, hey, you pull this change if you like it into your repo, like you download the changes into your account itself. That is where the Nareshwar, on the Nareshwar account, if you see that here, there are options like code, pull request, actions. You see that it is changing it, the multiple options given on the top of the repo, right? You see the settings of the project X, whatever it is you're having it. Now, one option we're saying again is the pull request. The pull request is kind of a request that you can send it to the original repo for taking your changes and adding into the original repo. That is how you do it. So on the pull request tab, I will open a new pull request option. So click on the new pull request. Right now, it will try to compare. Now you see that on the right side, you see that it is the Nareshwar T project XYZ, right? And we talk about the branching a little later. So this is the main branch of it. Now he is proposing the changes into the original project, which is the lead DevOps project X, which is the other account, and to the main. Now it says that you're going to create a pull request symbol. Now, why you are creating it? You need to give an explanation to the original guy, saying that, hey, added a new feature here, something. Now you give some explanation to it and say that create a pull request. Now, when the pull request is being created, remember, when the pull request is being created by the Nareshwar, the lead DevOps get a notification. The owner of this project gets a notification accordingly. Let's say that pull request is given to you. Now, this pull request, the original person will open it up. Now, he can review it. Remember that the create new Nareshwar something, it says that, okay, Nareshwar is actually proposing it. The one opened now by the Nareshwar T here. This is another guy on the GitHub. He opened this pull request, it says. Now this guy will review it. Oh, he will see that, okay, Nareshwar created this particular file. Now he needs to look into the file changes. He will look into the files changed. Okay, this is the file which is changed. This is the content he's proposing to me. If I feel good about it, that I'm okay with this content adding to my repo, I'll say that review it, right? Review the changes. Hey, all good. All good. Thank you. And say that submit the review. Now, whenever the request has been submitted, right? Now you see that there is an option at the bottom that is called a merge pull request. Merge in the sense, now we're taking the code from the Nareshwar account and adding into the lead DevOps account. So it is like updating the code like this. So confirm the merge again. Now, whenever you confirmed it, as simple as that, it is done, right? The pull request is merged and closed by the T. Now, if I go back to the project X here, now you should see that the Nareshwar T file has popped up into the project X, which is under the lead DevOps now. So this is how team we ask users sometimes. Now this forking option is meant for the public open source projects, right? Because when you talk about an open source project team, there will be number of community developers who are across the globe will start contributing it. That's where one repo will be maintained by the original community, and that will be forked by many developers across the globe. They do the development and then finally propose their changes to the original repo. If the original community loves them, likes them, and they encourage the developers accordingly to give us more features accordingly. This is the logical idea, team, that how the changes can be updated from one account into another account using a pull request concept. Now, it is mandatory that whoever it has to be updating from one account to another account, they must be raising a pull request only. That is the understanding you should keep in mind. So I believe now you got the understanding that whenever somebody take a copy, they make the changes, they propose back to the original repo to contribute, right? It's your hand in the open source community that you would like to support the community and then give your efforts accordingly. That is the logical idea, right? So I believe, team, now you understood about two important things in the GitHub, especially which is called fork option and also something called as the pull request option. So what are these two things and how do I understand it, which is very much important. This words you will be hearing, maybe not be the fork option, but say that a pull request option, you will be keep hearing it in the future when you join any organization as well. Right, so I believe, team, a lot of people started forking now. I can show you that these many people have forked it, right, like this. Simple idea. Thank you again, team, that you're experimenting, which is great. So I believe that I'm clear on forking as well as the, forking as well as your the pull request concept here. If anybody has any questions before I go to the next concept, let me know. We can talk about it. Yes, team. Are we all clear on the option of fork as well as the pull request? Any questions on this particular understanding of forking? Looks like everybody's trying, or seems like no response from anyone. Right, so if you keep quiet, team, I have to assume that you're all good and have no questions. Briefly, something, Kumar, again, I'm telling you that if you like something on a public, what you try to do is that you take a copy. Right, so this is what the idea is. So going back to the Naresh again, that if the Naresh likes something, right, this is my account, I'm doing it. Nareshwar has taken a copy from the lead DevOps here like this, right? This is the simple idea. Remember that I see it. You have to log in, Venkatesh. If you haven't logged into your, account, then it will be not coming to you. I hope that you have logged into your account. That is very much important. Okay. Without logging in, you cannot fork it. Now, assuming that again, one more time, I'm doing the pull request, team, try to understand that the one user wants to propose his changes to another user using a pull request. So assume that again, the Nareshwar is trying to modify the file, say narration.txt on the repo, which is already being merged there. So I'll edit it. And he's adding some more code like this. Whatever it is he did, like this. And then he committed the changes here. Now, when Nareshwar again committed some more code here within the narration.txt file, or he may edit some more files as well. Doesn't matter that he doesn't need to edit only his files. He may also modify some other files as well like this. Now he commit the changes of both of them here. Now understand that. Now the Nareshwar made a multiple changes. It didn't work or so this is what it is, right? So technically, the Nareshwar had multiple changes made on multiple, files like this. Now, if the Naresh has to propose his changes, remember, he needs to update whatever the changes made into the original repository, which is the lead DevOps. Now, he needs to send a request into the original guy, right? Original lead DevOps, that's where he go to this pull request option on the top given in his account here. Go to the pull request and he will raise a new pull request here, right? And you will see something. So it is comparing the Nareshwar account, right, with the lead DevOps on the left. I see that, okay, you can send it. Now you're seeing the two changes I'm proposing it. You can give a title, right? New changes, new feature, X something. Then you say create a pull request. Now, when the pull request is created, remember the lead DevOps gets a notification that, hey, somebody raised. Now you see that as soon as I'm doing it, say Nareshwar T has raised a PR. I think Netra also raised a PR. Abhinay raised a PR. Kunj raised a PR. Previously Nareshwar raised a PR. Like you see that multiple people, whoever is in the like that, I'll get a notification on my email. Now I'll go to my account. I'll review this pull request. Like you see it, pull request now available. Now, as an owner of this lead DevOps account, I will have to review them. Now, I'm not blindly accepting your changes, team. I can even go and reject them simply that, okay, I don't like it. You may go and do something. Now, if I want to review any changes, you click on anything that you would like to. So I think I'm doing this KUNG. I'm not sure who is this person, but yeah. Now he modified, he or she modified some code inside the 1.java. We had this content. It says it says added this content. Great. I feel okay about it. So what I'll do, I'll simply review. I'll say, hey, it's good. Submits my review. Now, once I submit my review, I just get an option called a merge pull request option, right? I'll click on the merge and I say confirm the merge. Now, once I confirm the merge, now the changes will be coming back to this particular account here, which is 1.java. See that all the changes are updated here like this. So this is the understanding team again. The pull request allows you to propose the changes from different people into one's account that you are contributing. You are all now contributing towards the lead DevOps project as a multiple developers, right or not? This is the understanding you need to keep it. Now I can start merging the code from different people. So Neha, Sundar, Nareshwar, everything. Right, so great. Nikki also says that, okay, once I merge it, you also receive a notification that your changes have been accepted. That's how it will work, right? So you get notifications, right? So this is the understanding team, what we are trying to do it. Say somebody created a test.java. I'm accepting this change as well. So I get this hi and say review the changes, whatever you wanted. Submit the review and I see the merge pull request option, confirm merge. So I keep approving the changes as an owner, right? As an owner of the original project here, which is the lead DevOps. You want to take a copy and you're on. Now see that the create test.java is done by the Sundar, that I see it. Update 1.java is done by KUNJ something. And there is something create narration.txt by the narration T. Like I see that multiple people are now contributing on the same project here. Like you see, I'm seeing more pull request team. I'll merge them as well later. But if you understood the pull request concept, and it is very clear. So we can now continue on to the next options we can do. So I hope that I'm clear. We did multiple times here, right? So if you have any questions again, please revisit the recording one more time as well and come back to me with more questions accordingly, and we'll talk. Now, this is something fork and a pull request concept that can be used for support by multiple this one. Now you are all also known as your contributors. Remember here, you are all, whoever is giving me the pull request now, that you are all forked it. Now you become the contributors, like I see it on the right side here. Technically, we're talking about it. See, the number of contributors I see it for this project are different people. Contributes from the main, like say Sundar, Kunj, Nareshwati, Alugu, whatever. The different people, how many commits they are actually doing it, that it will give me a report as well, like who is doing more work and on this one, like that. So this is the logical idea that you can see this, how the things works about your repo. The GitHub gives you all those things. So this is the understanding team. Now we have done successfully that multiple developers, multiple people are able to contribute towards this project. So we are all ready to work as a team. That is the idea. Now you understood about the fork option, the pull request option. But again, one challenge here is that now as of now, you see that everybody is adding the changes into a one single report can lead to multiple conflicts as well. Say some people, for example, a couple of people are exactly modifying the same files, maybe like one.java file. Previously, somebody modified one.java file. Now somebody else is modifying one.java file. Some kind of a conflicts can arise. Remember that when multiple people started working on the same repository, right, a same code files basically, there is a confusion will occur. Like, okay, who is working on which feature now? How can I really track it? That is not going to be easy for me, correct? Can I say that? Can I say that, team, everybody? Is that easy for me as a owner of the project now? How can I say that you're working on XYZ feature? Some person is working on ABC feature, some other person is on development. Some people may be developing the same feature, right? Now adding that code into the same repository again can be a duplicate of work as well. Can I say that, team, everybody? Do you agree with me or not? It can lead to a lot of confusions now with this option that you see this, right? With these options that you see it is going to be a lot of confusion. That is what the simple idea. So to avoid this confusion, maybe across the accounts as well, or within the account as well, team, we need to talk about a concept called branching. Now, what is a branching and why do I need branching? Now you can leave the fork option, the project manager right now. Let's say that we're going to talk within the same project as well. Like, how can I do it? So this is what I'm going to do it. Remember, team, what I'm trying to tell you. Now, instead of taking a copy and then you raise a pull request, there is also one option I can give you that I'm not going to do, but I'm saying here that now I can give a direct push access, like we were doing a push yesterday, right? Like a lead DevOps was able to push anything. Say if I make some changes here, git push origin main, that I'm able to push directly. Since it says that there is something on the remote which is not available in the local, it says the rejected, that's okay. But assume that, can I give you a push access here? What do you think? Can you directly push, rather you take a fork, make changes in your account, then propose me changes? Rather, why can't you take a clone, right? Remember, why can't you take a clone, like say git clone into your local, do changes in the local and push it directly to this account itself rather from your account tracing it? Can it be done? Can it be done or no? What do you think, team? No? Yes, everybody, what's your opinion? Just an opinion, right? Yes or no? You can take a clone of it to the local and say you want to push it directly. Some people says yes, some people says no. What's the right thing? The answer is yes, team. The people can clone and then directly push to the same repo as well. That is also another option. But for that, I need to give access to you to push it. For this, where we go with project X again here, the settings of the project X. Now on the left menu, you see that the access collaborators. The collaborators are the persons who have a direct access to the repository. Right, it's asking my authorization code. So let me open up this test verification button. So let it open up. This is multi-factor authentication. Okay. I'll take this and I'll open up. So verify. Now assume that here what I'm seeing it on the collaborators page that you see who has access to this project, right? Now, if I want to have a direct access rather taking from your accounts again, I can also give a direct access. That 0 collaborators have been access to this repository except the owner, nobody has it. Now, if I give you the access, say manage access here, and I say add people, now I can give your ID. Say, for example, I give my other ID, which is the Nareshwar T. So this is my other user, right? So I'm saying that Nareshwar is again going to be a direct contributor, rather he's doing indirectly with a pull request, right? So here it is. Now you see that technically that Nareshwar T is being invited. Remember, it is not directly you added. You need to invite, or as an owner, I can invite somebody to be a direct contributor. So they don't need to fork and propose me the changes. They can directly push into my account. That is what the idea is, right? So again, it is just a request only. Remember, the Nareshwar should accept that right now. That is another understanding. So let me show to you that Nareshwar would get an invite as well, right? Let me open up a new browser and see here. Right, so now if you look into my screen team that I have logged into my Gmail again, which is Nareshwar account. Now you see that on the top, let's say that the lead DevOps has invited you for the Project X collaboration. So if I open up the email, now you see that lead DevOps has invited you to collaborate on the project lead DevOps repository here. Now it says that you must accept him here. It says that you can accept or decline this invitation. That's your choice. If I want to view the invitation, I can see. Now it will give you that, hey, I want to accept or decline something. Say accept it if I really want to do it. Now once accepted, now it is Nareshwar can be pushing directly into this account, right? Remember, if I go and see this page of the lead DevOps right now, it says Nareshwar T is now a collaborator, some other person. Like I can invite all of you team, like add people if I get your ID, so I can start doing it. That is the idea. But again, adding them will be a little difficult right now, so I'm not going to add anybody. So that I just showed you that how do I invite one person at least. And then this guy can actually do something like what? Right? He needs to now go ahead and start, cloning the report to the local and then start pushing directly if he wants to. That would absolutely work for him. Like he needs to use his credentials, remember? He needs to use his own user ID, his own personal access token to push the code into the Git repo, and he will be able to push directly into this Project X without any permission issues. So this is called as the collaborators. The collaborator is a concept that where I can give multiple people access, direct push access or a direct access to a single repository. Now, this is another way of providing multiple people contributing towards the same project. The first option was forking, that everybody can take a copy, make their changes in their repositories, then propose the changes to the original repo. Now, that is going to work in the open source community team. Like the open source projects available on the GitHub will be supported by a community of people across the world. That is there for the community purposes. But within an organization, now within your organization, remember, if I have a development team, now those people do not going to fork it. Like all of those development team, like 10 developers, will be given a direct access to the same project repo, same repo here. They will directly push it. So they don't need to fork it, update it, and raise a pull request like that. It's not that, right? It is like they take the clone of the project, they will make the changes in the local, and they will upload their changes directly to the project with their credentials account. This is another concept in the Git called as the collaborators. The collaborator is a concept where we can directly give access to multiple people on a single repository. Right. I believe that I'm clear on this as well, which is the listing. What is the challenge you see it? That's a question to you, right? What is the kind of challenge? Now you have taken a clone of this and say that I have taken a clone of this. Now in my local, in your local, can we say that we can work on the same file like 1.java maybe? Is there a possibility? Right. So 2 or more person doing the changes on the same file. Thank you, Nikki. Absolutely correct.
at the same time. Now, that can lead to a lot of confusion that why both are working on the same file. Now, there can be a duplication of work, something is happening, so on, so, right? Now, how can I avoid the confusion, conflicts between the developers usually, right? Now, this is where team, the actual concept, the one important concept that comes to the picture called branching, right? What is a branch? Why do I need a branch? Now let's start discussing about a topic called as branching team. How does a branching help in collaborating multiple developers collaborating without any confusions or issues, and then make the software release smoother, right? Now, what we have here again, think about it on the above, which is always a remote repository, which is like a GitHub, right? Remember, this is always a remote server where you have something called as a github.com in our case. Now, inside this one is where you have your account, which is like this one is say project X something. Now, by default team, what we saw so far, whenever we started working on the Git repositories, now we already observed something that there is already a default thing called as a main. Either it can be a master as well, remember. On the remote, you see something called branches main. And even in the local of any developer, say that a git branch command. So you see that it is a main. Now on the other developer as well, say that a git branch, let's say that everybody owns something called the same feature or a same thing called as a main. It means that everybody is actually updating in a certain space called as the main branch. That is what the idea. So this is the single idea. Think about it right now. So assume that everybody was working on the main branch so far. That is what the logical idea, either in the local or on the remote, wherever it is basically. This is what the understanding you have it. Now, once you see this is the main branch and you see that whatever the changes made by multiple developers, multiple people are updated into the same branch can lead to certain confusion. So you see the number of commits are made as well here, right? That are on the only the main branch. So technically team, assuming that now on the master branch or a main branch, I see the number of changes made as the multiple commits, say M1, say that we call it as a C1, C2, C3, and so on. Now, assuming that scenario as well, team, now, can I also say that now once we done with certain amount of changes with multiple commits, can I say that this is actually my one particular version that I want to release into the market? Can I say that? Now, assuming that we are done with certain changes, for example, the scenario I'm talking about it, can we consider that in a Git repository, that multiple commits made by multiple people together, we can consider as a particular version release? I cannot say that each commit is a new version, right? New version of a software release, correct or not? Can I say that, everybody? Are you agree with me or not? Can I say that whatever the commits made until this position, right? Whatever the commits made until this position, all of them together, now I release as a version 1. Can I do that? Say something, Tim. Yes, right? That is the understanding, basically. Remember, it is never that a single commit or a couple of commits we consider, that it is the number of commits made by the multiple developers. Now, once the development is completed like this, then we release this into the market as a particular version. That is what we're going to do it, right? If I want to do this particular 15 commits team, whatever I have it right now, if I want to release this as a version 1, see on the right side, just beside this one, there is a releases option. You see it, that below the code button, there is a side box, there is a release. Now there is an option called create a new release, means I want to release the code into the market. So it says that when I say create a release, it is asking me to choose a tag. If it is not available, say I do it. This is my v1.0 as a tag I'm giving it, say version 1.0, and I'm giving that, okay, we are releasing version 1.0. Now you create a publisher release. Now this means that his team, remember, until the task coding done right now or until now made by the multiple developers, we created a release here. Now the release is ready to go into the market, which is a version 1.0 like this that I do. Remember again, the code until now we updated, the number of commits together. All of them are until this 15th commit, you consider it as a release version 1.0 into the market. So assume that the commits which are made on the main branch right now, we released into the market. Now I'm talking about the concept of branching, why we need it exactly. So I'm taking this and I'm saying that I released into the markets, which means that I'm running on the production server, right? Remember that I'm running my software on a production server where the end customer is using the version 1 successfully. Now, as we are in the Agile model team, remember, we go in an incremental model. So we just released a part of functionality only. Now, after releasing of a version 1 with certain features into the market, then we start working on a different feature development. Say, feature X, I want to develop it. Feature Y, I want to develop it. Maybe it's the existing version may have some bugs or defects. So I need to work on defects or bugs as well. That is reported by the customers. Maybe think about it. Now, when you have certain task in mind, team, like we know in the sprint planning that we plan that when we will release this feature, when we will release this feature, when we will release this particular box into the market. Now, what is a priority item that the client tells us? Based on that, we will plan the release accordingly. Now, in this scenario, for example, the client said, hey, the defects are causing the problem. You need to fix them immediately, and say that, hey, you need to release right by, let's say, the 5th Jan, means there is only New Year in between. The client understood. He gave us holiday, and say that ensure that you release the defects and bug code, whatever it is, fix the issues and release the software into the market again by 5th Jan. Now, there is a bugs which are affecting more. So considerably same way, the feature Y has to be released as well. So he said, hey, you can release the feature Y 15th Jan maybe. I'm giving additional 10 days time to release the feature Y. Ensure that you release by then. And similarly, say that release by 20th Jan. Now remember that the scenario here, he's expecting that feature X and Y to be done by 20th Jan itself together. But before that, you have a feature Y to be released first of all as a priority, then go for feature X. Before that, we have the defects to be released. Now, defects, remember team, the feature X and feature Y is a new development. It needs a full amount of time, maybe say 1 month of time as development decided. Now, if it is that needs a 20 days of time, now, which means that technically developers needs to start work on the feature Y, feature X and defects right now itself, correct or not? Can I say that all these things now need to be started in parallel so that technically?
Just a quick info, guys. Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.
They can achieve the goal by 20th Jan to release all the features plus bug fixes, everything. That is how the things will be planned, team, remember. The scenario would be like a parallel development also can come up in a scenario most of the time where people have to work in parallel. Now, in this scenario, team, assuming that the feature version 1 is done, which is great, fantastic. Now, the multiple developers part of the team, part of the project here, like this one, assuming that they started working. So the target is to release the bugs. So let's say that they connected to the remote. Now, assume that they have taken a copy from the remote as it is right now, I'm telling it. So they are working on the project X in the local, right? And say that they got the copy of the main itself as in the local. Now say that C1, C2, C3, right? And let's say that everybody got the same copy, team, exactly the same copy here, like this. That is the idea. Now, as per the plan, say the team manager said, this is a senior guy, the developer 1, I'm calling it. So he has to work on the defect fixing immediately. So he needs to work on the defect code, especially focused on the defect development. Now, this guy needs some more time. So he's like a kind of a new person project. So say that we will assign him the task of the feature Y development. So it needs more time. So he has more time to it. So technically, the developer 2 needs to start working on the feature Y right now. And whereas the developer 1 start working on the defect, both are working it. Now assume a scenario here that they are working on this default copy of a main itself, even though they're working on 2 different tasks. The challenge would be like this, right? He added some code here related to the feature. So the defect, so D1, D2. Remember that he made the changes to fix the bug in the software code. He committed the changes he made as a certain commits, D1, D2, something like this, that you can see this here. Now, when you talk about this one, he also working in parallel, right? So at the same time, he focused on developing feature Y. So he also made some new code development, existing code changes, and see that he committed certain code as well as certain commits. Now, by default, at the end of the day, everybody starts pushing the code into remote here. So this guy updated feature code, this guy updated defect code. Now, everything is on the same main branch here. Remember that since the feature Y got more time for development, he is not done yet. But certain reason that the developer defect fixing is done on the, or say the 5th Jan itself, before 5th Jan. Now, can I take the code from the main branch here and then release into the market? What do you think, team? In this scenario, that the feature Y code is also available on the main branch and the defect is completed, he also updated everything into the main branch itself. Now, can I take the code from that repo and release into the market on 5th Jan as a defect fixing is done? Now, it might include the feature code as well, right there. The feature code is incomplete, which might fail to work it. That is one another idea. So certain challenges works out like this when multiple developers working on the same strategy or the same thing. Possibility of working on the same files in the local, possibility of merging the code from different features. So technically, as per the released plans, we may not be able to do it properly. Now, how do I avoid this kind of a challenges here in the Git repos? Now, this is where the branching comes into the picture here. Now, what do you mean by branching here? Let's start working. Now, the branching meaning is that now, since we said that, okay, there is one main copy, we keep it, the original copy we are talking about it. Now, assuming that this main copy is a working software copy, which we already released in the market, say there might have bugs in it, but something like which is already being worked on, which is finalized project, right? We already released it. Now, technically, instead of editing any code in this main copy or a main branch, what we say is that we take a copy of them in the local here itself, say that we can create a defect, which is a copy I'm talking, technically looks like a copy exactly, right? It says that a defect, I took it. Now I'm also asking the create another branch, say X branch, right? He wants, say feature Y we want to write early. So C1, C2, C3. So like we have now 3 copies of the same exact code, which is given. Now, what we will ask developers is that, hey, don't touch the main branch now. Means do not work on the main working copy or the main code here. Rather, you take a copy of the defect branch. That is what you're going to do it. See that here, let's say this guy, he takes the defect branch. Say that he might have the main branch in the local as well. I'll take over. So assume that this guy is going to work on the defect branch itself, C1, C2, C3. Great. This is what the idea is. Now, the same way, this guy is asked to work on a specific copy called as a feature X or a feature Y, whatever it is technically. Now, in this scenario, they commit the code in their branch, the copy that took from the main copy, D1, D2. Now, this guy is updating here on the feature one. So F1, F2, something. Some codes is updated like this. Now, whenever they are pushing as well, they update their code in their specific area, which is the defect code is updated on this one, and the feature code is updated on this one, F1, F2, something. This is a simple logical idea. We talk about it. Now, in this way, we have a clear picture now that what is the version 1 less defect code on the 5th of Jan. Is that a clear picture now? That looking at a branch, that a branch is exactly having the code of exactly having the code of v1 plus the defect code only. Can I say that, everybody? That is a simple, logical, clear picture. You got it, right? By simply creating a branch, we have a clarity that what is exactly located where. Now, if you want to release the defect into the market, you can take it and release it here. On 5th Jan, which is very much clear, I can take the code from the defect branch and then release it. No, some people may say that, hey, before you're doing it, let's say that we will merge the code into the main branch so we can keep the main copy untouched again. So since it is working now, defect is fixed, we push the code, or we request this one again to update the code, D1, D2. Now, once I do it, I can take a main branch itself and release it as the version 1.1. As a defect fix, you need to move the version up. So we say that 1.1 released into the market as a defect code on the 5th Jan. So now later, this guy is still working on it. Maybe it's still in the progress, right? He was maybe committing more commits. F3, he will keep updating here. F3 something. Now, once he done, before he updates the code back to the main branch team, first he needs to take the code here, right? Say from the main branch, he needs to update the code to the local first of all. So he will update the code as D1, D2. Now you see that it's a clear picture again that in the feature Y branch, I have the version 1, which is C1, C2, C3, defect, which is the D1, D2, and also the feature related code ready by the 15th of Jan. Now I can take this code and release it, or you can follow the same approach. I'll merge it back to the main here, right? Which is going to be F1, F2, F3, and release into the market again. Now, this is the logical idea, team, that why a branching or how a branching would help in making cleaner picture when multiple developers are working, what work they're doing it, and how they can be segregated by each developer accordingly. So this is just a concept I'm talking about it. This has to be implemented practically here, right? I believe that I'm clear on the concept wise why a branching is necessary, or as mandatory we call it, with respect to the development. If you are working on infrastructure side team, the branching may not be a big problem, but say that when you are working on a development projects, the branching is one mandatory concept that everybody uses. Okay. Am I clear on the concept wise? So can we implement this practically now? The first thing is that we need to know how these branches are being created, where the branches are created. Should I create a branches in the remote or local? Now, it is recommended that since we are talking with Agile, as part of the sprint planning meeting, remember that we plan that what a client wants in the next 2 weeks or something. As part of the sprint planning, the team manager or the team leader who has access to the project at the admin level, they will do this one. So this is what the idea. So on this particular thing, let's say that on the remote itself, now let's say that technically you go with this, right? So this is the main branch. Now, if I want to do this, I can create from here, or I can say that from the dropdown, I say view all branches. That I see right now only the one branch here made, but I can also see something called view all branches. If I click on that, I will go to the branches page here. Now, in this scenario, you see only the main branch available. Okay, so let me answer your question. So if we release the bug fix and the new feature at same time, how can we manage? You can merge the code from the, if you want to make them a separate release, you need to create a separate release like we did, right, Sundar? That's all we're going to do it. If you want to club both of them, then you have to test it separately, merge all the code into the main branch, and make a release of them. If you don't want them to be, say that first I merge my defect code into the main branch. I create a release here. I mean, to be specific again, as I'm doing it, I have to implement practically to show you. I can create a release after, merging the code from a defect branch into the main branch, create a release 1.1 defect. Now I also want to create a, release at the same time. So I also merge the code from feature branch into the main branch. So both codes are available in the main branch. Take both of them and release it. That's a simple one, right? So the only thing, how you want to keep the histories matters. That's the only thing, right? But otherwise, I can merge the code from either defect and then feature branch at the same time into the main branch. Release the main branch, which includes both defect and the feature accordingly. That's all you can do it. right, Sundar, I believe. So for example, V1, we have multiple bugs, and on multiple bug, multiple developer are working. How code is push or merged main? You create multiple bug branches, right? Simple. Bug one is separate branch, bug two is separate branch, and allocate each bug to a different developer. Ask them to update to that, and then finally push it to the main branch. Okay. It's all about how do you decide to do it. Or if you want to allow the same bug branch by multiple developers, ensure that they're not colliding, right? They need to discuss what they're working on separately and they work on it. As you say, there are multiple bugs. Now you know what is a bug related. So bug one is to fix this problem. So create a branch for that itself. Bug two is about fixing that problem. So create a branch for that problem itself. And then you have multiple bugs. Each developer working on individual bug on an individual branch. Once they're done everything, merge all the code into the main branch. Then release into the market. Simple. That's how people work on usually, Venkatesh. Okay. Is there any other question from anybody? Did I miss, or is there anything that needs to be clear? Let me know, we can talk. Before I start creating the branches, is there any more questions? That's right. It's all decided by the development team how to do it. So what is the question, please? Right, defect code is merged into main. Right, we are ready for the release. Great. Yes, of course, right? When you are releasing a defect as well, you bump up the version, say version 1.1. I need to do that. Whenever you're releasing any new change into the production, it has to go with the new version number only. Now we have a standard versioning strategy we follow. What is a versioning strategy we follow generally? We have a 3 digits, right? So I say that 1.0.0 something, which is like we have the major version dot minor version dot a patch. A patch is like a defect, we call it, right? So means if I'm releasing major features into this one, then go with the 2.0 dot, right, 0.0. If it is a major release, like you're adding n number of features to it, right? Like iOS 16 to 17, you include hundreds of features in it. That's how the major release comes in picture. Now, if iOS is releasing the 17.2.1 something, the one is a bug fix only, right? So whatever the bugs reported by the clients, that will be reported like 1.0.1 something. So they bump up the version whenever there is a patch, which is like a bug fix. A minor release about a couple of features only. Now, major releases like your entire interface is getting changed and you have 100 new features released together, then that becomes the major release for them, right? You change the version numbers accordingly. Major dot minor dot patch, that is what the people will follow. Okay. Every time you do a new release, it's a bug or anything, the respective numbers will be changing it. I hope that answers your question, Venkatesh. Right. So now, give me next 10 minutes, team, before you ask any questions. Let me explain about how to create branches and how do I take them to the local. So let's do that. Now, again, as I said, on the project X repo, the drop down of the main branch, you see it. Now there is only one branch. Rather, you can click on the view all branches here. When I click on the view all branches, it will go to a page called branches. Now, as of now, you see it's only the main branch I have it. Now, technically on the right side, you see a new branch. Now, when I click on the new branch, it says that, hey, you can enter your new branch name. What is the name? Say defect. Now, from which you are copying it, like the main is a copy from the source main version. I'm copying it and creating a new branch. That's it. And it's simple as that. You create a branch like this. If I want to create one more branch, I'll say that new branch again. I'll say feature Y. And again, I'm taking the same copy from the main, create a new branch. Now you see the both branches coming up here like this. Just refresh it. Now you see your branches coming up here, branch, defect, and feature. And if you want to have it, but since the your active branches right now. Now, once I create a branch, if I go back to this as well, like you see, the dropdown will show you the multiple branches, main, defect, feature. Now, if I switch to the branch, like click on the defect here, now you see that you see the exact same code, exact same number of commits available. If I go to the feature Y, the same exact files again, same number of commits are also available. That is the logical idea. So right now, I'm hoping that everybody is clear now about how do I create a new branch and see that we're taking a copy of the main branch itself here. Am I clear? How do I create a branch? The first thing, it is always recommended to create a branch in the remote. Now, once the branches are created in the remote, now the developers to get to the local. Remember that whenever there is a changes happened in the remote team, that you need to check the changes in the local, or you need to download those changes to the local. So what command should I run here? Yes, what command should I run here? Pull, right or not, team? So before that, I can check the git log --- one line as well. That you see that they have the exact same code. So technically, team, right, we just need to do something called as whenever there is a new changes available on the remote, I say git pull origin. I'm doing it, for example, not even giving the main. So whatever maybe the changes on the remote, which is origin for me, where it can be a new branch created, the changes on the main branch, everything you download to the local. So I'll say the main as well if you want to. I will try to tell you, right? Okay, there are certain changes which are available on the things. It is downloaded these files into the local as well. Now, if you want to try with the git pull origin as well. Now, when you pull a team, it comes up with everything almost. Remember, if I say only the main branch here, now you see that it is getting the changes only from the main branch, right? That is not getting anything else apart from the main branch. But if I say simply git pull origin, now the other branches are created, right? It is also getting the data of the new branch, new tag we created on the remote. Now all those changes being as also coming to down. Remember, there is a difference that you do a git pull origin main, which means you're referring that only get me the changes inside the main branch only. Now, if I say git pull origin, it doesn't matter about which branch it is. Get me all the changes happen in the remote, like different branches changes, everything into the local. That is what the git pull origin is for you. The same thing the developer 2 can also do it, say git pull origin. So it will get the changes of main branch as well as this one. I can try the same way if you want. You get only the main branches. But if I change it to origin, now he also gets the new branches. Everything is available here. Now, like the developers, like 2 different developers now came to know that, okay, there are 2 different branches like defect and feature Y are available. Now, these guys needs to work on these branches. So technically, let's say that in the local, the branches won't create by default, though it said like you still see only the main branch here. In the local, the branch needs to be created yet from the remote consent, right? When you pull it, it just says, okay, the branch is available. The branches are available. That information is pulled to you. But if I want to really create this branch in the local right now, using the remote reference, now we do something called git checkout. Now, remember that we are sitting in the main branch still here. Now, I want to check out, say this guy wants to work on a defect only. So he will do git checkout defect. Now, it will tell you that, hey, the branch defect is set up to track to the origin defect, which is a remote defect branch, and also says that you switched to a new branch called defect. If I go on run a git branch now, which is like shows the local branches. Remember that a git branch command here shows, right, or lists, right, all the local branches only. This is the understanding of you need to do it, right? So this is the command. Git branch command will always list all the local branches. Now, similarly, if this guy has to create it, the git checkout I do and say feature Y, means the developer 2 wants to work on a feature Y. Now, this would create a branch tracking with the remote branch technically. So that's what it says to you. Now, again, if I do a git branch command, let's say that this guy has the feature Y, and this guy has the defect. Now, both of them working in parallel now in their local machines, technically, they can start doing it. So now we understood about how to create a branch in the remote. How do I get that branch information to the local with a git pull command? Then how do I create a new branch in the local? By tracking to the remote, which is the git checkout, the branch name that you want to work on always. So this is what we do. Now, once we do it, now the developer, remember team, to be sure again, you are inside the, you're inside the defect branch. You can refer to the star mark, right? The star mark is the reference, you see it. Now, if I do ls, you see the same files. Now you can check the log as well. If I do a git log -1 log, I will tell you all those things, right? So the remote, we have the tag 1.0, origin main, which is a remote main branch, origin feature Y, which is a remote feature Y branch, origin defect, which is a remote defect branch. Now this main is the local branch, and this defect is a local defect branch. We have it. So all of them having the exact same number of commits and same code only. Now on this note, if I start making a change here, say I'm developing a new defect code, say I'm say defect.java. I say git add dot, and I say git commit -m. I'll say this is my diva. Now you may modify one other file, hello.java, right? I say that fixing the defect code here, something I'm writing it, defect related. So I'll write it, save the file, and say that git add dot again, and say git commit -m. So D2 something. So assume that now the developer who is assigned the defect job, he started working and he almost fixed it. Say he done with the work, whatever he has to do it. Now, if we check it, the only thing you see, the difference is that the two new additional commits on the local defect branch only. Remember again, in the local defect branch, there are two new additional commits, whereas the other branches in the local or remote have the two not having those commits. That is what I do. Now, what I can do here is that technically I'll push the code, git push origin. Now remember that the defect has to push into defect only. So I'll specifically mention, say, hey, you update into the remote defect branch from the local, which is origin defect is the remote defect branch. Right now we're in the local defect branch. We are moving the code. I do it. Now that updates the code into the remote defect branch only. Now let's say that here, for example. So if I go to the project X, refresh it. Now it says on the top itself, defect had a recent changes 11 seconds ago. Now you can switch. Remember team here, I don't find the defect.java file in the main branch. If I drop down and I switch to the defect branch, now you should see that the D1, D2 commits we made, which is good, right? I will go back here. Right, the defect branch do have the defect changes which we updated and that are possible, that are present only on the defect branch. As you can see it, the changes are not reflected in the main branch. So have a clarity that the defect branch is good. Now I can go and make a release of the defect branch itself if I want to, or I can actually add these changes into the main branch as well, right? That we can do it. So I hope that I'm clear here, team, that how do I create a branch? How do I get it to the local? How do I work on the branch in the local by switching to it? And then how do I make changes and how do I commit on the changes on the same branch? How do I push those changes to the remote defect branch itself?
Now, the other thing here, meanwhile, the feature may be worked on as well, right? Say touch, remember again, on the right side, we do it. Git branch, I do. That is a feature Y. He is working on feature. So feature one, feature Y.java something. Git, I'm just doing it. Git add dot, git commit -m, F1 something. Now this guy, whenever he done with his work, certain work is done, he will update back to his own branch again. Git push origin, say feature Y. That's all he has to do it. Now he will update it back to the feature Y branch. So the changes are reflected only inside the feature Y branch only. So if I switch to the feature Y, now you see that the feature Y is reflected only here, that it's not present either in the defect or maybe the main branch. So every developer has this segregated, isolated environment where they can upload their changes. But again, the concept is that once they're done with their changes, now their code needs to be updated back to the where the code should be updated now, from the defect or a main branch. Yes, team, where the code needs to be updated. Main, right or not? Agree with me? The code from the defect branch now should go to main branch. Defect code merger in main. Now, how do I merge it here? Is the question. Now, within a repo as well, team, if I want to update the code from one branch into another branch, given a scenario again, there can be a restricted privileges that not every developer can push the code into the main. Remember, in the real time, there would be a scenario that to protect the working copy or a main copy, no developer will be given a access to the main branches, right? The main branch can be protected. The main branch can be restricted with access who can actually update the content there. It can be the owner of the project, but not the individual developers, like as a collaborators, they update to the specific branches. Technically, they will do that. Now, as a developer, given access to this repo to work on specific branch only, but not on the main branch. So that's how we restrict the accesses that can be achieved as well. Now, given that scenario here, that how a developer changes goes into the main branch. Now, each developer, whoever owns a branch or whoever is working on a branch, now the person who's worked on a branch needs to raise a pull request again. As you see, the same concept on the top, it says, defect had a recent pushes 4 minutes ago. Right? It's telling you, hey, you compare and pull request. This is what you can do it, or also just below the code button. Remember, after you selecting a defect branch, there is a code button, you see it. Now below the code button, there is a contribute option. You need to contribute your changes to the main. So this branch is 2 commits ahead of the main. Now it says that open a pull request to contribute your changes to the upstream, which is the main branch. So I can compare before I'm raising a request to be sure that I am sure about it, then I create a pull request. When I create a pull request, say defect changes are now going into the main branch within the same repository. The fork is from a different repo to the original repo pull request, whereas the branches also have the pull request concept from one branch into another branch. That is called this one. Now I'll create a pull request. Once a pull request is created, as usual, I will get notified. The owner gets a notification, and somebody who has access goes to this one, review the changes. The files changed here, defect and hello, right? Fixing the defect here. The defect.java is an empty file that I can see it, which is good. I'm feeling good. So which is 10. The review changes are done still here. Remember, with the branches as well, the review process is a mandatory process. Somebody would review the code before they merge the changes into this one. So all good. Now I'll submit the review. Now, once the submit review, you again get a merge pull request option as usual. So just go and create a merge pull request and say confirm the merge. Now, when you confirm the merge, the code gets updated into the main branch. The defect code actually updates the main branch. So you see D1, D2 are updated into the main branch. Make sense, everybody? Am I clear here about the changes? Now, since the main branch is updated with the code right now, if you are ready to release the defect, what I can do is that I can create a version for this. Say, again, since the defect is done right now, I can go to a release pages, right? Now I can add a draft a new release here. Click on the draft a new release. Now you create a new tag. Say I'm going to create a v1.1. I'll say that 1.0.1 maybe. I'm just doing it. Sorry. Following the standard. So I'm just releasing a bug fix, right? This is what it is. Now 1.0.1, I constraint, create a branch, or create a tag accordingly. And I say that this is going to be release 1.0.1 something, right? Now I draft a new release, publish it. Now, when I publish it, I can go with releases that I have these assets. I can directly download my 1.0.1 code, something like this. We had a release 1.0 earlier. Now the second release we have is 1.0.1, which is just defect release. So that's why I update the patch level, right? Now this is what I'm doing it. Now you can take the code and release into the market. The meanwhile, the feature is still worked on, right? This feature is still available. Feature is still on the development itself. Now here, try to understand here. So this guy is working still. So touch today.java something. So git add dot git commit -m say f2 something. He's still working on it. Remember, that's all he needs to understand. I'll say that a git push origin feature y. And this is what I do. Now these guys keep updating it. Since we are still at the 5th Jan, we still have 10 more days time to update the feature Y into the market. Now this guy is still working. Say feature is still on. So you have one more changes, F1, F2, something. Likewise, you complete the work, right? You complete the work of the feature Y accordingly. There is one thing to catch here, that the defect is already released. Now, can I say that in this feature branch right now, we are missing the defect code? Can I say, everybody? Does the developer 2 missing the feature code? Yes. Agree with me, everybody, or not? Now, does he need to get the changes from the main branch again to move ahead or not? Right? Remember, team, it is also, assume that right now, if I do a pull from the main, say git pull, assuming that I'm ready to release it, the feature code, I also updated it. But the thing is that technically, understand that before I release my feature Y, say the defect was released into the market. Now, either a defect you merge into the main, either a defect you want to merge into the feature. Since the defect is already merged into the main, we can also get the changes from main, correct or not? Can I say git pull origin main here? Maybe, because remember, I'm in the feature Y right now. And I want to do a git pull origin main, which means that I'm getting the code from the main branch and I'll add it to the feature Y. Correct or not? Is that what we want to do? Yes. Is that what we want to do? Yes or not? Technically, yes, right? Technically, before I put my code, before I merge my code from feature into the main branch, it is necessary that you should pull that. Now, tell me something. Now, in my local scenario, after this code, I have the F1, F2. Now, if I get the code from, remember, if I get the code from the main branch, will it add those changes on top of the F1, F2 or below the F1, F2? Try to understand team scenario here. It's a very simple logic we need to understand. Now, the scenario is like this. Now, we had a main branch. Basically, we had certain commits C1, C2, C3, right? Just understand the scenario. We took a defect here, which is C1, C2, and C3 here. That is what happened. Now, the defect here, something happened. So feature Y, I'm doing it. We also had the same copy, C1, C2, C3. Now, meanwhile, this guy is working on it, D1, D2. Means he added some code on the defect. Now they merged it. So there is a pull request is being raised. Now, because of the pull request, right? Defect, I say that defect branch had raised, right? Remember, raised a PR to main branch technically. Now, what happened with the main branch right now? So the main branch looked like this: C1, C2, and C3, then D1, D2. Now, until D1, D2, which is the actual version 1.0.1 release, correct or not? Meanwhile, this guy is working on the feature code F1, F2 something. Now, can this guy directly raise a pull request into the main branch is the question, right? Can this guy raise a pull request into the main branch? Maybe or may not be, right? Some kind of a scenario. Remember that there is a scenario here. Once you took a copy, the main branch is moved ahead. Now it is necessary that you need to get changes from the main first of all into the feature branch. That is the logical idea. Before you update your code into the main branch team, it is always recommended that you should get the defect changes first of all. Even if I want to test my feature, you need to test along with the bug fix only. So this is where I'm saying that the feature Y first should pull the changes from defect or maybe main if it is done into the main already. That is the true, correct or not? Now, given a scenario like this, if I do a git pull origin main maybe, which means that I'm in the local, I'm saying it to local main branch here to the local feature Y branch on the developer to machine basically. Now he is trying to perform something called as a git pull origin main. Remember that in the local feature, he already had the code. Remember the feature Y is already having this code. Now let's say that, assume that after having this code, he's pulling it. Now, how does this one look like? Feature Y, C1, C2, C3, and I say F1, F2, then D1, D2. Can it be like this? Adding the commits from the main branch here to the main feature Y branch now. Will it be looking like this, everybody? The Venkatesh says no. Then how would it be? That's all right. So because he is just downloading the code and adding to the main branch, feature Y branch, why wouldn't it be like that? The only thing is that these two additional changes have to be coming and sitting in my feature branch. That's all it is. Second one. And what about the other people? Do you think is the second one or the right one? First one. The right order will be like this, first of all, right? Say the right order must be like this because must be like this only for sure. That is the logical idea because we released V1 first of all, the V1.0.1, then we are going with the feature code. So the history must look like this, right? History must, right? Say that in my history, the release history must be like this only for sure. But what happens if I just do a pull origin main? Now let's try that, right? Say that here we do git pull origin main. Now let's see what's going to happen here. Now it says that some options for you. Now it says that do you really want to merge or rebase? There are two options it is giving you right now. It is not directly getting the changes into your local yet. Now there is a concept here we're talking about. Do you want to merge or do you want to rebase? It says that git config pull rebase false, which is a merge option. Now git config pull rebase true, which is a rebase option. Now which is the right one to do it? Now it is recommended that team you have to go with a rebase only. If you want the right order, you always have to do a rebase. That is the idea, right? Let's look into this. If I set this parameter called as a rebase true, remember I'm saying that it has to be rebase here, not the merge simply. Now since I said a rebase true, rebase is true, which is like we do like this. Now if I set rebase true team, the simple answer I'm saying it, if I do a rebase, it will be like this. Rebase will do this technically, and the merge will do this. Now, which one should be the right one then? Technically, team, while you're pulling right now, it didn't actually get the changes. It was suggesting that, okay, you are diverged, means that your local feature Y branch is diverged from the main branch because you already pulled it and it's done later, right? Somebody else updated the main branch already. So while you're pulling next time, you be sure that you want to do a merge only or rebase only. Now it is recommended that if you want to be with the sequence of the orders, you must always do a rebase here. The rebase will set the order of the commits properly, whereas a merge will do unnecessary commits or shuffle of the merges out, right? Now in this case, team, if I do this right now again, since I set the rebase to true, this is where I go on do a pull again. Now, in this case, it says successfully rebased and updated references everything. Now, what do you mean by successfully rebased here? The pull only, it is just updating content only, but it updates the commit history properly for you. Now, you see that it moved the D1, D to the bottom, whatever the code on the remote origin main is updated, then it is moving up F1, F2. This is called rebasing it. Remember, whatever is there in the remote will become a base for the changes you made it like this. Now, once you do this, this is when you can actually push it again. Git push origin feature Y. So I think team previous commits did it. Before you pushing it, you actually have to do rebase, right? So that's fine. So now here, now let's say that you're successfully rebased on the remote as well now. Now you can just go and push it again. Now this gets updated back to the remote accordingly. Now you see on the remote as well, the feature Y is going this. Now this is what you do it. Feature Y is updated with the defect content as well as the F1 content. And you can see the commit history as well in a proper way. Now you see everything is done in a good manner. That's everything is good. Now getting back to the situation here like this. Now you can go ahead and again, the feature Y needs to raise a pull request into the main branch now. That can be done by comparing and pull requested. And I say feature Y to the main, create a pull request, which is good. Now let's say that the feature Y needs to be updating it. So feature Y, go ahead. You can review if you want to. Let's say that everything has been reviewed here, whatever it is updated. Good. Now I can go with the conversation and everything. Merge the pull request, confirm the merge. Now this is the concept team that you just need to understand the logical idea, right? Whatever it is now done on the main branch right now. The main branch has the feature code, the defect code, everything is available. Now I can make a release again. So I can go to the releases, draft a new release, right? And I create a new one. I consider this is a minor version because I'm adding features to my application, say v1.1.1 something, right? This is what I do. Something like it can be 1.1.0 as well if you want to make it like so. So this is what happened. Now I say that it is 1.1.0. I'll say that it is my minor release. I'm doing it. That includes the defect already in it and publish a release. Now, this is the understanding team that you keep updating the branch's code into the main branch and you release the main branch into the market accordingly. So release v1.0, 1.0.1 is a patch release. We had initial release of 1.0, everything. Means the only thing is that with this release, we're making that we simply download the code, what we needed for that particular versioning. So this is the logical idea team about how do we work with branches. Create a branch in the remote, always. Take them to the local, then work on the local branch, then go ahead and then update it, right? Go ahead and update to the remote branch, then raise a pull request into the main branch. That is what all we can do here. This is the general idea of how do we work.
DevOps is a set of cultural concepts, practices, and tools that improves an organization's capacity to provide applications and services at high speed. If I talk about what exactly is DevOps, it is actually collaboration of development and operations team. It is more of a cultural shift, which is kind of related to the Agile methodology. And its priorities are resource management, communication, and teamwork. And an organization get benefited by the speed, functionality, stability, and innovation by following this methodology. I hope so it's clear to you what exactly is DevOps. Now, let's move forward and discuss the next question. The next question is, how does HTTP works? And the answer to the same question is, HTTP stands for Hypertext Transfer Protocol, which works in a client-server model like most other protocols. HTTP provides a way to interact with the web resources by transmitting hypertext messages between clients and servers. So, there is an HTTP request by the client, and in response, there is an HTTP response given by the server. This is how the HTTP works. Now let's move forward and discuss the next question. The next question is, what is CI and what is its purpose? Actually, CI stands for Continuous Integration, which is the process of compiling the entire code base every time a member of a software development team checks the code into the shared code repository. Suppose if a team member checks into the code file with a bug, the build gets broken. In this sort of scenario, the other developers can synchronize the shared source code repository without introducing the compilation errors into their own local workspaces. Thus, collaborative and shared software development cannot go forward. When a CI build breaks, it is crucial that a problem is corrected immediately. A CI process often includes a suite of unit and integration and regression tests that run every time the compilation succeeds. If any of these tests fail, the build will be considered unstable, not broken. I hope so it's clear to you what is CI and what is its purpose. Now let's move forward and discuss the next question. The next question is, name 3 important DevOps KPI. And the answer are, the 3 most common DevOps KPIs are, first, mean time to the failure recovery. Then there is a deployment frequency. And finally, we have percentage of failed deployments. I hope so it's clear to you what are the 3 important DevOps KPI. Now let's move forward and discuss the next question. The question is, what is the difference between continuous deployment and continuous delivery? Continuous deployment is fully automated, and the deployment to production needs no manual intervention in continuous deployment. Whereas in continuous delivery, the deployment to production requires some manual intervention for change management in the organization, and it needs to be approved by the manager or higher authorities to be deployed in the production. According to your organization's application risk factor, continuous deployment or delivery approach will be chosen. I hope so it's clear to you what is exactly the difference between continuous deployment and continuous delivery. So basically, if I talk about the continuous delivery, your code is done first, then you go for unit test, then you integrate, then there is an acceptance test, and finally you deploy it to the production. And in the continuous deployment, we have first the code is done, then there is unit test, then there is integration, then there is acceptance, and from acceptance test to deployment production, the test is done automatically, where in the continuous delivery, it is done manually. I hope so it's clear to you what is the major difference. Now let's move forward and discuss the next question. The question is, what are the core operations of DevOps in terms of development and infrastructure? The core operations of DevOps are application development, version control, unit testing, deployment with infrastructure, monitoring, configuration, and orchestration. I hope so it's clear to you what are the core operations of DevOps. Now let's move forward and discuss the next question. The next question is, can one consider DevOps as an agile methodology? And the answer is, DevOps can be considered as in complementary to the agile methodology, but not completely similar. Now let's move forward and discuss the next question. Can you tell me what are the advantages of using Git? So if the interviewer asks you this question, you can answer the major advantages of using Git are data redundancy and replication. Then we have high availability. Then we can discuss of only one Git directory per repository. Moving ahead, you can say something like this. There is a superior disk utilization and network performance. It is collaboration friendly, and finally, it can be used for any sorts of projects. I hope so it's clear to you what are the advantages of using Git. Now let's move forward and discuss the next question. The question is, are Git fetch and Git pull the same? This is one of the most important questions which is asked in DevOps. So you can answer something like this. The command git pull pulls any new commits from a branch from the central repository and then updates the target branch in the local repository. But git fetch is slightly different from git pull. Unlike git pull, it pulls all new commits from the desired branch and then stores them in a new branch in the local repository. In order to reflect these changes in your target branch, git fetch must be followed with git merge. The target branch will only be updated after merging with the fetch branch, where we performed the git fetch. We can also interpret the whole thing with an equation something like this, where git pull equals to git fetch plus git merge. I hope so it is clear to you what is the major difference between git pull and git merge. Now let's move forward and discuss the next question. The next question is, what are the benefits of using version control? And you can answer something like this. The major benefits of using version control are that it helps to improve the collaborative work culture, which means that the team members are allowed to work freely on any file at any time. The version control system allows us to merge all changes into common version. The next advantage is that it keeps different versions of code files securely, where all the previous versions and variants of code files are neatly packed up inside the version control system. Then it understands what happened. Every time we save a new version of our project, the version control system asks us to provide a short description of what was changed. More than it allows us to see what changes were made in the file content, as well as who has made those changes. The next advantage is it keeps the backup. It is a distributed version control system like Git, which allows all team members to have complete history of the project file, so that in case there is a breakdown in the central server, they can use of their any teammate's local Git repository. The next question is, how do you handle the merge conflicts in Git? The answer to the same question is, in order to resolve the merge conflicts in Git, we need to follow these three fundamental steps, and these are: understand first what has happened. It could be because of the same line edit on the same file, or also it could be because of deleting some files, or it could be because of files with the same file names. You can check everything by using the git status. Then mark and clean up the conflict. When we open the files using the merge tool, git marks conflicts the area like this. Then it performs the commit again and then merge the current branch with the master branch. I hope so it's clear to you how you can handle merge conflicts in Git. The next question is, can you tell me some advantages of forking workflow over the other Git flows? And the answer to the same question is, forking workflow is fundamentally different from the other Git workflows. Instead of using a single server-side repository to act as a central code base, forking workflow gives every developer their own server-side repositories. This workflow is most often seen in the public open source projects. The main advantage is that contributions can be integrated without the need for everyone to push a single central repository to maintain a clean project history. Developers can push their own server-side repositories, and only the project maintainer will push to the official repository. As soon as developers are ready to publish their local commits, they will push their commits to their own public repositories. Then they will perform a pull request from the main repository, which notifies the project maintainer that an update is ready to be integrated. I hope so it's clear to you what are the advantages of forking workflow with other Git workflows. Now let's move forward and discuss the next question. The next question is, when do you use git rebase instead of git merge? The answer to the same question is, both git rebase and git merge commands are designed to integrate changes from one branch to the another branch, just that they just do it in different ways. When we perform the rebase a feature of branch onto the master branch, we move the base branch of a feature branch to the master's branch endpoint. By performing a merge, we take the contents of the feature branch and integrate them with the master branch. As a result, only a master branch is changed, but the feature branch history remains the same. Merging adds new commit to your history. Rebasing will create inconsistent repositories. For individuals, rebasing makes a lot of sense. Now, in order to see the history completely, the same way as it happened, we should use merge. Merge preserves history, whereas rebase rewrites it. I hope so it's clear to you when do you use git rebase instead of git merge. The next question is kind of interesting, and interviewers can also give you scenario type questions. Suppose he says, if I want to move or copy Jenkins from one server to the another, is it possible or not? You can answer something like this. Firstly, I would suggest copying the Jenkins jobs directory from old server to the new one. Then we can move a job from one installation of Jenkins to the another just by copying the corresponding job directory. Or also we can make a copy of an existing Jenkins job by making a clone of that job directory in a different name. Another way is that we can rename an existing job by renaming the directory. But if you change the name of a job, you will need to change any other job that tries to call the renamed job. In this way, you can move or copy the Jenkins from one server to the another, and which forms the perfect answer to this question. Now let's move forward and discuss the next question. Now let's discuss the next question. An interviewer can ask you something like this. Can you tell me what continuous testing and automation testing are? And you can answer something like this. Automation testing, as the name suggests, is a process of automating the manual process of testing. It involves the use of separate testing tools that lets developers to create test scripts that can be executed repeatedly without any manual intervention. Whereas the continuous testing is nothing but the process of executing the automated tests as a part of the software delivery pipeline in DevOps. In this process, each build is tested continuously, allowing the development team to get fast business feedback so that it can prevent the problems from progressing to the next stage of software delivery lifecycle. This will dramatically speed up a developer's workflow. He or she no longer needs to manually rebuild the project and rerun all the tests after making the changes. I hope so it's clear to you what is continuous testing and automation testing. You can answer something like this. An interviewer will definitely get impressed. Now, let's move forward and discuss the next question. The next question is, are there any technical challenges with Selenium? So, you can answer something like this, that there are certain challenges with the Selenium, such as it supports only web-based application, it does not support the bitmap comparison, no vendor support is available for Selenium as compared to the commercial tools like HPUFT, and finally, there is no object repository concept. Maintainability of objects becomes very complex. So these are kind of technical challenges with the Selenium. I hope so it's clear to you. Now let's move forward and discuss the next question. The next question is, when should you use Selenium Grid? And the answer to the same question is, it can be used to execute the same or different test scripts on multiple platforms and browsers concurrently in order to achieve distributed test execution. It allows testing under different environments, remarkably saving the execution time. I hope so it's clear to you. In this scenario, you can use the Selenium Grid. Now let's move forward and discuss the next question. The next question is, how will you secure Jenkins? If the interviewer asks you this question, you can answer something like this. The way to secure Jenkins is as follows. First, ensure that the global security is on. Then, check whether Jenkins is integrated with the company's user directory with an appropriate plugin. Then, you can say something like this. It also makes sure that the project matrix is enabled to fine-tune the access. Then, you can automate the process of setting rights or privileges in Jenkins with custom version control script. Then, you can limit the physical access to the Jenkins data or folder. And finally, you can also periodically run the security audits. I hope so it's clear to you how you can secure the Jenkins. Now let's move forward and discuss the next question. The next question is how to create backup and copy in Jenkins. So if the interviewer asks you this question, you can answer something like this. To create a backup, all we need to do is periodically back up your Jenkins home directory. This contains all of the build configurations of our job, our slave node configuration, and our build history. To create backup of our Jenkins setup, just copy this directory. We can also copy a job directory to clone or replicate job or rename the directory. I hope so it's clear to you how you can create backup and copy in Jenkins. Now let's move forward and discuss the next question. The next question is, what is Jenkins pipeline and CI/CD? The answer to the same question is, Jenkins pipeline can be defined as a suite of plugins supporting both implementation and integration of Jenkins continuous delivery pipeline, whereas CI/CD or continuous integration or continuous delivery pipeline consists of build, deploy, test and release. The pipeline feature is very time saving. In other words, pipeline is a group of build jobs that are chained and integrated in a sequence. I hope so it's clear to you what is Jenkins pipeline and CI/CD. Now let's move forward and discuss the next question. The next question is, what are Puppet manifests? So this is one of the most important interview questions which can be asked by the interviewer, and you can answer something like this. Every Puppet node or Puppet agent has got its configuration details in Puppet master, which is written in native Puppet language. These details are written in a language that Puppet can understand and termed as Puppet manifests. These manifests are composed of Puppet codes and their file name uses the .ppp extension. For instance, we can write a manifest file in Puppet master that creates a file and installs Apache on the Puppet agents or slaves that are connected to the Puppet master, which forms the Puppet manifest. I hope so it's clear to you what exactly is Puppet manifest. Now let's move forward and discuss the next question. The next question is, how can I configure systems with Puppet? This is also one of the most important interview questions, and you can answer something like this. In order to configure systems with Puppet in a client or server architecture, we have to use the Puppet agent and the Puppet master application. In a standalone architecture, we have to use Puppet apply application. I hope so it's clear to you how you can configure systems with Puppet. Now let's move forward and discuss the next question. Now let's discuss the next question. It is also an interesting question, and the question is, what is Puppet code dir is? So if the interviewer asks you this question, you can answer something like this. It is a main directory for code and data in the Puppet. It consists of environments containing manifests and modules, a global modules directory for all environments and your hero data. The next question is, name some of the most important DevOps tools. So the answer to the same question is, the list of important DevOps tools are Git, Maven, Selenium, Jenkins, Docker and Puppet. This is one of the most important questions, and interviewer is definitely going to ask you this one. So be aware of it about some of the most important DevOps tools. Now let's move forward and discuss the next question. Now let's discuss the next question, and the question is, how does Ansible works? This is also one of the most important questions which can be asked by the interviewer, and it can be on any tool which you are comfortable with. So here I have chosen Ansible, and you can answer something like this. Ansible is an open source automation tool which is categorized basically into two types of servers. The first is controlling machines and second is nodes. Ansible will be installed on the controlling machine, and using that machine nodes are managed with the help of SSH nodes. Locations are specified by inventories in that controlling machine. Since Ansible is an agentless tool, it doesn't require any mandatory installations on the remote nodes. So there is no need of background programs to be executed while it is managing any nodes. Ansible can also handle a lot of nodes from single system over an SSH connection with the help of Ansible playbooks. Playbooks are capable of performing multiple tasks, and they are in YML file format. So this forms a perfect answer to this question. Now let's move forward and discuss the next question. The next question is, why should I use Ansible. If the interviewer asks you this question, you can answer that Ansible can help in configuration management, application deployment, and task automation. That's why I'll prefer to choose Ansible. This forms the perfect answer to this question. Now, let's move forward and discuss the next question. The next question is, what are handlers in Ansible? This is one of the most important questions, and you can answer something like this, that handlers in Ansible are just like regular tasks inside an Ansible playbook, but they are only run if the task contains a notify directive. Handlers are triggered when it is called by the another task. I hope so it's clear to you what is handlers in Ansible. Now let's move forward and discuss the next question. The next question is, can you tell me the purpose of SSH? So if the interviewer asks you this question, you can answer something like this. SSH is nothing but a secure shell that allows users to log in with secure and encrypted mechanism into remote computers. It is used for encrypted communications between two hosts on unsafe network. It supports tunneling, forwarding TCP, and also transferring files. I hope so it's clear to you. It is one of the most important questions which can be asked by the interviewer. Now let's move forward and discuss the next question. The next question is, what is an RPE in Nagios? So if the interviewer asks you this question, you can answer something like this. NRPE stands for Nagios Remote Plugin Executor. As the name suggests, it allows you to execute Nagios plugins remotely on any other Linux or Unix machines. If I talk about Nagios, it can be helpful in monitoring remote machine performances metrics such as disk usage, CPU load, etc. It can communicate with some of the Windows agents add-ons. We can execute scripts and check metrics on remote Windows machines as well. I hope so it's clear to you what is NRPE in Nagios. Now let's move forward and discuss the next question. Now let's discuss our final question, and this is, what is Nagios log server? So if the interviewer asks you this question, you can answer something like this. Nagios log server simplifies the process of searching the log data. Nagios log server is the best choice to perform tasks such as setting up alerts, notifying when potential threats arise, simply querying the log data, and quickly auditing any system. With Nagios log server, we can get all of our log data in one location with high availability. So this defines the Nagios log server. I hope so it's clear to you what's the answer of this question.
Just a quick info guys, Intellipaat's DevOps certification course is in collaboration with NASSCOM's Future Skills Prime. With this collaboration, we bring you a DevOps course which is completely aligned to the job market. Intellipaat's DevOps course has been carefully curated by top DevOps experts from around the world and after going through hundreds of jobs description for DevOps jobs. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Intellipaat's Achievers YouTube channel, for which the link is given in the description below. If you're looking for a job in the DevOps field and want to become a NASSCOM certified DevOps professional, do check out the course link mentioned in the description below.